So are we live? So can you hear me, students? Guys, can you hear me? Let me know, give a thumbs up or give a hi hello and I'll know that we are live, and then we will start with a brief introduction, knowing each other. And since your exam is also approaching, so you might be concerned what to do and what not to. So here we are with the Maha revision of complete class 11th. Hello everyone. Good morning everyone. Hello everyone. So are you guys ready for the class 11th Maha revision? We will complete all the important topics and we will cover all the chapters and we will do questions as well from each chapter. And you will know what concepts and how to approach the question from that particular chapter. So should we begin? Give me a thumbs up and let me know that should we start with our session and our first chapter, which is your, as we all know, your first chapter that comes is our set theory. So are you all ready with that? No problem. Once if you are from bio, we will start and look at each definition and each concept from basic. Please try to grasp as much as you can. Okay. Once try to focus on the topics that are important, such as matrices and determinants from class 12th. That is a easy chapter if you are from a bio student, if you are from bio background. All right. And also you can go for calculus if you are interested in calculus, because that needs a little deep understanding. So try to go for easy chapters that will help you boost your rank and the score in mathematics portion. Thank you, Manish. Chalo, let's start then. All right. So, as we all know, you all might be knowing now what is the definition of a set. Set is a well-defined collection of distinct objects. All right. By well-defined, we means it is same for all. It is same for all. And what does that means? That means if you say you are picking some elements and putting in a set, then next person will pick that elements only and put in that set. It has no ambiguity or no confusion what you will include in this particular set or collection. And by distinct, it means we never repeat elements in a set. For example, let's say your set is denoted by a capital letter A and you write a set. All right. So if you have a 2, then you will not repeat 2 in this set, because that is a repetition of the same element. By this distinctly means if you have included an element once, you will keep it at once only. You will not keep on repeating it. So this is not a correct way. You will write it just as 2. Once you have included that element will be just calculated or counted only once. And these objects are also sometimes called elements or members of that particular set. Now these are some notations that we generally use in your set. A belongs to A, which means this particular element, this particular object, or this is a member of this set A. And what it means? It means A belongs to A. For example, this is a set 1, 2, 3. All right. So in this I said 3 belongs to this set. Why? Because 3 is a member of this set. 3 is an element of this set. So that's why I wrote 3 belongs to 1, 2, 3. Next, does not belong to. If some element is not in a set, then we write it as does not belong to that set. So A does not belong to A. Since 5 was not in this set, or any element other than 1, 2, 3 is not in this set, so we will say those elements are not a part of these set. Now cardinality is an important concept. By this we denote cardinality. If you put dash on A, that means cardinality, or you write just number of elements in set A. This represents number of elements in set A, and this is another notation for this, and it is cardinality. What it means? Number of elements in a set. So for this particular set, you can see how many elements it has. It has 1, 2, 3 elements in total. So the cardinality of this set is 3. And how do we generally denote our set? Our sets are denoted by capital letters, then they are enclosed in curly brackets. Now whatever elements you are writing here, let's say I write A, then you will separate it with a comma. Next element you will write, then you will separate it with a comma. And same way you just keep on writing whatever elements belongs to a particular set. So what is the way to do it? You give it a name, a capital letter, put an equal to sign, then you enclose all the elements of a set in curly brackets, and then whatever elements you are writing, they will be separated by a comma until and unless you don't see the outer curly bracket and a comma. Till this gap, whatever is written here, that is single element. Then till next comma, it is a single element. Now these elements can be of this form as well. Let's say I can write this as, this is also a set. This is also a set. Now in this, your first element, your element is, now in this, your element is this. This is an element of a set. This is not a set itself. This is an element of this set A. Why? You see, the outer curly bracket, first comma comes here. So whatever is before this, that is an element of the set. Then next also is an element, and this is also an element. You don't see them as sets. You don't see them as sets. These are elements in this set A. Alright. Then these are some standard number sets which we have to know and we have to remember by heart, because these are standard notations and no one will tell you that these denotes what. So n is what? N is set of all natural numbers, and natural numbers are what? 1, 2, 3 and so on. Next, n naught represent what? Natural number union 0, and this is also your set of whole numbers. This can also be written as W, set of all whole numbers n naught. Alright, n union 0. Then Z denotes your set of integers, Q rational numbers, R real numbers, then R plus. If you see a positive sign written in any of these sets, it means positive reals or positive rationals or so on. And C denotes your complex number sets. Similarly, you can write R minus, Q minus and so on. And there is one more set, that is your Q complement. We also have QC, that is your set of irrational numbers. Set of irrational numbers. So this was all about basic set and some standard notations. All right. Then next you have your types of sets. What are the types of sets? Because this is a Hindi channel, this is not a Hindi channel, we are on English channel. You can watch it on Hindi channel as well if you want to. All right. Manish Yadav, that is not a correct set. You don't write 4 twice. You don't write 4 twice in a set. If you have included 4 once, you will never write it again in a set. All right, Manish. Display problem. All right. I don't think there is any display problem in our end. Please look at your end. So first set that is in your type of set is empty set. All right. So empty set, as the name suggests, empty, it means it will be empty. There will be nothing inside it. So no element. And number of elements in empty set, that will be what? 0. Because it is empty, it has nothing. So number of elements will be 0. Then you can see this example. What it says, x belongs to real number and x square is equal to -1. Now we know for any real number, for any real number, we know x square is always greater than or equal to 0. Because if you put 0, it will be 0. Put any negative or positive, square will make it positive. So x square is always greater than equal to 0, but it says it should be equal to -1. So that is never possible. So this is an example of your empty set. Next, singleton set. Again, as the name says, singleton, which means single element. So it has exactly one element. So these are the examples of singleton sets. Now here note that phi is written inside this set. Phi is written inside the curly bracket. So this is not an empty set. This is not an empty set. This is an element of this set. This is an element of this set, and this set has only one element, which is phi. So don't confuse it with this and this. This denotes empty set, single, only phi. If phi is written inside curly brackets, that means phi is an element of that particular set. Then finite set means number of elements in this set will be a natural number, which means number of elements in this set will be finite. For example, this is a set, number of elements in this set is 3. So finite set means a set in which there will be finite number of elements. Then infinite set, uncountable or countably infinite, which means we cannot count how many elements will be inside this set. For example, all your natural numbers, real numbers, integers, or you can say whole numbers, rational numbers, all these are infinite sets because we cannot count the number of elements in this set. Equal sets, what do you mean by equal sets? Two sets are said to be equal. A is equal to B. This is a condition if and only if A is a subset of B and B is a subset of A. So A has to be a subset of B and B has to be a subset of A. Or in other language, you can say all elements of A are same as all elements of B. If all the elements, these two sets are completely same, then we say these are equal sets. For example, these sets are equal. In this set is 1, 2, 3. In this set is also 1, 2, 3. It does not matter in what order you write the elements of a set. In what order you write the elements, it does not matter. If you write 1, 2, 3, 3, 1, 2, or even if you write as 2, 3, 1, all these denote same thing because order in a set does not matter. In what order you are writing the elements. Equivalent sets, it means number of elements are same in both the sets. This just means only the number of elements will be same. It does not matter what elements are they. In equal sets, elements has to be also same. But in this, only the number of elements matter. So 1, 2 is equivalent to AB because number of elements in this set, number of elements here, number of elements in this set, let's say this is A, this is 2, and number of elements in this set, which is let's say B, in this also it is 2 only. So these sets are equivalent sets. Next are your subset. So A is a subset of B. When we say A is a subset of B, when every element of A is an element of B as well. So whatever elements are in your set A, if they are also in set B, then we say A is a subset of B. For example, 1, 2 is a subset of 1, 2, 3. Why? Because 1 is in this set, 2 is also in this set. So every element of this small set should be in the big set. So 1, 2 is a subset of 1, 2, 3. Same way we can have so many subsets. Alright. Then proper subset. What is the difference between subset and a proper subset? So A is a proper subset of B. When we say that A has to be a subset. So definition is what of proper subset? A is a proper subset of B. Why? When if A is a subset of B, that is required because it is a subset. So A is a subset of B. But A is not equal to B, which means A is not completely equal to B. It is just a small subset. For example, this is a proper subset of 1, 2. And if I write this, 1, 2 is a subset of 1, 2. This is also true. 1, 2 is a subset of 1, 2. Why? Because every element of this set is in this set. That does not violate my definition of subset. That clearly says every element of A is in your set B. So every element here is in this set 1, 2. So this is a subset, but not a proper subset. And why it is not a proper subset? Because this set 1, 2 is equal to this set 1, 2. Both the sets are equal. So they are subset of each other. So they are equal, but it is not a proper subset. For proper subset, they should not be equal. Then your universal set. Universal set contains all the elements that you want in a particular context. Which means if you are talking about many elements, a lot of elements. So all the elements, you just put them in a particular set. You call it as a universal set. And it is denoted by U. For example, R for number sets. So for a number sets, whatever number you know till now, for that your R set of real number is considered as a universal set. Because whatever we study mostly everything is covered in number terms in your real numbers. So U as real numbers is considered as a universal set for your number sets. Then power set. Power set, what it says? Power set says set of all subsets of A. So whatever set you have, you take all its subsets, collect all its subsets and make a set with those subsets as a element. For example, you have a set AB, you want its power set. So what would be its power set? Now empty set is a subset of every set. Remember it always, empty set is a subset of every set. So first element is your empty set. Second subset will be singleton A, another subset will be singleton B, and the set itself is a subset of itself. So this is the power set of this A comma B. So this was your set, this is its power set. Then you have disjoint sets. It's not visible, I think. So let me tell you what it is. This is disjoint sets. Disjoint set, what it means? It means intersection is empty. And by intersection, we will see what it means. Intersection is empty means these sets have nothing in common. These sets have nothing in common. So this is A intersection B. For example for this. So example for disjoint sets. What example can you give for disjoint sets? Let's say I have my set 1, 2 and 5, 6. You can clearly see these two sets have nothing in common. They share no common element. So these are disjoint sets. They have nothing in common. So this is what we means by disjoint set. Then next are your set operations. This is your visual representation of all the set operations. Now this complete portion represents your A union B. So you have two sets, set A which is denoted by this circle in blue, set B denoted by the circle in pink. This is your universal set which we generally make with the help of a rectangular box, and then sets inside it are represented by circles. So this is your set A, this is your set B. By union of two sets, we means elements in A or elements in B, whatever you have, combine them both and make the union. By intersection, we means only take common elements from both the sets. So this is your intersection, the yellow colored part. Intersection means whatever is common in A and B both, take only those elements. Take only the elements which are common in both set A and B. A minus B. Set A minus B, what it means? You take set A, whatever elements in B are common with A, delete all those elements and take only the remaining elements of set A. What it means? Take your set A, delete all elements of set B from this set, and whatever is left is your A minus B. Then A complement. By complement, what we means? By complement, which means this is your set A. Complement means remove all the elements of A and take all the other elements that are present in your universal set. So this green color part represents your A complement. What it did? It did what? Deleted all the elements of set A and included all the other elements in your universal set. Then A delta B, what it represents? It represents the symmetric difference. So A delta B is what? A delta B is your symmetric difference. So symmetric difference, in symmetric difference we take A minus B. This is your A minus B. So this is what? This is A minus B. And this is what? This is your B minus A. So in this also we can also see B minus A will be what? This will be your portion B minus A. What does the definition of A minus B says? Delete all elements of B from A and take rest of the elements from A. So B minus A will be what? Delete elements of A that are common with B and take other elements of B. So this is your B minus A. Now can you see some similarity in A minus B, B minus A and A delta B? What we can say? We can say A delta B, your symmetric difference, is equal to A minus B union B minus A. So this is how we can write a symmetric difference in terms of union. This is A minus B union with B minus A. Or there is another way, or what you can say, A delta B is your A union B minus A intersection B. What you do? You take the union. So union will be this complete set. Delete the intersection part. So that will give you this portion and this portion only. So this is how you can represent your symmetric difference in terms of union and difference. So this is your symmetric difference. The next disjoint sets, as we saw, what does it mean? Two sets are disjoint if they have nothing in common. So they will be separated. They will be apart from each other, because if they are together joined, they will have some common intersection part. So these are two disjoint sets. स्क्रीन ब्राइटनेस एडजस्ट कर दो, वो कह रहे हैं ज़्यादा हो रही है. We are adjusting the screen brightness. Wait a minute. Vector will be in your next class, that will be in 12th. Q complement is set of irrational numbers. It is not complex number. Q complement is set of irrational numbers. Alright. Now these are some laws of your sets. The first law of set is idempotent law. What it says, if you take a union of a set with itself, you will return back with the same set. Because you take union of a set with itself. The union, it says, take elements in this or in this. Now these are same, so it will return with the same set. A intersection A is also A. Similarly, your identity law. A union with an empty set. Now empty set is nothing. You take its union with A, you will get back again your set A. A intersection with universal set. Now you are taking a big universal set, you are taking its intersection with a small set inside it, so you will always get the back set, your A set. That is what it says. Now domination law. Domination law says one set will dominate among two. So A union universal set. Among A and universal set, universal will dominate A, and so you will return back with your universal set. A intersection with an empty set. In this empty set will dominate. Why? Because in intersection the small sets dominate, so your empty set will get back as an answer. So next is your complement law. So A union A complement. You take A is your set. A complement says delete elements from A, take from the universal. So when you join these two, you will be always getting back the universal set. And A intersection with its complement is always empty because they share no element in common. Next is your commutative law. So if you take A union B or B union A, it is same. You can take union from any side from A to B or B to A. Similarly, for the intersection, you can take A intersection B as well as B intersection A. That will give you the same set. That will give you the same set always. Associative law. Associative law says if you take union of two sets first, then you take its union with some other third set. That will be same as taking the union of last two sets first and then with the first set. So associative law says you take union in any order, you will get back the same set as a result. And same holds for your intersection. Distributive law. Distributive law is sometimes important and can be used. It says if it is A union B intersection C. If it is A union B intersection C. So first take A union with B. First take A union with B. Then what you see next? You see the symbol of intersection. So put the symbol of intersection. Now you are left with C. But outside it was a union for C as well. So take A union with C as well. So how can you remember it? First take A union B. Move in this way, A union B. Then you see the symbol of intersection. So put a symbol of intersection. Then you are left with just C. But you see, with C also we had a union because there was a bracket. So take A union with C as well. And similarly you can do for the intersection part as well. Now next is your De Morgan's law. This is important. De Morgan's law. What it says, De Morgan's law says, if you take A union B complement. So how you can see with the help of your Venn diagram. So let's say I have my universal set. This is my set A. This is my set B. All right. This is my set A. This is my set B. Let's say this has some P elements. This has some Q elements, and this part has some R elements. And outside these, there are some S elements. You want A union B complement. So what will be A union B? From this, your A union B will be what? Your A union B will be PQR. You can clearly see and easily see your A union B. Take all elements in A and B. So PQR, this will be your A union B. You want its complement. So A union B complement will be what? S. Delete all the elements here. Take all other elements which are in your universal set. So your universal set has elements S. So this will be your A union B complement. Now calculate A complement intersection B complement. Now let's see what is your A complement. So what is your A complement? Now you will delete elements from A. Elements of A were P and Q. You will delete them. So rest remaining elements in universal set are what? R and S. So your A complement is R, S. Now you want what? You want B complement. So see what will be your B complement. B complement will be deleting the elements from B and taking the elements from universal set. That will be P comma S. Now you will take the intersection because it says A complement intersection with B complement. So take the intersection of both. So A complement intersection with B complement. That gives you S. So A union B complement is always equal to A complement intersection B complement. So this is what your De Morgan law says. And similarly you can show and prove it for this intersection part as well. Take this Venn diagram only and prove it for your intersection part as well. Now last is your absorption law. Absorption law says if you take A union A intersection with B, you take this, apply this distributive property, you will be left with your set A. Try this, apply the distributive property, you will be left with your set A. And similarly, for this intersection part, apply the distributive property, again you will get set A. So this complete thing absorbed itself and gave you back your set A. This complete thing absorbed itself and gave your back set as A. Now these are cardinality formulas which is important. Yes, we will do question practice as well. We will do question practice as well. Alright, now these are your cardinality formulas which are important. So this is just a basic union formula. This is also known as inclusive exclusive principle. What it says, number of elements in your A union B will always be equal to number of elements in set A plus number of elements in set B minus you take the intersection. Why we do that? If you want to see why we do that actually. So why we do that actually? So let's see with the Venn diagram. So when you take A union B, when you take A union B means all this portion. A union B means all this part. Now you want to take what number of elements in A, number of elements in B. So when you take number of elements in A, you will see, you will take all these elements. You will take all the elements in your pink color. Then when you take set elements B, you will take all these elements. Can you notice something? When you added number of elements in A with number of elements in B, this particular portion counted twice. Why? Because this was counted in your A as well with the pink color. This was counted in B as well with the purple color. So this common part which represents your intersection, this was counting twice. So So to not overcount, we subtract it once because we want A union B. So to avoid overcounting, we subtract it once. N of A intersection B subtracted once. And similarly, these are your variations of this formula, and these are your other standard results and other standards cardinality formulas. If you have any doubt in this, look at them. I'll explain you, and please ask, look at them, and once try to see how you will have them from this particular formula. Till then, I'm reading your comments. If you want to say something, anyone has to say something, please say. Until then, look at these formulas. If you have any doubt among all these, please ask. So I'm moving on. Next are your cardinality formulas for three sets. Now these are your cardinality formula when you have three sets. So it says again number of elements in your A union B union C. What you do? You just add all the single set elements once, subtract their intersections with each other. So you take pairwise intersection, subtract them, then add the intersection of all the three sets. So this formulas keep on going. What happens if you have four sets now? You will add all the four sets elements. You will subtract all the pairwise intersection. This is called as pairwise intersection. You take pair of two sets, you will subtract them all. Then you will add all the three pairs, add all the three pairs of set. Then you will subtract all the four pair intersection set. So this is known as actually your inclusion exclusion principle, in which you include, then you exclude, then you include and you exclude, and this keeps on going for as many as number of sets you have. Now with this, these are some related formulas. Number of elements in only set A, number of elements in exactly one of the set, number of elements in exactly two sets, number of elements in all the three sets, which is nothing but your A intersection B intersection C. And what it means by exactly one, exactly two, let me tell you with the Venn diagram. So exactly one actually means, exactly one means you have three sets. All right, this is your universal set, exactly one. So you have three sets. So you have three sets A, B, and C. All right. This is, let's say, your set A, this is your B, this is, let's say, your set C. By exactly one set, which means the elements should be in exactly one and only one set. So exactly one represents your this portion. Exactly one represents this part of set A, this part of set B, and this part of set C. So this means these are only in exactly one of the three sets. This, all the elements that will be here will be only and only in exactly A. Elements here will be only in exactly B. And in this, there will be exactly in set C. Alright. Alright, then exactly two sets. By exactly two sets, it means the element should be in exactly two of the three sets. So exactly two sets. These are your three sets again. By exactly two, it means they should be exactly in two sets. So that means this part, this portion, and your this particular portion. These three parts, when you will see this part is in set A and B, exactly in set A and B, in nothing else. So this is your set A, B, C. So this portion will be in exactly A and B. This will be in BC. This will be in AC. So that is what we mean by exactly two sets. And exactly three means all the three. So exactly three will be this particular portion. So this represents your exactly 3 sets. So this is your exactly 3 sets. All right. Chalo. Next come is your counting of total number of subsets and proper subsets. And this is an important formula. This is sometimes used as well. So this is sometimes used as well. So this is an important formula. First is what? Total number of subsets of a set. So if your number of elements in set A is n, then number of elements in your power set is 2 to the power n. And what does power set represents? Set of all subsets. So your total number of subsets is also 2 to the power n. This is also your total number of subsets. Total number of subsets. Then next come up is proper subset. So what is a proper subset? Number of proper subsets are 2 to the power n minus 1. Why? Because the only set that is not proper, the only subset that is not proper is the set itself. So the only improper subset, the only improper subset is the set itself. Because other than that set, every subset you take, that will be a proper subset. So number of proper subset is 2 to the power n minus 1. Then non-empty subsets, we know there is only one empty subset. So number of non-empty subsets will be also 2 to the power n minus 1. Now subsets with exactly k elements. So what does it means? Let's say example, let me do an example. For example, let's say you have a set A which has elements 1, 2, 3 till 10. So your number of elements in set A, are 10. You want subsets with exactly, let's say, k elements, let's say with 5 elements. So subsets, number of subsets, you want number of subsets with exactly 5 elements. So you want all those subsets that will have exactly 5 elements. So what is the formula for that? You take NCK. This is what if you have studied in your combination and in your binomial theorem, which we will see further. This is NCK, the binomial coefficient NCK. NCK, and this is the formula n factorial upon k factorial n minus k factorial. So for 5 elements, what will be your answer? This will be 10 factorial upon 5 factorial, and 10 minus 5 is again 5 factorial. Calculate this, you will get number of subsets with exactly 5 elements. Alright, so this is your number of elements, number of subsets with exactly 5 elements. So just calculate this particular number, you will get number of subsets with exactly 5 elements. Right. So let us come to a question from your PYQ. Try this and tell me what will be the number of subsets B of it such that A minus B will be 3 and 8. So think and tell me the number of subsets B of this set X such that A minus B will be equal to 3, 8. Tell me guys. Try this question, I'm giving you time. Guess what is the answer? Anyone? Anyone, what is the answer to this? What concept will be used? How you will answer this? How we do this? So this says A minus B. A minus B has elements 3, 8. All right. So think, if your set B, what was your set A first? Your set A was 3, 5, 8, 9. Now, if your set B will have 3 or 8, if this set B, think, if this set B has 3 or 8, then after subtracting A minus B, I will not get 3, 8. But it says A minus B is 3, 8. If B set has this element 3 and 8, A minus B will never return me 3, 8. 3 or 8, anything. So B set cannot have 3 or 8. So first thing that I conclude is, from this set X, which is 1, 2, 3 till 9, I know my B set cannot have, let's say this is, all right, let's mention all the elements. Let's write 7 there. So now I know A minus B has 3, 8. If B has 3 or 8, my A minus B will never return me 3, 8. So I know my set B cannot have 3, it cannot have 8. Also, A minus B return me 3, 8, which means the elements 5 and 9. The elements were 5 and 9 which were surely deleted from set A, because A minus B never returned me 5 and 9. So 5 and 9 were surely deleted from your set A. So 5 and 9 are surely in your set B. So 5 and 9 are for sure in your set B. So the restrictions you get is 3 and 8 can never be in your set B. 5 and 9 will always be in your set B. So these are the restrictions. About rest of the elements, you have no further restriction. Now, what are the remaining elements? Remaining elements are 1, 2, 4, 6 and 7. Now with these elements, you can include them in B, you cannot include them in B as well. So you have 2 choices for 1, 2 choices for 2, 2 choices for 4, 2 choices for 6 and 2 choices for 7. You can include them in your set B, you cannot include them in your set B. You have both the choices. You want to include, it's fine. You don't want to include, it's fine. So for all these 5 elements, you have 2 choices. So the answer is, number of subsets will be 2 to the power 5. Because for all these 5 elements, you have 2 choices. So 2, 2, 2, 2, 2, 2 to the power 5. Right? Next, S denote this set, then which of the following is true? Among all these, which of the following is true? Here it is a subset, here it is element, here this says equal to, here it says this is an element. So which among these is true? Tell me which among this is true. So for this, your first option says 1, 2 union 1. So what will be this? 1, 2 union 1. This will be 1, 2. Now 1, 2, you can see this is an element in set this. This is an element of the set. It is not a subset. So this is an element, this is not a subset. So don't get confused with elements and subsets. So as I say, when it is separated by a comma, it means it is an element. So 1, 2, this is an element of your set. Let's call this set S. This is set S. this is an element of this set, but 1 comma 2 is not a subset of this set S. So first option is wrong. Second, S minus 1, 2, 3. You delete this 1, 2, 3 from this set. Now from a set, you always delete some set. You don't delete elements. You delete some other set. S minus some other set. This is a set 1, 2, 3. So you see what elements are common here. So I can see only one is common. So remaining set for option B. For option B, your S minus 1, 2, 3. This will be 1, 2 and 1, 2, 3. So here also this is not equal to this particular set. So option B is also incorrect. Look at C. C says 1, 2, 3 union 1, 2. It says this is an element of S. So let's see what the union will be. So your union is 1, 2, 3. After you take the union of these two, your union is 1, 2, 3. I can clearly see this is an element of my set S. This is an element of your set S. So correct option is option number C, and we don't need to check option number D since we got option C as a correct option. All right. No, it is C, not B. B says S minus 1, 2, 3. So here your element is 1, your element is 2, element is 3. But in your set S, you have only one element, you have only one as a element. So you can only delete one here. So this is what your remaining set will be, S minus this. If you want to see by Venn diagram, also. So your set S, this is your set S. It has elements what? It has 1 here. It has 1, 2 as a element and 1, 2, 3 as a element. Now you deleted what? You deleted 1, 2, 3. I can only see with 1, 2, 3. This is 1, 2 will be here, 3 will be here. This set S has only your element 1, which is common with this set. Now you delete 1, 2, 3, which means you will only delete 1. So you will only delete this element 1. So S minus 1, 2, 3 will be remaining this set, and that is not equal to that set. All right. This is 1, 2, 3 as a set, and this 1, 2, 3 is an element. This 1, 2, 3 is not a set. This is an element. This is element. All right. And these are three elements of the set 1, 2, 3. So don't get confused with this notation and this notation. That's what confusion actually arises from. All right. So that was all about your sets chapter. If you have any doubt, please ask, and then we will move on to your next chapter, which is relations. So your next chapter, relations. So let's start with the definition of Cartesian product. For two non-empty sets A and B. So you have two sets now, A and B, which are non-empty. Cartesian product is defined in this way, A cross B, and what it says, take all the pair of elements A comma B such that your first element A is from set A. Whichever set you will write first, you have written A first. So the first pair element will be from set A. If you have written B afterwards in the product, your other second pair element will be from this second set B. This is how we write Cartesian product. Then A comma B is called ordered pair. Whatever we write here as a pair, that is called an ordered pair. And that is what is written. A is the first component. A is called the first component. It comes from set A. B is your second component which comes from your set B, and order matters. You cannot say A comma B is equal to B comma A. For example, you can never say 1 comma 5 is equal to, you can never say 1 comma 5 is equal to 5 comma 1. So in this pairing, whatever you are writing here, order always matter. 1 comma 5 is not equal to 5 comma 1. These pairs are always equal only when A is equal to B. This can only be equal when A is equal to B, or if you say an ordered pair A comma B is equal to an ordered pair C comma D, then A has to be equal to C, B has to be equal to D. So the first component should be equal, the second component should be equal. So order matters in the ordered pair. Then what is a relation? How we define a relation? So a relation from set A to a set B is nothing but it is the subset of the Cartesian product A cross B. So whatever relation you want from set A to a set B, it is nothing but you just take a subset of this Cartesian product. So R is a subset of your Cartesian product A cross B. How we notate it? We say if A comma B is an element of R relation, then we can write this as A is related to B. This is read as A is related to B, and this is how we write it, A R B. A is related to B. So this element from set A is related to an element of set B, and this is how we write it, and this is what it actually means. Now if A comma B is not in the relation, then what we write? We write this as A is not in relation B, which means A is not related to the set element B. Now the special case, a relation from a set to itself, a relation from set A to set A only. So a relation is being built, from a set A to the same set A only, and this is called relation on a set. This is called relation on a set A only, and this is what, this will be nothing now, this will be a subset of A cross A. So relation R will be now subset of A cross A. So this is your special case, which is actually general studied, and whatever results, whatever types of relations you have, which is on relation from set A to A only. Next, again you have types of relations. First relation is an empty relation. Empty relation means nothing, it has nothing. So R is empty. No pairs are formed. Nothing is related to no element in your other set. That is what your empty relation is. Then universal relation. Universal relation says take all the possible pairs. So that is nothing but your A cross A, the complete set A cross A. Then identity relation. Identity relation says elements will be related to itself only. If I am an element, I am related to myself. If you are an element, you are only related to yourself. You will not form a relation with any other element. You will only form a relation to yourself. You will only self-love yourself. So A is only relating to itself. It is only loving itself. It will not get related to some other element. Reflexive. Reflexive is like identity only. It says A comma A should be in your relation, which means I should love myself, you should love yourself, you should get related to yourself for sure, I should relate to myself. The element should relate to itself. For all A belongs to A. But here it says only and only. In reflexive, there is no foundation on it to relate to any other element. So I can relate to you as well, you can relate to me as well. But identity does not allow that. Identity says I will only be for myself. You will be only be for yourself. Symmetric. Now symmetric says what? Symmetric says if I am relating to you, I am giving you a relation, I am building a relation with you, then you also have to build a relation with me. Otherwise, I will not build a relation. So if I am being related to you, I am relating to you, you will also have to relate to me. If A comma B is related, then B comma is also related. If A is forming a relation with some other element B, then B also has to form a relation with that element A. Transitive says if A comma B is in a relation, which means let's say you and me, I am in a relation with you. All right. So I am building a relation with you. A comma B. So I am A. Let's say you are B. Now you are B. So you are forming a relation with some third person. So let's say you are the person B. You are forming relation with some third person. Then what I'll do? I'll get jealous. I'll get jealous and I'll say I will also form the relation with that third person. So if I am relating to you, but I see you are getting related to some third person. So A is related to B. B is getting related to some third person. Then I will directly get related to that person C. If that is not happening, then your relation will not be transitive. So this is what transitivity means. Now antisymmetric, asymmetric are sometimes asked or learned. So you just have to know the definition. What does it mean by antisymmetric? If A and B are in a relation and B and A are in a relation, then B will always be equal to A. Symmetric says if this happens, then this has to happen. If I am relating to you, then you have to relate to me. But antisymmetric says another condition. It says if I am related to you and you are also related to me. If I am related to you, you are also related to me. Then we both have to be equal, which means we both have to be same. Or in short, it says I cannot relate to some other person and form a cross connection. We both have to be same if we both are forming a relation with each other. So we both have to be same. We cannot be different elements. Asymmetric, what it says, if A comma B is in R, then B comma A will not be in R. It is just reverse of your symmetric, that is asymmetric. If A comma B is in R, which means if I am related to you, then you will never be related to me. If I am related to you, you will never relate back to me. That is what asymmetric means. Then equivalence, if it is reflexive, symmetric plus transitive. If it is all reflexive, symmetric and transitive, then we call our relation is an equivalence relation. So these are your types of relation. If you have any doubt, please ask me. If you have any doubt, please ask me about the types of relations that we saw. All right. Next is your equivalence relation, and by equivalence relation we study an important definition which is of equivalence class. So for an equivalence relation, so remember, for equivalence class to be defined, your relation has to be equivalence beforehand only. So for equivalence class, you have to have an equivalence relation. And what is equivalence relation? Reflexive, symmetric plus transitive. So for an equivalence relation on some set A and for some element of this set A, we define an equivalence class of this element. So we have an equivalence relation on some set A. For some one particular element, we pick up some element from that set A. We define the equivalence class of that element. What it says, equivalence class of that element is nothing but take all the elements from your set A such that it is related to that element. So what we do, let's say I have an equivalence relation. We are 5 members in an equivalence relation. I am in an equivalence relation, and you all who are watching, we all are forming an equivalence relation. Let's say I am related to the starting third person. Let's say 1, 2, 3. So my equivalence class will have what? My equivalence class will have those 3 particular elements from my set. All right. Let's say I am building an equivalence relation with all of you guys, but I am only related to the starting third 3 person. So my equivalence class will have only those 3 person, which means if we have an equivalence relation, the equivalence class of the element will be what? It will be all the elements I am related to. All the elements I am related to. So I am related to all these X elements. So include all those X elements and form my equivalence class. So I will form my equivalence class by taking all the elements which are related to me. So this is your X is related to A. Or take all those elements which are related to this element A. That is what your equivalence class is. Properties of equivalence class. Your element A will always be in your equivalence class. Why? Why? Because of reflexivity. Equivalence class will have what? Equivalence class of A will always have A. Why? Because of reflexivity. Reflexivity says I will always be related to myself. That is what equivalence relation says. It says it has to be reflexive, and reflexivity says I will always be related to myself. So my equivalence class will have me always because I am always related to myself. Then two equivalence classes are equal. Class of A element is equal to class of B element if and only if both these elements are forming a relation. So let's say that I gave you an example. I am related to the starting 3%. So those 3% will have me in their equivalence class and those two elements as well. So the equivalence classes are equal if and only if those two elements are related in a relation. Then two equivalence classes. Two equivalence classes are either empty, they will have either nothing in common, or they will always be equal. Like I said, either they will always be equal or they will have nothing in common. Next, you take union of all the classes, it will always return you back your set A. You take all the union of the classes, this is a subset of A, you will always get back your set A when you take all the unions. Now these are the counting formulas for your relations. These are your types of relations. These are the formulas of number of relations that are formed for these particular type. So total relation, if your set A has n elements, then total number of relations are 2 to the power n square. Total number of relations are 2 to the power n square. Total number of reflexive relations. Total number of reflexive relations are 2 to the power n square minus n, or you can also write this as 2 to the power n, n minus 1. Then symmetric. How many symmetric relations will be formed? This is 2 to the power n square plus n upon 2. Total number of symmetric relations are 2 to the power n square plus n upon 2. And you can take n common and write it in this way as well. Reflexive and symmetric. It means it will be reflexive as well as symmetric. This will be both reflexive as well as symmetric. So these are 2 to the power n square minus n by 2. Remember, symmetric is n square plus n by 2. Both reflexive and symmetric are n square minus n by 2. Then your identity relation. Identity relation is only one single relation in which all the elements are related to each other, only and only related to each other. So your identity relation is only single relation, which is only IA. Empty relation is also only one because there is only one empty subset. So empty relations are also only one. And similarly, your universal relation will also be one, which is A cross A, the set complete Cartesian product itself. So these are all 1, and these are the number of relations for total reflexive, symmetric and reflexive plus symmetric. Is there any doubt here? Because next we are going to do question. So we are going to do question. If there is any doubt here, please ask. Yes, it is majorly seen that one question from relations is always asked. One question from your relation is majorly asked in every year. So this is an important topic, relations. Yes. Anyone, any doubt in these formulas? All right. So let us look at this question. Now, if you have a knowledge of matrices, I hope you have studied that much, so you will be able to attempt this question. It says X be the set of all 2 cross 2 matrices with real entries. By real entries, it means all the numbers will be real in this matrices. and a relation is defined on this set. R is a subset of X cross X, which means a relation is defined on the set of 2 cross 2 matrices, and this is how your relation is defined. A comma B are related if AB is equal to BA. So two matrices are related if their product, if their multiplication will be equal in this manner. So you have to tell which of the following is true. It is reflexive symmetric, not transitive, reflexive transitive, not symmetric, symmetric transitive, not reflexive, or it is an equivalence relation. So basically you have to check what? You have to check reflexivity, symmetric and transitivity for this. So answer this. Tell me what will be the answer. Tell me what will be the answer to this. Yes, I'm giving you a moment. Tell me what will be the answer. Yes, I can see you people in the live. Yes, tell me what will be the answer to this question. Anyone? D. All right. Someone is saying D. What about others? What about others? Let's see. Let's see what will be. First, let us check reflexive. Reflexive says A comma A should be in your relation R. All right. For all the elements that are in your relation, A comma A should be in your relation. So for this, if A comma is in your relation, which means let A be a matrix, let A be a 2 cross 2 matrix. Then if A comma A will be in relation, I have to check this particular condition. So this condition says A into A. This is your matrix multiplication. So A into A should be equal to A into A. So here it will be A square. This is always equal to A square. So for a single matrix, A square is always equal to A square. A is always related to A. A comma A will always be a part of this relation. So this is reflexive. So this is always reflexive. For symmetric, let's see now symmetric. Symmetric says if A comma B is in your relation, then B comma A should also be in your relation. So let's say some A comma B is in your relation. Two matrices A comma B are in your relation. So let A comma B is in your relation R, then it means AB will be equal to BA. This implies AB is equal to BA. Now you want the inverse part. You want to show BA is in R or not. For this to be shown, what we will show, BA should be equal to, this implies BA should be equal to AB. But the first step itself says BA is equal to AB. I can say for this as well, BA is equal to AB. So this is what? This is symmetric as well. So it is reflexive and symmetric. Reflexive and symmetric. So third option is gone. Second option is gone. It says reflexive transitive, not symmetric. It says symmetric but not reflexive. So it is reflexive as well, symmetric as well. So B and C are you're gone. Now only left is to check with the transitivity part. So for transitivity, for transitive, let B be a matrix which is equal to your zero matrix. Let B be your zero matrix. Let B be your zero matrix. Then let A be 1 0 0 1, and let C be not, don't take 0 1, take it as 1 0 0 0. Let C be 0 0 1 0. Let these are the three matrices A, B, C. This is the zero matrix. So whenever you will multiply A with the zero matrix, so A, B, AB, you have AB, you will multiply this with the 0 matrix, you will always get 0. BA, for BA also you will get 0. So AB is equal to BA. So A comma B. So this implies A comma B is always in your relation R. Similarly, B and C will be related because 0 matrix after multiplication always give your 0 matrix. So from here, my B comma C will always be in your relation R. Transitivity says what? Transitivity says if I am making a relation with you, you are making a relation with some third person. So I have to also make the relation with that third person. So for transitivity, A comma C should be in relation R. This has to be true. If this is transitive, this has to be true. So this has to be true. This must be true. Check if A and C are related. A into C is equal to B into C. Check if this is true or not. Let's take A into C, which is 1 0 0 0 0 0 1 0. When you multiply this will be 0 0 0 0. All right. But when you multiply C into A, now let's calculate C into A. So 0 1 0 0 into 1 0 0 0. This is what C into A will be. This will give you what? This will actually give you 0 0 1 0. These two are not equal. So I will not say A is related to C. So A is not related to C. That means this is not a transitive relation. So option number A is correct. This is not a transitive relation. Did you all get this question? Did you all understood what we did? For reflexive and symmetric, we showed the general way. For transitivity, we just find one example which fails it to be a transitive relation. So this is not a transitive relation. It is reflexive as well as symmetric. All right. Do this question, try this. It says S is your set A comma B. This is an ordered pair. A and B are from integer Z. R is an equivalence relation defined in this particular manner. So you are already given that R is an equivalence relation. You don't need to prove or check. Then for some A comma B, we have FAB. FAB denotes what? It denotes the equivalence class. This denotes the equivalence class of this element AB. So in general, how we define the equivalence class for an element, let's say X, this is how we represent the equivalence class. They have represented in this way. They have represented the equivalence class in this particular way. Now they are asking you which of the following option is correct. This says there exists some element in your set S such that the equivalence class will have only one element. It says it will have exactly 4 elements. It says exactly 6 elements, and this says this will have infinitely many elements. So you have to tell which of the following option is correct. So you have to just check if there exists some element for which these 4 conditions are true or not. Whenever there exists, you take an example, disprove it, and you can show that. So how you will show or prove that as well? How we will do this? So what the relation is defined? So your relation is defined in this manner. A comma B is related to C comma D if what the condition is A square plus B square is equal to some C square plus D square. All right. Now you want to say if there exists some AB such that your equivalence class will have only one element. So let, for option A, let A is equal to 0, B is equal to 0. A 0, B 0 is allowed because it is from integers. So this is allowed. This is an element. So this implies 0, 0 is an element of your set S. This belongs to your set S. Now you want the equivalence class of this element. So you want f of 0, 0. It says 0, 0 will be related to some element if this is true. So for this to be true, if this has to be related to some element, that means this will be what? This will be C comma D is an element of this will be an element of S. This is how it is defined. This will be an element of S if these are related to each other. If these are related to each other, which means 0 is equal to C square plus D square. This is what the equivalence class of your 0, 0 will look like. Now square of two numbers is equal to 0. Square of two numbers which are integers is equal to 0. This means this condition C square plus D square is equal to 0 simply implies C, D both has to be equal to 0. There cannot be any other integers. That will give me 0 as my answer after squaring and adding. So your equivalence class of 0, 0 is what? F of 0, 0 is nothing but this is only 0, 0. So I got an element from this set S for which the equivalence class has exactly one element. So your option number A is correct. Now for option number B, how you can think of for option number B? So in general, let A square plus B square is equal to some value K. Let A square plus B square is equal to some element K. So what you want? You want actually C square plus D square should be equal to this K. We let A square plus B square is equal to some K. So from this relation definition, C square plus D square will be equal to this K. Now this represents what? This represents a circle in your XY plane. So this represents a circle in your XY plane. This C square plus D square is equal to K condition represents a circle in your XY plane. Now see, if there is some element AB for which this will have exactly 4 elements or not. So if I let A is equal to 0 and B is equal to 1. If I let A to be 0 and B 1, I'll get K as 1. This implies my K will be 1. So what circle I'll form? I will form the circle C square plus D square is equal to 1. So this will be a unit circle. This will be C square plus D square is equal to 1. So this point will be 1, 0. This will be 0, 1. This will be minus 1, 0. This will be 0, minus 1. These are the 4 points that C square plus D square is equal to 1 will satisfy. These are the 4 points that C square plus D square will satisfy. Are there any other integers possible on this circle? Because C square plus D square has to be equal to 1. So are there any other integer points that are possible on this circle or not? No. Why? Because if you embed this in a square, if you put this inside a square, you will see this is your coordinate 1, 1. This will be your coordinate minus 1, 1. This will be your coordinate minus 1, minus 1, and this will be your coordinate 1, minus 1. These are the 4 integer coordinates that you will get on this square. Now all the other points, all the other integer points are only this 4. Rest all the points on this circle will not be an integer. Any point on this circle except these 4 will never be an integer, because integer points are this. After these 4 points, my next integer points are this. So there will only be these 4 particular points. So B option is also correct. For 0, 1, I have an equivalence class that will have exactly 4 elements. Now for exactly 6, let's say it has 5 elements. Let's say it has 5 elements. 4 elements will be of sum this form. The fifth element, 4 elements will be of sum this form. Let's say it has some fifth element, C comma D. As soon as the fifth element comes, there we are doing the square. As soon as the fifth element comes, we are doing the square of both the numbers. Then minus C comma D, C comma minus D, and minus C comma minus D. These will also be an element of F A comma B. As soon as you move to a fifth element, any element C comma D, by symmetry, because we are doing the squares, these 3 elements will also be in your equivalence class. So as soon as the fifth element comes, I get 3 more elements. So 6 elements are never possible. If you have 4, after that you can only have 8, then 12, then 16. 6 elements are never possible, because by symmetry, if C comma D is there, all this also has to be there. So C is incorrect and D is also incorrect. It says infinitely many elements. So you take any A comma B, you will form a circle for C square D square. For C square D square, you will always form a circle for any AB. That will always be inside a square. This circle will always be inside a square. And on this square, I know there are only finitely many integer points. So this will never have infinitely many integer points, because it says there exist. It says there exist. So you can take some value of AB, for which you can show that there are exactly 4 elements. It says in all the 4 options there exist. So you take any one particular option as a choice and show that there will be exactly 4 elements in its equivalence class. All right. All right. Any doubt, anyone? Yes. So this was option A and B. Next comes your third chapter, which is trigonometry. In trigonometry, I hope you all have studied and learned all the important concepts, all the important formulas, sign conventions, in which quadrant what trigonometric function will have what sign, and trigonometric equation. So in trigonometry, I have just brought you questions for your practice and for understanding how to attempt the questions. So I'm not giving you any theory in trigonometry. Why? Because I hope you all have your formula sheets for trigonometry and all the concepts about solving the equations, about the trigonometric identities, all the trigonometric 2 theta, 3 theta formulas and everything. Because if you don't have till now, then I cannot say anything. You should have the formula sheet till now. So in trigonometry, we are only going to do question practice. So try this question. Try this question. Yes, everyone try this question. This is an easy question. This is an easy question. You all should be able to do it. Try it. So what it says, you want to tell the number of solution of this particular equation in this interval 0 to pi. You can see sin x and sin square x. If something is repeating in an expression, you just simply let it to be t. So for this question, let sin x is equal to t. I can see sin x was there as well and here as well. So just let it be equal to some expression t. What you will get? You will get 2t square plus 1 is equal to 3t. Alright, so this will be 2t square minus 3t plus 1 is equal to 0. This is a quadratic equation. You all have studied quadratic in your 10th class as well. What are the roots and solution of this quadratic now? What are the roots and solution of this quadratic? So t will be equal to b square is your 9 minus 4ac, which will be 8 upon 2 into 2. So this will be 3 plus minus 1 by 4. So this will give me one solution as 1, another solution as half. So my values of t are 1 and half. So let's take both the cases. When t is 1, this implies sin x should be equal to 1. This gives me value of sin x as 1. Your interval is 0 to pi. Let us analyze this with the help of graph. So your graph of sin x in the interval 0 to pi. This is the graph of your sin x in the interval 0 to pi. You want the value 1. You know there is one single point only that is giving you the highest value, which is 1. That is your point pi by 2. So for this to be true, I have x as pi by 2. So from here I get one solution. From this case, I get one solution. Let us see at the second case. When t is equal to 1 by 2. This implies sin x should be equal to 1 by 2. Now when sin x is equal to half in this particular interval, so half is somewhere here. This is half. When you see at what point it will be equal to half, I can clearly see from the graph it will be at this point as well as this point. So for sin x is equal to half, I have two solutions. So in total you have one solution from here, two from here. So your total number of solutions are 3. Hindi Maths Revision Live is also going on. Right, so your answer is D. So graph sometimes helps you a lot in finding the solutions when it is for trigonometric identities or trigonometric functions. Next, you are given ABC to be a triangle. This is a relation that is true. You have to tell that triangle is of which form. It is an isosceles, equilateral, right angled or obtuse triangle. So now these two equations are true. We will use just these two equations. First one says 4 sin A is equal to sec B. I can write sec B as 1 by cos. So this will be sin A cos B is equal to 1 by 4. This will be what from this first identity. Second one says 3 times of sin A upon cos B. I can write tan as sin by cos. It will get multiplied. So this will be cos A upon sin A is equal to, this will be equal to 1. Alright. From the second equation. So from here You have sine A cos B as 1 by 4. Sine A, wait. Okay, this will be, wait. This will be cos A. This was sine A by cos A and this was cos B upon sine B from this part. Alright. So you have cos A and sine A and cos B as 1 by 4. Substitute the values. So just substitute this value, you will get 3 into 1 by 4 upon sine A upon sine B cos A, this to be as equal to 1. So send it to the that side, send it to the other side. From here you will get sine B cos A. You will get sine B cos A as 3 by 4. Now you have value of sine A cos B and you have value of sine B cos A. Can you memorize or can you remember some formula or identity which I can use by these two equations? So can you think of something? Can you think of some identity that will relate these two equations? Can you think of some identity that will relate these two equations? Think, if I add them, what it will be? If you add these two, sine A cos B plus sine B cos A. If you add these two, you will get 1 by 4 plus 3 by 4. That will be equal to 1. So this is what I get after adding these two equations. So this will form what? This will form your sine A plus B. That is equal to 1. Now what you will use? You will use the question given condition that this is forming a triangle. If ABC is forming a triangle and sine of these two angle is equal to 1, then only possibility for this to be equal to 1 is that A plus B has to be equal to pi by 2. Any other values at which sine take value 1, they cannot form angles of triangle, because next value where it will be 1 will be what? It will be next value where your sine x will be 1. It is what? If you see the graph also of sine x, this is where it is 1. Then in next cycle it is 1 at this point where it is 2 pi distance apart. And here also it is at a negative angle. So the only possibility for these two to form angles of a triangle is that A plus B has to be equal to this angle only, which is pi by 2 here. So A plus B has to be equal to pi by 2. And if this is forming a triangle, from here I can directly say my angle C is equal to 90 degree or it is equal to pi by 2. If A plus B is pi by 2, the remaining angle is pi by 2. So your triangle is a right angled triangle. So your triangle is what? Your triangle is nothing but a right angled triangle. So we just use these conditions and you have to remember the identity of sine A plus B, which is sine A cos B plus sine B cos A. So remember all these identities, and trigonometric identities are very important. Next, it says alpha and beta are root of this equation, and it says alpha minus beta is not an integer multiple of 2 pi. Then you have to tell the value of sine alpha plus beta by 2. It says this satisfies this equation. Alpha minus beta is not an integer multiple of 2 pi. You have to tell the value of sine alpha plus beta by 2. So how you will approach this question? Now if alpha and beta are the roots, which means alpha and beta will satisfy this always. So if alpha and beta are roots, I will get 3 cos alpha plus 4 sin alpha is equal to 7 by 2, as alpha is the root. Similarly, beta is also a root. So I will get 3 cos beta plus 4 sin beta is equal to 7 by 2. This will always be true because alpha and beta are the roots of this. So this will be true and this equation will be true. Subtract both. Subtract both the equation. So this is, let's say, 1. This is 2. Subtract 1 and 2. Subtract both the equations. Why we do that? Because this term will cancel out and it will become equal to 0. So why when we did that? So this becomes 3 cos alpha minus 3 cos beta plus 4 sin alpha minus 4 sin beta is equal to 0. Now this expression simplifies as and it became equal to 0. So now take 3 common. This will be cos alpha minus cos beta. This will be 4 common. Sin alpha minus sin beta is equal to 0. Do you remember the identity of cos alpha minus cos beta and sin alpha minus sin beta? Who will tell me? Comment down the identity of cos alpha minus cos beta and sin alpha minus sin beta. Comment down and tell me these identities. How you see cos A minus cos B, sin A minus sin B. Yes, anyone? If you have studied trigonometry, you should remember these identities. Cos A minus cos B, sin A minus sin B. What it is? Tell me. Yes, no one? No one did study, I think. None of you studied it? None? So let me write down. So cos alpha minus cos beta is nothing but minus 2 sin alpha plus beta by 2 sin alpha minus beta by 2. And what will be your sin A minus sin B? Your sin A minus sin B is 2 sin alpha minus beta by 2 cos alpha plus beta by 2. And this is equal to 0. These are your identities. Sin A minus sin B is equal to 2 cos A plus B sin A minus B. Right. So you just missed this angle. This angle is also divided by 2. And similarly cos A minus cos B is this. Now what you can see? You can see sin A minus B by 2 and 2 is common in both. This 2 and sin A minus B by 2 is common. So take this common out from both the equation. So you will be left with 2 sin A minus alpha minus beta by 2 and this will be minus 3 sin alpha plus beta by 2 and this will be plus 4 cos alpha plus beta by 2. This is equal to 0. Why did we write it in this form alpha plus beta by 2, alpha plus beta by 2? Because in the question the angle is in this form only, alpha plus beta by 2. So when you do this, now this equation is equal to 0. This is one particular number something. This is one particular expression sum. It is equal to 0. Two numbers or two expressions are equal to 0, which means either this is 0 or either this is 0. Let's see if this can be 0 or not. Let's see if this can be 0 or not. If 2 sin alpha minus beta by 2 is equal to 0. If this is equal to 0, 2 is a number, it has nothing to do. So this means sin alpha minus beta by 2 is equal to 0. When is sin 0? Sin 0 is at the angles. This means alpha minus beta by 2. Alpha minus beta by 2 should be of the form n pi. because the value of sine of any angle is 0 at 0, pi, 2 pi, 3 pi, 4 pi, or so on. So this has to be equal to n pi. This means alpha minus beta is equal to 2n pi. But the question says alpha minus beta is not an integer multiple of 2 pi. Now here n is an integer only and it is a multiple of 2 pi. But question says alpha minus beta is not allowed to be an integer multiple of 2n pi. So from here this cannot be equal to 0. So this is not true. This is not true. This is not true. So from here you will get this to be equal to 0. From here you will get this to be equal to 0. And from this, when you get this to be equal to 0, you can write sine upon cos. That will give you tan. So your tan alpha plus beta by 2 will come out to be equal to 4 by 3. You can check it easily. This will come out to be 4 by 3. Now just apply your trigonometric identities. This is what? This is your perpendicular, this is your base. So your hypotenuse will come out to be 5. So sine of alpha plus beta by 2 will be 4 by 5. So your answer to this question is option number A, 4 by 5. Alright, so this is how we approach this type of question in which we use every information that is given to you. If this happened, this condition will be violated, so this is discarded. Now if this is 0, this directly gives me tan alpha plus beta by 2 as 4 by 3. Now my hypotenuse come out to be 5, so sine of alpha plus beta by 2 will be equal to 4 by 5. Any doubt in this, anyone? Yes, anyone, any doubt? Clear? Let's move on. You try this question. This is similar to the first one that we did. Try this. Try this question. This is similar to the first question that we did. Almost the same method and approach that we will apply. So here I can see sine square. This is sin x cos x and this is cos square. All terms are in sine cos. I can convert them by some manipulation in terms of tan. How will I do that? First check if cos x is equal to 0 is a solution or not. When I check cos x is equal to 0 and put it in this expression, I will get 1 is equal to 0, which is not possible. So my cos x is equal to 0 is never a solution, which means cos x can never be equal to 0. So I can divide the whole equation by cos square x. So divide equation by cos square of x. Divide the complete equation by cos square x. This will give you sine square by cos square. That will be tan square x. This will be sine by cos. So that will form minus 15 10x. And this will be cos square will cancel out. This will become plus 50 is equal to 0. Now this is again converted into a quadratic in tan square. So let tan square x is equal to t. So this will be t square minus 15t plus 50 is equal to 0. When you will find the roots of this, you will get t minus 5 and t minus 10 is equal to 0. So your roots are t is equal to 5 and t is equal to 10. So again two cases. two cases. Wait, not tan square, it was tan. We let tan x is equal to t. Then it will form a quadratic. When you let tan x is equal to t, this will be t square, this will be 15t, and this will be 50. So we get two cases again. So case 1, when your tan x is equal to 5, case 2, tan x is equal to 10. We have two cases, tan x is equal to 5 and tan x is equal to 10. How we will solve this? Whenever you see this type of equations where one side is a constant and other is your trigonometric ratios, always draw the graph. So this is your graph of 10x. What interval it says? It says in the interval 0 to 2 pi. So in the interval 0 to 2 pi, just draw the graph of 10x and visualize. So 10x graph. 10x graph is something like this. This is the graph of 10x. Let me draw it more clearly. So this is your 10x from 0 to this point is pi by 2. Then in the next interval, 10x goes like this. This is your 10x and this point is your pi. This point is your pi. Then you will draw when next cycle. Okay, I did draw it. Let me just shift it a bit. What happened? All right. So this is 10x. When you draw it in the next cycle, it will actually come out to be. Let me just draw it again. Let me draw it again somewhere else. So let's just draw it again. Let's just draw it here. So your 10x will be what? This is the graph of your 10x. This will be this. This is the point pi by 2. In the next cycle, 10x goes like this. This is your point pi. Next, this is your point 3 pi by 2. Then in the next cycle, your 10x will be here. And this is your point 2 pi. So from 0 to 2 pi, this is the graph of your 10x function. All right. This is what we wanted. This is what we wanted for 10x. Now this has to be equal to 5 or 10. So y is equal to 5. Let's say this is your point 5. Let's say this is your point 10. So when you try to see at what points it will intersect. So draw the line. Draw this line. You will see 10x is intersecting this at these 2 points. These 2 points. So total how many solutions you will get? In total you will get 4 solutions. So the correct option is A, 4. So whenever you find this expression in which some trigonometric function is equal to a constant value, always draw the graph of that trigonometry in that particular interval and just analyze how many times it will cut it. It will cut it at 4 points. So number of solutions are 4. Next, you have to tell the number of roots of this equation in the interval 0 to pi by 2. Number of roots of this equation in the interval 0 to pi by 2. Yes, what we will do for this? So, I can see this is 1. I'll try to make it 0 first for easy calculation. So, I know my cos square x is 1 minus sine square x. This is equal to 1. 1 now cancels out. I get x square is equal to sine square x. Now, two square numbers are equal. I can take the square root. So, taking square root. So, what I will get? I will get x is equal to sine x or x is equal to minus sine x. When you take the square root, you take it outside the square root, you will get mod on both the sides. So either x will be equal to sine x or x will be equal to minus sine x. Now in this particular interval, in the interval 0 to pi by 2, in interval 0 to pi by 2, I know this implies sin x is always greater than equal to 0. In the interval 0 to pi by 2, sin x is always greater than equal to 0 and x is also always greater than equal to 0. So in both the intervals, both are either greater than or equal to 0. So for case 1, let's see the graph of x sine x. So this is the graph of your x. This is your graph of y is equal to x, and your graph of sine x will be, let's draw graph of sine x first. This will be your graph of sine x, and you have to take only the interval 0 to pi. And your graph of y is equal to x is this line. Your y is equal to x is a line which will always be above the graph of x. Why? Which will always be above the graph of sine x. Why? Because I know x is always greater than sine x in this particular interval. So it will only meet at this one point, which is 0. So for this to be true, x is equal to 0 only. Similarly, when you will see for sine x, minus sine x. Now, minus sine x will always be less than equal to 0. This will always be greater than equal to 0. So, only point at which both can intersect is when both are 0. That is nothing but this point only. So, for both the solutions, I get only one point, which is x is equal to 0. So, number of roots of these equations are only 1. B option. Who is saying 0? Number of roots it asked. So the option is B. For the previous one, did you say? All right. All right. Now we have to do this question. If alpha and beta satisfy this equation, you have to tell which of the following will be true. If alpha beta satisfy this equation, you have to tell which of the following equation will be always true. So you have to tell in general which of the following equation will always be true. So I'm only giving the hint of this question now, rest you will do on your own. So for this question, this is what, bring it to one side, alpha terms alpha side, beta terms beta side. So this will be root 3 cos alpha minus sin alpha is equal to sin beta plus root 3 cos beta. So bring alpha terms on one side, beta terms on one side. Now for these types of equation, when we have some equation of the form a cos theta plus b sin theta. So when you have equation of this form, we solve it by dividing under root a square plus b square. So whenever you see this type of equation is formed, this type of equation where a and b are some real number, some constant, you solve it after dividing it by under root a square plus b square. So for this equation, your a is 4 above, your a is what? Your a is root 3, your b is minus 1. Your a is root 3 and b is minus 1. So divide it with under root a square plus b square. So this will be under root 3 by 2 cos alpha minus 1 by 2 sin alpha, and this will be equal to 1 by 2 sin alpha plus root 3 by 2 cos beta. Now this is what is formed. I know root 3 by 2. Root 3 by 2 is what angle? Root 3 by 2 is at which angle? I know root 3 by 2 is what? Root 3 by 2 is at cos of pi by 6. Root 3 by 2 is the value of this angle cos pi by 6. And this is your cos alpha. Then minus, this can be written as sine of pi by 6. This will be sine alpha. And this similarly, this will be sine of pi by 6 sine alpha plus this can be written as cos pi by 6 and cos beta. So why we did this? We did this because we wanted to make it of some angle form, and then we can apply the identity cos A cos B minus sin A sin B. Sin A sin B plus cos A cos B. Now this is a trigonometric identity and we can use it here now. This will be what? This will be cos alpha plus pi by 6 and this will be equal to cos beta minus pi by 6. This is what now your equation reduces to. Your this equation, which was looking very complicated a bit, this simplified as cos alpha plus pi by 6 is equal to cos beta minus pi by 6. Now we know cos theta 1 is equal to cos theta 2. This implies, we know if cos theta 1 is equal to cos theta 2, this implies theta 1 has to be equal to 2n pi plus minus theta 2. This is how we solve this equation. If cos theta 1 is equal to cos theta 2, then this angle is 2n pi plus minus theta 2. When you will put these values, you will find a relation between alpha and beta, and you can simply see that option number A is your correct option. I have given you hint till this. Till here, you will find a relation between alpha and beta, and this will be formed and this will be always true. Okay, this was sine beta. All right. Okay, wait. This was sine beta. Yes, sine beta. Yes, correct. That was beta only because that's what we wrote for the beta identity. Yes, Anup, it was beta only. This was sine beta, this was also beta. This is identity sine A, sine B plus cos A, cos B. So this reduces as cos A minus B. All right. After this, just find a relation between alpha and beta and you will get option A as your answer. Next, you have to tell the value of this particular expression. So what will be the value of this expression? Now you know you cannot calculate the value of cos at these random angles. So question never asks you to do that. There is always a trick because you never know the value of cos pi by 2022. You don't know the value of cos 2021 pi by 2022. What you need to see is this first angle and the last angle. When you add them, what will happen? Pi upon 2022 plus 2021 pi by 2022. This is always equal to, you can say, pi. You can clearly add them. This will be 2022 pi by 2022. This will always come out to be equal to pi. From here, I can write 2021 pi by 2022 as pi minus pi by 2022. I can do that. This angle is nothing but pi minus pi upon 2022. Now you want its cos value. So cos 2021 pi by 2022, it will be equal to this only. Pi minus pi upon 2022. What is cos pi minus theta? What is cos pi minus theta? If you know the sign of trigonometric ratios, in the first quadrant all are positive, in second quadrant only sine and cosec are positive, in second quadrant tan and cot are positive, and in this cos and sec are positive, 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 positive. So cos of pi minus theta will be what? This is pi, pi minus theta will be somewhere here. So pi minus theta, cos will be negative, and cos opens as cos only because this is pi. So cos pi minus theta is nothing but minus of cos pi by 2022. So this is nothing but minus times of cos pi 2022. So this term cancels out with first term. Similarly, your second term will cancel out with, this will be somewhere here, it will be 2020 pi by 2022. You can write them as this as well. Similarly, this term will cancel with this. All the terms will cancel out. But what's the catch? The catch here is there are odd number of terms. There are 2021 terms, which is odd. So there are 2021 terms. Pairs will cancel out. 2 pairs, all the 2 pairs will cancel out. The only term remaining will be the middle term. Now what will be the middle term actually here? We have to see the middle term. We start with 1, 2 and we reach till 2021. So these are number in increasing order 1, 2, 3 to 2021. So the middle term. So your middle term is left. So what will be the middle term? Middle term will be cos 1011 upon 2022 into pi. This will be your middle term. When you calculate the middle term of this finite expression 1 pi by 2, 2 pi by 2022, your middle term will be 1011 by 2022. This cancels out as 1 by 2. This is cos pi by 2. And I know cos pi by 2 is what? 0. So all the terms cancelled out. This value is 0. So overall sum is always 0. Yes, anyone, any doubt? Anyone, any doubt in this question? All right, the answer is the sum is equal to 0. Next, you have to tell the number of solutions of this expression. E to the power minus x is equal to sin x. Here is a hint for you. Try this, please. Hint is by graph. Solve this by graph. This is your hint for this. Try to solve this and see by graph. Yes, what will be the answer to this? Anyone? Anyone, what will be the answer to this question? I have given you the hint, you have to try it by graph. So let's see. Let's see the graph. What is your graph of e to the power minus x? This is your graph of e to the power minus x. This is your graph of e to the power minus x. Now you want to compare it with sin x. Now what is your graph of sin x? This is your graph of sin x. So how many points are they meeting? How many points will they meet? At how many points will these two graphs meet? Yes, the answer is option number D. More than 1000 points. They will keep on going further. This graph e to the power minus x will keep on approaching to 0 as it moves on the positive side. And we know sin x take these values at least twice in every interval, in every gap. So it is meeting 1, 2, 3, 4 and it keeps on meeting it. So it is not 0, not 1, not 2. It is more than 1000 points. Or not even more than 1000, you can directly say at infinite points. All right. Next question. So this was a very detailed solution for this. So I have brought with the solution to you, the detailed solution of this question. What it says, in a triangle ABC, sin A sin B plus cos A cos B cos C. This is an expression that is given to you and length of one of the side. So you are given a triangle, you are given a triangle, you are given a triangle with one side length as 1. So which can be any side? This can be 1, this can be 1 or this can be 1. Alright, so you are given a triangle ABC with which this relation actually holds. This is your triangle ABC. This can be 1 or 1 or 1. Any side can be 1. This relation is given to you. S is given, small s is given to be the sum of other two sides of this triangle ABC. So if one of the side is of length 1, the sum of other two side is given to be, sum of other two side is given to be as S. Then you have to comment on these four options. So this question might seem difficult and tricky because of these options, but you have to only analyze this actually, this condition. So what the condition says? What the condition says? Sin A sin B plus cos A cos B cos sin C is equal to 1. You can see cos A cos B and sin C term. This is an odd term with cos A and cos B. So separate this. We will write cos A cos B sin C is equal to 1 as 1 minus sin A sin B. So separate this. You write cos A cos B sin C as 1 minus sin A sin B. Now separate sin C from here. So cos A cos B will go in the denominator. This is always less than equal to 1. Why? Why this is true? Why this is less than equal to 1? Why this is less than equal to 1? Who will tell me why this expression is less than or equal to 1? So this is because this expression is nothing but sin C. We know sine of any angle is always less than equal to 1. The maximum value that sine of any angle can achieve is 1. So sin C, since this expression was completely sin C, so this is less than equal to 1. Now solve this inequality. You will get 1 minus sin A sin B less than equal to cos A cos B. From this expression, 1 minus sin A sin B will be less than equal to cos A cos B. Or you can say 1 is less than equal to, send it to the right and add it, cos A cos B plus sin A sin B. Now we have written an expression in terms of A and B. So we have eliminated the sin C angle, which was an odd angle expression in sin A sin B cos A cos B. So now this is cos A cos B plus sin A sin B. I know this is my identity, which is cos A minus B. So this becomes cos A minus B and this says it is greater than or equal to 1. Now cos A minus B is greater than equal to 1. I know cos maximum value is 1. So this has to be equal to 1 because cos of any angle is also less than 1 or equal to 1. So this has to be equal to 1. So cos A minus B has to be equal to 1. Now when it is 1, cos of any angle is equal to 1 when cos is at angle 0. So A minus B has to be equal to 0. So A is equal to B, because these are again angles of a triangle. These are against the angle of a triangle. So difference of two angle is making cos value 1. That is only possible when cos is at 0 degree angle. So A has to be equal to 1. When A is equal to 1, put it back in this expression. When A is equal to 1, put it back in 1, first expression. So your sin C will become what? Your sin C will become 1 minus sin A upon cos A, cos A. So sin A into sin A, sin square A. Cos A into cos A will become cos square A. And I know 1 minus sin square A is nothing but cos square A. So these two cancels out. This becomes equal to 1. Now sine of some angle C is giving me equal to 1 value. So that angle C has to be equal to what? That angle C has to be equal to 90 degree. And if C is 90 degree and A and B are equal, this directly gives me A and B are of 45 degree. So from here what I can conclude, my ABC is an isosceles right angled triangle. So just by this particular expression, this expression and this information only, I can conclude that my ABC is an isosceles right angle triangle. So this question can be framed till here as well, and they can ask you what type of triangle is ABC. So it is an isosceles right angle triangle. Now moving further, when we find out, now this is an isosceles right angle triangle, right angled at C. So this is your point, let's say A, this is B, this is C. This is right angle at point C. This is 45 degree. This is also 45 degree. Now it says length of one of its side is 1. So let us assume two cases. The two cases will be when its hypotenuse is equal to 1. So the case 1 is when one of the hypotenuse is 1, if this is equal to 1. So suppose the side opposite to C, which is your hypotenuse, if it has length 1. So by Pythagoras theorem, this and these are equal. So the length of other sides will be 1 by root 2. If this is 1, I know my BC and AC are equal. So you just apply the Pythagoras theorem. This will come out to be 1 by root 2 and 1 by root 2. What was your S? S was sum of other two sides. So your other two sides are 1 by root 2 and 1 by root 2. Take the sum. When you add them, you will get 2 by root 2, which is equal to root 2. So the other two sides are of length 1 by root 2. So your sum S will be what? 1 by root 2 plus 1 by root 2, which is equal to root 2. Now you check the options. Here your S sum comes out to be an irrational number. You take the square. When you take the square, it becomes 2, which is a rational number. So the S is an irrational number. S square is a rational number. So from this, option number D can be cancelled out. S says S is a rational number, but S came out to be irrational. Second option which can be discarded is option number B. It says both S and S square are irrational, but my S is irrational and my S square is rational. Let's come out to be the second case to discard the other option among these two. Case 2, if one of the leg has length 1. So case 2 says if one of this leg, if these are equal to 1, then your hypotenuse will be what? Your hypotenuse will be equal to root 2. If one of the leg, let's say this is fixed and this is equal to 1, then the other two sides will be 1 and root 2. Then the other two sides will be 1 and root 2. Now your S will be what? S will be 1 plus root 2. S will be 1 plus root 2, which is again an irrational number. Now you calculate S square. S square will also be an irrational number. Now what other option says? It says S is always irrational, but S square is always rational. But here S is also irrational, S square is also irrational. So my option A is also discarded. So the remaining option is option number C. And you can check it as well. S minus 1 square will come out to be a rational number. So we discarded all the options. So the remaining option was only option number C. Alright. So this was a good question, I must say. So next chapter is your sequence and series. I will say please try to do this chapter. You will get, if you get a question, it will be easy only and you will be able to do it. So please focus on this chapter. If you are not a math student, so you can score from this chapter if you get a question from this chapter. Okay. Chalo, let's start with this chapter, sequence and series. So first, what is a sequence? Let's introduce a sequence. Any ordered list of numbers following a pattern or rule. So you write the numbers in a particular manner. If they are following some rule or pattern, we call them a sequence. Like A1, A2, A3, these will be some numbers following some pattern, so we call them a sequence. And this is how we can write them if it is an infinite sequence, which means numbers are not ending, they are keep on going. Let's say for your natural numbers, so your natural number is also a sequence. For example, in your natural numbers, what we have? 1, 2, 3, 4, and it keeps on going. We know what will be our next number. So this sequence is following a particular pattern or manner. Even for even numbers, 2, 4, 6, 8, I know what pattern it is following. So all these are called sequences. Any list of numbers which is following a specific rule or pattern is called a sequence. Similarly, we can define series. Series is nothing but sum of terms of a sequence. Whatever terms are written in a sequence, you just sum them all, that will form a series. So this is nothing but sum of terms of a sequence. So A1 plus A2 plus dot 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 till AN, because the sum upper value was n. So this is sum of terms of sequence, that is called as series. Next, the general term. How do we represent a general term? So Tn or An actually represents the general nth term of any sequence. For example, here I can give them, I can write 1 as A1, then next as A2, and keeps on going. So how do I represent my general term? Your general term is represented by the number An. And I know for my natural number, my An will be equal to n only. Why? Because A1 is 1, A2 is 2. For even numbers, your An will be equal to 2n. So this is the formula, this is the pattern that they are following. So your general term is represented by An. Next, these we will study further in your AP and GP. Let's come to the fundamental formula for finding the nth term if you are given the series sum. So if you are given series, so let's say you are given series Sn. So your Sn is what? Your Sn is A1 plus A2 plus dot 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 An. What will be your Sn minus 1? What will be your Sn minus 1? It will be A1 plus A2 dot 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 An minus 1. Just analyze the definition of series. It says sum them to n terms. Sn is what? Sum them to n terms. So Sn minus 1 will be what? Sum them to n minus 1 terms. Now subtract both. Subtract Sn minus Sn minus 1. When you subtract these two equations, A1 cancels out, A2 cancels out, all the terms till An will cancel out. You will be only left with An. n. An was what? An was what? It was the general term of your sequence. So if you want to form the sequence from the series, how you can form? Sn minus 1. This is the general formula how you can find the nth term of a sequence with the help of your series. And for this, n should be greater than equal to 2, which is obvious because when you will put n as 1, this will become S0, but for 0 it is not defined. And first term is equal to the first sum, because for T1 it will be the first term only. When you will take S1, it will be from 1 to 1, so that will be only A1. So first term and first sum, they both are same. So T1 is equal to S1. Now what is arithmetic progression, your AP? So a sequence where difference between consecutive terms. This is a special type of sequence in which the difference between consecutive terms. Consecutive term means the first, second term or second, third, third, fourth. Terms which are next to each other. Difference between consecutive terms is always a constant. So the difference between two terms will always remain fixed. Difference between two consecutive terms will always remain fixed. This is how we standard notation for a arithmetic progression. The first term is represented as a, then a plus d, a plus 2d, a plus 3d, and so on. This is the general term of a sequence a plus n minus 1d. Now what difference can you see? When you take any two consecutive difference, let's say my third term is a plus 2d, my second term is a plus d. So when you difference them, a minus d, this will always come out to be d. So in this, every term, every consecutive term is with the difference d. That is what arithmetic progression is. Sequence where difference between consecutive term is always a constant. Here that constant is d. And this first term is a. Whatever is the first term of your sequence, that is called to be the first term. So here it is a. And what is your common difference? Common difference is from the k plus 1th term, subtract the kth term. That is what I did. From the third term, I subtracted the second term. You can subtract any general term and a term previous to that. You will always find d as the common difference. So this is what your AP is. Now this is the general formula for the nth term of your AP. Tn is given as a plus n minus 1 into d. That is what it is written here. The general term, nth term of an AP is a plus n minus 1d. And sum of first n terms of an AP, this is how we write the sum of first n terms of an AP. It is n by 2, 2a plus n minus 1d. And similarly, this can also be written as n by 2 a plus l, where l is your what? L is your last term. Why? Because your last term will be what? These are till n terms. So your last term an will be a plus n minus 1d. This is nothing but your last term. Alright, because this is sum till n terms. So when you put it in this formula, you can write this formula as n by 2 a plus n minus 1 d. Now replace this a plus n minus 1 d with this. This is your a plus n minus d. This is L. So this will be n by 2 a plus L. So this is how you can represent the sum of an AP in this two manner. Alright, if you want to find the common difference when only two terms are known, let's say you are given mth term and some kth term. Let's say you are given 7th term and 84th term. Alright, so any two terms are given to you. Finding the d, you want to find the common difference. You only have 7th term and 84th term of the AP. You want to find the common difference. So you do what? From T84 will be what? T84 will be a plus 83d, minus 7th term will be a minus 6d. Divide by m minus k. Your m minus k. M is 84, k is 7. M is 84, K is 7. So what you do? 84 minus 7. That will be what? That will be 77. So you can clearly see AA cancels out. This will be 77, D by 77. You can easily find the value of D. So if you are given 84th term and 7th term, you can find the value of D by just this formula. Now arithmetic mean. Arithmetic mean between two numbers A and B. Arithmetic mean between two numbers A and B is what? A plus B by 2, which means the difference term that will come in between them. A and B is A plus B by 2. So let's say your two numbers are in AP. You have A and B. You want to insert a number in between so that this series will be in AP. So this middle number that you insert, this is known as arithmetic mean. So for these two terms, your arithmetic mean will come out to be A plus B by 2. Now inserting an arithmetic mean between A and B. So let's say you have two numbers. Let's say you have two numbers A and B at some distance apart. You want to add an arithmetic mean between them. What it means? It means you want to add n numbers between A and B so that this complete sequence will be in arithmetic progression. By arithmetic mean and arithmetic mean insertion, what we mean is you want to insert n numbers between these two numbers so that this complete sequence will be in arithmetic progression. So what is the general formula for finding the common difference? For the common difference, what you do? You do B minus A upon n plus 1. So for example, let's do an example for this. For example, let's say this is the example for this. Let's say you have A as 5, B as 100. You want to add 20 arithmetic mean. You want to add 20 arithmetic mean between A and B. So you want to add 20 arithmetic mean between A and B. So what it means, this is your A, this is your B. You want to add 20 numbers between them such that this complete sequence will be in arithmetic progression. So what is the formula for finding D? Formula for finding D is, this will give you D as B minus A. So 100 minus 5. 100 minus 5 upon n plus 1. N is your 20. So upon 20 plus 1, which is 21. So your common difference will be 95 by 21. Now you know your first term is 5. Second term will be A plus D. So second term will be 5 plus 95 by 21. Your third term will be A plus 2D. And so on, you will find all the terms between these two numbers so that this sequence will be in arithmetic progression. Alright, now if you want to have three numbers in an AP, if in any question it is not given what these three numbers are, you are only asked to tell, or you are only asked to suppose that we have to take three numbers in AP. So the best way to take them is A minus D, A and A plus D. Why we do that? Because when you sum them, D will cancel out, your expression will only be in A. So for simplification and simpler calculation, we assume the three numbers in AP as A minus D, A and A plus D. Because when you add them, D cancels out, we will be left with only 3A. Similarly, for four numbers, you take A minus 3D, A minus D, A plus D and A plus 3D. This is the same reason here. When you add them, 3D cancels out, DD cancels out. The expression in addition will only be in terms of A. Then sum of first n natural numbers. From this AP sum formula, you can find the sum of first n natural numbers, which will come out to be n plus 1 by 2. Just apply this formula for first n natural number. You will come at the result. It will be n plus 1 by 2. Just apply this sum of AP. You will find that the sum of first n natural number is n plus 1 by 2. Now next come is your geometric progression. Next come is your geometric progression. So what is your geometric progression? This is again a sequence. What pattern it will follow? In this, ratio between consecutive term is constant. In your AP, the difference was constant. In your GP, your ratio is constant. The sequence in which ratio between consecutive term is a constant is called as geometric progression. And what it is standard form? Standard form is A, AR, AR square, AR cube and so on. You can see whenever you take the ratio, divide AR by A, you will always get R. AR square by AR, you will always get R. So the ratio between two consecutive terms will always be a constant, and that constant here is your R. So this is called as the common ratio, which will always be equal to R. And what it is? Divide the two consecutive terms, tk plus 1 upon tk. Whenever you divide the two consecutive terms, your ratio will always come out to be equal to R. And same to the AP, the first term is always the term that is at the first place. So here the first place term is your A. So first term is A. Alright, so similar to AP, the nth term of GP is given as ARn minus 1. AR to the power n minus 1. Sum of first n terms of GP is ARn minus 1 upon R minus 1. How you can remember this? So remember, sum will always come out to be a positive number if R is greater than 1. Alright, so for this, if R is greater than 1, you divide it by R minus 1. You anyhow have to make the denominator positive. In the sum, remember only the thing that the denominator should be positive. So when R is greater than 1, R minus 1 will be a positive denominator. So write denominator as R minus 1. So in numerator also you will take R to the power n minus 1. And A is always there. A is always there in both the expression. So A is fixed. Denominator is to be made positive. So if R is greater than 1, R minus 1 will be positive. So in numerator also it will be R to the power n minus 1. Similarly, if R is less than 1, so 1 minus R will be a positive number. So in numerator also you will take 1 minus R to the power n. And A is fixed in both the case. Now if your ratio is 1, what will be your sequence? If your ratio is 1, it means that is a constant sequence. If this is 1, so this will be A, it will be clearly just A. If R is 1, if R is equal to 1, your GP will be what? A, and so on. So GP will be, GP is A, and so on A. So you want to sum the terms. These are n terms. So Sn will be sum of n terms. A times this will be equal to n into A. So that is what it is returned. If R is 1, your sum is n into A only. So this is the case when R is greater than 1, this when R is less than 1, and this is the case when it is equal to 1. So we have written all the sum formulas for all possible values of K. Now sum to infinity. Now this GP can also go to infinity. It has the choice, it has the possibility that it can move to infinity. The terms does not end. So sum to infinity is only valid when the mod value of R is less than 1. So you can sum them to infinity, a GP, if you know this value of R. The R mod value is always less than 1. And this is the formula for infinite GP sum. A upon 1 minus R. Remember, this condition is necessary. This is a necessary condition. If mod R is less than 1, then only you will take sum to infinity of a GP, and that will be S infinity A upon 1 minus R. If this mod R is greater than 1, then sum does not exist. It will go to infinity or minus infinity. So in that case, sum does not exist. So this is only valid, remember, this is only valid when mod R is less than 1. Next, geometric mean. Just like arithmetic mean, geometric mean means what? You have two numbers you want to insert a number between it such that this will be in GP. So this is root of AB. And why is that? If you insert root AB here, now you take the ratio of the consecutive terms. Take ratio. So root AB by A. This will be what? This will be root B by root A. And similarly, if you take B by root AB, this will again be root B by A. So the common ratio is root B by A, and the term that will be inserted in between will be root AB. So the geometric mean between two terms A and B is root AB. All right. All right. So root AB upon A, this comes out to be root B by A, and this also comes out to be root B by A. So your geometric mean between two terms A and B is root AP. Similarly, you can product these terms. You can add also, you can product these terms. When you product them, A will get multiplied how many times? N times. So A to the power N. Your R is 1, R to the power 2, 3 and so on, N minus 1. When you product them, how the product will be formed? So when you take the product, so product of A to the R, A to the power R square and so on. Now A is coming always till N times. So A to the power N. Now in your R, first R power is 0, second R power is 1. So R starts with power 1, then with power 2 and so on, it will go to power N. Now in previous only we have seen sum of first n terms of a natural numbers. Sum of first n natural number, which is n plus 1 by 2. And this is still n minus 1. This is still n minus 1 because the general term is n minus 1. So this will be till n minus 1. So take the sum of first n natural numbers till n minus 1. So this will give you n minus 1 by 2. So this is the product of first n terms of our GP. There is an alternative form as well. This is an alternative form of this. You take the first term, you take the last term and take the power n by 2. First term, last term with the power n by 2. So your first term is A, last term is A to the power n minus 1 and with the power n by 2. So power n comes here. By 2 is what? Square root. So you just take the square root. So these are two forms to write the product of first n terms of a GP. Now similar to the AP, you want to insert n geometric mean between A and B. You want to insert n numbers between A and B such that they will be in a geometric progression, such that they will have this definition condition. So what is the common ratio? The formula for common ratio is B by A to the power 1 upon n plus 1. So your common ratio will be B by A 1 to the power n plus 1. Similar to the AP example, you can take an example for GP and find this common ratio, and then you will have your complete GP series. Now three numbers in GP, just like the AP, three numbers in GP are taken as A by R, A and AR. Why we do that? Because in GP we multiply the terms. In GP the terms are taken as ratios, so we multiply the terms. So when you multiply these three terms, your R will cancel out, you will be left with A cube. So that's why for easy simplification, when you multiply an AP, when you multiply a GP, it will remain as A cube. Similarly for four terms, A by R cube, A by R, A into R, A into R cube. This will be clearly a GP, and when you multiply them, R terms will cancel out. You will be left with only A terms. For simplification, that's why we consider 3 terms and 4 terms like this. All right. Next, now harmonic mean is not in your question syllabus now, so just cut this harmonic mean part. For two numbers we have seen arithmetic mean, we have seen geometric mean. Harmonic mean is not a part of your syllabus now. So now you know what is arithmetic mean, you know what is your geometric mean between two numbers. So the inequality that these follow is arithmetic mean is always greater than or equal to geometric mean. Arithmetic mean is always greater than equal to geometric mean. By this what we mean? This means a plus b by 2 is always greater than equal to root a b. The arithmetic mean geometric mean inequality says a plus b by 2 is always greater than or equal to root ab. And from where you can prove this, we know a plus b whole square will always be greater than equal to 0. Sum of two number and you are squaring it. It can be 0 or greater than 0. So from here I get a square plus b square plus 2ab greater than equal to 0. So this will give you a square plus b square will be greater than equal to minus 2ab. Then when you manipulate this, you will always get sum as this particular arithmetic mean geometric mean inequality. Alright. So this is always true. And your inequality holds. Your inequality is becoming an equality only when a is equal to b. When a is equal to b, in case when a is equal to b, then your arithmetic mean will always be equal to your geometric mean. When a is equal to b, your arithmetic mean will always be equal to geometric mean. Alright, and harmonic mean is not required, so this relationship is not a part of your syllabus now and you don't need to look at this proof. Alright, so the only relationship you wanted to see is between arithmetic mean and geometric mean. So AM and GM, this is the relation, and this is true for any n number. So in general, your arithmetic mean will be what? Your arithmetic mean will be a1 plus a2 plus a3 an, and this will be divided by n. This will be your arithmetic mean of n terms. This will always be greater than or equal to the geometric mean of n terms. And this is the geometric mean of n terms. Nth root of a1, a2, a3 until an. So arithmetic mean is always greater than or equal to geometric mean even for in general case when it is your n number of terms. When you take 2, so a1 plus a2 by 2 will be greater than or equal to root 2 of a1 into a2. That is what it is written. This is the special case for 2 terms. This is the general case for n number of terms. All right. Next, telescopic series. There is no question I could see asked, but this is an important concept. What telescopic series says? Method of differences. This also is known as method of differences. What is the general principle for this? Now, when you can express a series as sum of difference of consecutive terms, what it means? Let's say you have a series. Let's say you have a series of this form sum fx, some series of function fx or fk. Let's take k. Sum is running from k equal to 1 to n. You have some series expression in terms of k. If you can express this series, if you can manipulate this and express this series as some g k plus 1 minus some g k. Alright, you manipulate this function and you can write this as a difference of consecutive terms. This will be the first term, this will be the term which is bigger, this will be the lesser one. So when you can write this as a sum of two consecutive terms, when you take the sum from k is equal to 1 to n. Now open this sum in this. You will get what? You will get g2 minus g1. Then next sum will be g3 minus g2 and so on. So when you can write some series expression which is in addition this function format, if you can split this as a difference of two function, that's why it is called as method of differences. If you can express this as a difference of two function, then when you see the terms keeps on cancelling out. This term will cancel with this, third term will cancel with here minus g3, and so on. You will be left with just the n plus 1th term and the first term. So this is how we have returned this. So what we are left with? I am left with the first, this minus g1 term, that is what here it is written as minus f1, and the last term that will be left with will be gk plus 1. So I will be left with only these two terms, minus g1 and plus gk plus 1. That is what we have returned here. So if you can express some series as difference of two consecutive terms, if you can express this as difference of two consecutive terms, then your general series sum just open up as this. All the terms in between cancels out. So this is an important method to find the sum of series. Sometimes to find the sum of series, this method is widely used. Common applications where it is applied: for partial fractions, for difference of consecutive squares of cube. So for difference of consecutive squares of cube, you can apply this. Let's say you have x plus 1 square minus x square, and x is running from 1 to k, or let's say x is running from 1 to k. So when you want to have the difference of consecutive squares, you can use this telescopic series, and you will find that this will be nothing. This will be equal to what? This will be equal to f of n plus 1. So this will be nothing but just k plus 1 square, the first term. First term will be f1, put 1. So that will be just minus 1. This will be your answer. Now you can take k as any value, and you can find this answer just by putting the value of k here. And similarly for cubes. Now trigonometric identities. Sometimes in trigonometry also, this can be expressed as difference of two terms, and then when you open it, it will come out to be as the first term plus the last term. Like you can see the basic forms here. 1 upon k plus 1. 1 upon k plus 1 can be expressed as difference of these two terms like this. Now when you want to sum them, 1 upon k plus 1 can be expressed like this. Now if you want the sum, for this, let's say you want to sum 1 upon k plus 1. Value of k starts with 1, it goes till 100. You want to find the sum of this particular expression. This will be a very tedious work to do. You will calculate it, and it will be a very long calculation. You can express this as 1 upon k minus, 1 minus k, 1 upon k minus 1 upon k plus 1. Now you take the sum. On this. Sum is from k equal to 1 till 100. Now put some values. For 1. It will be 1 upon 1 minus 1 upon 2. When you put k is equal to 1, it will be 1 by 1 upon minus 1 by 2. Then next term will be plus 1 by 2 minus 1 by 3. When you put k is equal to 2, it will be 1 by 2 minus 1 by 3. Next term, when you put, it will be 1 by 3 minus 1 by 4, and so on. What you can see? You can see your minus half cancels with plus half. Minus 1 by 3 cancels out with plus 1 by 3. So you are only left with this first term, which is your 1. And you will be left with your last term, that will be 1 upon k, and k last value is 1 by 100. This is what you will be actually left with. Plus 1 by 100, and this will be minus 1 by 101. And a term before this will be 1 by 99 minus 1 by 100. So you will be left with actually minus 1 upon 101. You can always write the last two terms and see which terms cancels out from here. You will be left with minus 101. So your first term remains as 1 and your last term which is remaining as minus 101. So this sum was so difficult to calculate, but we could see this is nothing but 1 minus 100, 1 upon 101. Now when you see this, this is nothing but 100 upon 101. So this is your answer for this particular sum of this expression. So you can express any function. If you can express as the difference of two function, then it is very easy to calculate the sum. Similarly, you can see for 1 upon k, k plus 2, for 3, 1 upon k, k plus 3, for 3 terms if they are, so you can write it in this way. If you have difference of squares, like here we did. So if this is the case, then you can write it as 1 by 2, 1 upon k minus 1, minus 1 upon this is k plus 1. You will get this in notes, so does not matter. All right. Now let us do some questions from this chapter. Try this question. This question says the root of these polynomials are in arithmetic progression in AP. Which of the following is the common difference of your progression? So this is a very easy question. If you want, and you can do it in 1 minute. So roots of the polynomial are in AP. You see how many roots it will have. This is a cubic polynomial. So how many roots will it have? How many roots will this have? 3 roots, right? So we know there are 3 roots. There are 3 roots. And I told you, whenever you take 3 numbers in an AP, what you will consider? Let the roots be a minus d, a and a plus d. Whenever 3 terms are in AP, you consider them as a minus d, a and a plus d. Now, sum of roots. What will be the sum of roots? That will be equal to 3a when you sum them. But for this, I know by Vita formula. If you don't know for cubic, you should have known. You must know actually by now. So we will study in quadratic. But if you don't know for now, sum of roots if of a cubic, this is nothing but minus times of this upon the coefficient of this. So that will give me equal to 39. So from here I can directly say my a is 13. I know my value of a is directly equal to 13. Now I also know product of roots. My product of roots. What is the product of roots? That will be a minus d into a plus d. What is your value of a? Value of a is 13. So this will be 13 minus d into 13 plus d. And product of roots is equal to minus times of this coefficient upon coefficient of x cube. If you don't know this, please know it. This will be minus times of this upon this. So that will be 1729. So this is what we get. Now this 13 you can divide, and this a minus b, a plus b. This will be 13 square minus d square. That will be equal to what? 13 you divided by 13. 1. This will be equal to 133. When you divide that term with 13, it will be 133. So from here you get d square as 169 minus 133. So your d square is what? Your d square is 36. So your value of d is plus minus 6 actually. Your value of d is plus minus 6. But in the options, only positive values are given. So you will take d as 6. So your common difference is 6. Abhay, this is happening in our English channel, so I cannot speak in Hindi because this particular Maha revision is for English channel. For Hindi, you can watch the Hindi channel as well. That is going live in our Hindi channel as well. So if you want to watch it in Hindi, we are going live for maths today only in our Hindi as well. But this is our English channel, so we are doing it in English only. Now it says A and B are positive real numbers whose geometric mean is equal to this. So A and B are positive real numbers. Geometric mean is this. You have to tell the value of t. So you just equate it equal to geometric mean. This is what? This is A t minus 99 plus B t minus 99 upon A t minus 100 plus B t minus 100. This is what is given to you as the geometric mean. But you know, for two numbers A and B, your geometric mean is nothing but this is under root AB. The geometric mean for two numbers A and B is what? Root AB. And this can be written as A to the power 0.5, B to the power 0.5. Because under root is nothing but A to the power 0.5, B to the power 0.5. Or you can say half and half. Now just equate this. Just cross multiply and equate. So you will get AT99 plus BT minus 99 is equal to A 0.5, B 0.5 multiplied with this expression. This is AT minus 100 plus BT minus 100. So when you multiply them, you will get what? AT minus 99 plus BT minus 99 is equal to. This will give you what? A to the power t minus 99.5, because this is minus 100, this is 0.5. So A to the power t 99 this and B to the power 0.5 plus A to the power 0.5 B to the power t minus 99.5. Now bring this expression to the left, take this to the right and write all in terms of A to the power. So when you bring it to the left, I can take AT99 as common. This will give me 1. This will give me minus A to the power minus 0.5. Right? And then this expression will give you B to the power t minus 99 when you take common. This will give you B t to the power minus 0.5 and this will give you minus 1. Now just solve them, equate them. You will get your answer and value of t as 199 by 2. Just equate them, solve them, you will get value as A to the t value as 199 by 2. Alright, try this question. Yes, the answer is A. Alright. Next. A1, A2, A 2022 are positive integers such that this is the relation given. AI plus AI plus 1. This sequence sum is equal to B plus 1. So this sum of two terms I and I plus 1 is equal to B plus 1 for all I. For all I from 1 to 2021. So for all values of I from 1 to 2021, I know this particular sum will always come out to be as B plus 1, where B is some constant. You are given value of A 2022, then you have to tell the value of A 22. You are given 2022 value of A, you have to tell A 22. So let's see, let's put I is equal to 1. When you put I1, this will be A1, this will be A2. This will be equal to B plus 1. Put I is equal to 2. So you will get A2 plus A3 as B plus 1 only. Put I value as 3. So A3 plus A4 will also be equal to B plus 1. These are the three equations which I can find by putting different values of I. You can keep on doing this step. From these three equations, this is, let's say, first, second, third. From first and second, subtract them. So from these two equations, what I'll get? A1 plus A2 minus A2 minus A3 is equal to 0. So this terms cancels out. This gives me A1 is equal to A3. Similarly, when you do for this and this, you will get A2 is equal to A4. And when you will keep on writing this, when you will see the pattern, you will get A1 is equal to A3 is equal to A5 is equal to all the odd number of terms that are the index. And then you will get A2 is equal to A4 is equal to dot dot dot. The last term is A2022. So all the terms at even index are equal and all the terms at odd index are equal and even are equal. So you have given the value of A2022. So you know A2022 is equal to 2. So all the even number of terms in the index will also be equal to 2. So this directly implies A22 is also equal to 2. So the answer is option number B. Alright. Alright, is this clear to everyone? This was a very easy question, All you have to do is just put values of I till 3 place and check the relation what your A are following. So A1 is A3, A2 is equal to A4 and all the odd terms will be equal, all the even terms will be equal and the value of A2022 was 2. So your value of A22 is also 2. Alright. So we are done with this chapter and with that let us take a break. You all can also have your lunch and then we will start with your binomial theorem. So it is 3:05. We'll be back at 3:15. So break till 3:15. All right. All right, wait. I forgot to put mic on. So let me explain it again quickly. So sorry for that. So this is your binomial expansion for a plus b to the power n. This is how your binomial expansion opens as. This is the summation formula r to the power r from 0 to n, ncr, a to the power n minus 1, b to the power r. Then you can also write this in expanded form as nc0 a to the power r plus this is nc1, nc2 until ncn. Then alternatively, this term, this is nothing but nc0. This and these are same notations of same thing but with different notation. So this is how your actually binomial expansion looks like. And this is what, this is your NCR, which is your binomial coefficient, and this is the formula to calculate it. If you put value of n, you put value of r, you can calculate the value of this coefficient, which is NCR. And these are the special variations and special cases which you can see. For a minus b to the power n, you put nc0 a to the power n. Now this in summation form, in plus form, can be treated as a plus minus b to the power n. So this is minus b now. So put minus b here, minus b, minus b, minus b in all the terms. So this will open as with a negative sign for odd powers, with a positive sign with the even powers. So this is how you can see a minus b to the power n as. Now these are the special cases for this only. In this a is 1, b is x. In this a is 1, b is your x. And now number of terms in a binomial expansion. So if you have nth power, if you have nth power, number of terms will be one more than that. It will always be n plus 1. Why? Because you see square, a plus b square. Whenever you do a plus b square, your terms expand as a square plus b square plus 2ab. So your number of terms become 3. Similarly, for a cubic expression, your number of terms becomes 4. So whenever you expand a plus b to the power n, your number of terms increases by 1. Whatever is the power, your number of terms will be 1 greater than that. Now the general term of a binomial expansion. In the expansion of a plus b to the power n, if you have this expansion, your general term is given by tr plus 1, and this is what? This is ncr, a to the power n minus r, b to the power r. So this is your general term in the binomial expansion. Alright, so this is your general term in the binomial expansion. Now middle term. What is middle term? So for middle term, in the expansion of a plus b to the power n, if your n is an even number, you see if the power is an even number, your number of terms will become what? N plus 1. If n is even, n plus 1 will be odd. So only one middle term exists in this case, and that will be at the position n by 2 plus 1. So your middle term will be at the position t n by 2 plus 1. Since it is at the position n by 2 plus 1, so if you calculate this general term, if you calculate this t n by 2 plus 1th term, that will be your middle term for the case, when n is even. Similarly, when n is odd, your number of terms will be n plus 1, which is an even number. In this case, you get two middle terms, and they are at the position n plus 1 by 2 and n plus 3 by 2. So just put this value in this general expression formula. Instead of r plus 1, put n plus 1 by 2, put n plus 1 by 2, put n plus 3 by 2, put n plus 3 by 2 here. So you will get the general term, middle term. From the general term, you will directly get the formula for the middle term in this case of odd numbers, in the case of even numbers. Now the properties of your binomial coefficients. The binomial coefficient which you see NCR, what are the properties that the binomial coefficient follow? So now sum of the binomial coefficients NC0, NC1, NC2 till NCn. It is always equal to 2 to the power n. Alright. Now sum of even position coefficients. Now coefficients which will be at even number of position or odd number of position, like NC0, NC2, NC4 and dot dot dot. This will be even terms here and this will be odd numbers here. This sum is always equal to 2 to the power n minus 1. So sum of even position coefficient is always equal to sum of odd position and that will be 2 to the power n minus 1. Now alternating sum. Alternating sum says first term positive, second coefficient negative, third again positive, fourth coefficient negative positive and so on. So sum of alternating coefficients is always equal to 0. Now sum with index. By index what we mean? Let's say for this, let n is equal to 10. Let your n is equal to 10. Then summation r from 0 to 10. This is what n dot, this is r dot ncr. So how you will open this? This will open as 0 into this. 0 into anything is 0. So then 1. So 1 into nc1 plus 2 into nc2 plus dot dot dot. It will be 10 into nc10. This is how this sum will open as for n is equal to 10. For n is equal to 10, if you see this, if you want to find this sum, 1 into nc1, 2 into nc2 till 10 into nc10. This is how this sum will open as for this particular value 10. You can directly use this formula. And what will be the answer? This will give me n into, n is your 10 into 2 to the power n minus 1. That will be 2 to the power 9. So you can directly use this formula for sum with index. Sum with index means this index comes in multiplication with the coefficients, and this is how your sum will actually be calculated directly with this formula. All right. Now sum of squares. If your binomial coefficients, these coefficients are squared and then added. This is NC0 square, then NC1 square, NC2 square and so on till n. So this is nothing but 2NCn. For example, for n is equal to, let's say 20. Let's say for n is equal to 20, you want what? You want sum of r is equal to 0 to 20. Your n is 20 of 20 CR and this is 20 CR square. So in the expanded form, how you will see this? This can be seen as 20C0 square plus 20C1 square and till 20C20 whole square. So if you have sum of coefficients in the square, this is square of sum of binomial coefficient. So you can directly use this formula. It is nothing but this is 2nc2. So this sum will be nothing but 2n. 2n is what? 2 into 20. C combination with n. N is your 20. So this is nothing but this is 40C20. Now you can directly calculate the value of this sum with this particular formula. So this will be nothing but 40 factorial upon 20 factorial into 20 factorial. So you just have to calculate this value if you want what? If you want square of the sum of binomial coefficients. And this is your Van der Monde identity. This says if you have two different numbers m and n and the binomial coefficients are multiplied, then you can solve this as m plus ncr. You can solve this as m plus ncr. If you have different numbers, if you have different binomial coefficients and they are multiplied together, you can find the sum as m plus ncr. All right. So now the greatest coefficient and greatest term. What is the greatest coefficient? You see you have coefficients NC0, NC1, NC2. These are the coefficients in the binomial expansion. So what is the greatest coefficient? In a plus b to the power n or 1 plus x to the power n. If your n is even, then the greatest coefficient is this. So this is nothing but your greatest coefficient is NCn by 2. Your greatest coefficient is NCn by 2. If two equal greatest coefficient are present, if n is odd, if n is an odd number, then we have two greatest coefficient, which is NCn minus 1 by 2 and NCn plus 1 by 2. So in case of even, we get only one. In case of odd, we get two greatest coefficients, which is given by these two particular formulas. All right. Now, greatest term. What is greatest term? Numerically greatest term, which means which term will have the highest numerical value. By numerical, we mean absolute value. All right. So for the expansion of a plus b to the power n, now both a and b should be positive. It can be negative as well. We take the mod in that case. So we will calculate what? Calculate this particular expression m. So let's say you have for a plus b to the power n. All right. You want to find the numerically greatest term. So you will calculate what? You will calculate this particular value. What value it says? It says n plus 1. Calculate this value n plus 1 times of mod b, n plus 1 times of mod b upon mod a plus mod b. So if you have this binomial expansion, all right, and a and b and n are given to you, let's say let a be 3, b be 5 and n be 10. All right, this is given to you. You want to find the numerically greatest term. So you have a, b and n value. Calculate this value n. So for this example, if I calculate it, for this example, my expansion will be what? Expansion will be 3 plus 5 to the power 10. Right? Right? This will be the expansion. In this case, these are just numbers, right? But sometimes it will be in terms of x, then your number will be given to you. So in that case, you calculate this. Your m will be what? M will be 11 into 5, 11 into 5 upon mod a plus mod b. That will be 8. This is what? This is 55 by 8. Now this is not, it says if it is an integer, then tm and tm plus 1. If this value comes out to be an integer, then this mth term and the next term, m plus 1th term, both are greatest. Both will have greatest value. If it is not an integer, then you take the floor function plus 1 and that will be your greatest term. So you don't need to see the alternative method. This method works well for finding the numerically greatest term. You just take if m is an integer, then tm and tm plus 1 both will be greatest. If it is not an integer, only t with floor m plus 1 will be the greatest term. Alright. So in this case, it is not an integer. M is not an integer. So what is the case? When it is not an integer, take the floor of it. What will be the floor? Floor of m. Floor of m will be, I know 55 by 8 will be what? This will be 6 point something. So floor of this will be 6 plus 1. So your seventh term, T7 is the numerically greatest term. So your T7 is numerically, that is the numerically greatest term. So in this expansion, you will find all the terms. You have to sum. So what you will find? You will find seventh term. T7 will be the numerically greatest term among all the terms that are added together. So in this, you will expand this as, 10C0 3 to the power 10 b's like that, then 10 c1 3 to the power 9 into 5 and so on. This is how you will expand this particular binomial. When you have to see the numerically greatest term, so among these terms, this is your first term, this is your second term. Among all these terms, the highest value will be of the seventh term. Whichever term is at the seventh place, that will have the numerically greatest value. That will be your numerically greatest term. Alright, now this is your general binomial theorem if your n is a rational number. Whatever binomial theorem and whatever results we have seen, that was for n to be a natural number. Now this is for any rational number, it can be positive, negative or a fraction. But in this, a special condition is there that mod x should be less than 1. So this, in this x, for this x, this mod x should be less than 1. That is a condition if you want to expand for a rational number. So this is expanded as 1 plus nx plus n minus 1 by 2 factorial into x square and so on. This terms will be n, then n minus 1, n minus 2 upon 3 factorial. Power of x keeps on increasing and this will follow this particular pattern. Now this forms an infinite series because it is not ending. It is a not ending. This is never ending series. And this converges only for mod x is equal to less than 1. So that's why for rational numbers, this 1 plus x to the power n as a binomial gets expanded in this manner and this converges, which means it is finite only if mod x is less than 1. That's why we take mod x to be less than 1. And this is the general term. This is the general term for this. You can clearly see the general term will be n minus 1, n minus 2. It will go till n minus r plus 1. This is n minus 2. So it will go till n minus r plus 1 upon r factorial. You can see for the third term, it is 3 factorial. So for this term, it will be r factorial. Then x to the power r. X to the power r. So this is the general term. And these are the special fundamental cases, important special cases for this rational number power. Alright, this is 1 plus x to the power minus 1. So this can be expressed in this manner, and for this mod x should be less than 1, mod x should be less than 1. In this case also mod x should be less than 1. In all the following cases, mod x should be less than 1. Then only this series will converge. By convergence, which means they will go to a finite sum. Alright, let's do the questions now from the binomial theorem. What types of question actually comes in your exam? Tips to attend questions in maths. So first of all, please analyze the complete paper. For mathematics portion and physics especially, please analyze the questions and figure out which are easy question, which are your forte, and please do that first because that will boost your confidence. Then come to the next level, see what are medium level questions according to you, mark them, then come to those questions and so on. The difficult questions are to be left for the last part. When you will have no time or when you will have limited time, then you can attempt those questions. When you will be left with a limited period of time, you can give your time to those difficult questions, so attempt those at the end. All right, we have to see this question. This says coefficient of x to the power 7 in the expansion of this is equal to the coefficient of x to the power minus 1 in the expansion of this. Then we have to tell which of the following relation is actually true. So let's see coefficient of x to the power 7 in the expansion of this. So how this will expand as? This is ax square plus 1 upon bx to the power 11. So we will just use the binomial general term. So your tr plus 1, your general r plus 1th term is what? ncr a to the power n minus r b to the power r. This is your general term for any binomial expansion. So let us see general term for this. Let us see general term for this. TR plus 1. Your n is what? N is 11. So 11 CR. What is your A? A is your this complete first factor. So that is A x square to the power 11 minus R. Remember this A, this is your complete first term, this is your complete second term. Alright, so this is first term to the power 11 minus R. B, B is your complete this. This is 1 upon Bx to the power R. So this is your general term, this is your general term for the expansion of this binomial part. Alright. So when you expanded this and see its general term, this is what you get. Now you want what? You want coefficient of x to the power 7. So separate all the terms with x power. So take all x power common and separate rest of the terms. So this will be 11CR, a to the power 11 minus r. And this is 1 upon b to the power r. So you can put it in the denominator. This is b to the power r. Now remaining terms are x to the power 22 minus 2r. Since this was x square, so x to the power 22 minus 2r. And this will be upon x to the power r. So when you take it with here, this will be minus r. So this is what your general term opens as. Now you want coefficient of x to the power 7. This is your powers of x. This is your power of x. You want power to be 7. So put this expression equal to 7. So this will give you what? This will give you 22 minus 2r minus r. That will be minus 3r should be equal to 7. When you will solve this, you will get value of r to be 5. So by this x to the power 7, I find the value of r. Now I know what will be its coefficient. Coefficient of x to the power 7 will be this when r is 5. So put r as 5. So coefficient of x to the power 7, that will be what? 11 C5 a to the power 6 upon b to the power 5. That will be my coefficient of x to the power 7 in this particular expansion. Similarly, do for this. Similarly, let's do for this. For this, it will be what? It will be 11 CR ax to the power 11 minus r. This is ax, so ax to the power 11 minus r. Then this complete term is minus 1 by bx square to the power r. This is your general term. So we are only using the general term formula in this. So this will open as, when you see this, this will open as 11 CR a to the power 11 minus r. Now this is what? Minus 1 by b to the power r. So take it complete out. So this will be b to the power r and minus 1 to the power r as well. So let's write it here, minus 1 to the power r. So in the numerator it was minus 1 to the power r, denominator was b to the power r, and this was a to the power 11 minus r. Now see the coefficients of x. So that will be x 11 minus r. From here you will get upon x to the power 2r. In the denominator you will get x to the power 2r. So see, you want to make the coefficient as minus 1. So this implies 11 minus 3r should be equal to minus 1. From here, I'll get my value of r to be 4. So from here, I calculated my value of r. So the coefficient will be what now? The coefficient is put r as 4. 11C4 a to the power 7. This will be 4. Minus 1 to the power 4 will be a positive number, so you don't have to worry about that. Divided by b to the power 4. Now the question says the coefficient of this in this is equal to coefficient of this. So equate them, put them to be equal. So according to question, these are equal. So 11C5 a to the power 6 upon b to the power 5 is equal to 11C4 a to the power 7 upon b to the power 4. Now cancel the powers. A6 cancels out here, this will be just 1. B4 cancels out here, this will be just 1. Now what will be 11C5? 11C5 is 11 factorial upon 5 factorial into 6 factorial. And here I am left with just 1 by b. This will be equal to 11 factorial upon 4 factorial into 7 factorial. And here I am left with a in the numerator. So 11 factorial cancels out. Now see, 5 factorial and 6 factorial. When you will solve this, you will get AB is equal to 7 by 5. All right. So the answer, when you solve this part, you can solve this as, you can write 5 factorial as 1 5 into 4 factorial. Let 6 factorial to be as it is. This was 1 by b. Now this 1 by 4 factorial, 7 into 6 factorial, and here it is a. All right. So 6 factorial cancels out. 4 factorial cancels out. So you will get a into b. A into b will be equal to what? That will be equal to 7 by 5. So your option number D is the correct option. Now you have to tell in this question number of terms that are integers in the expansion of this term. You have to tell how many terms will be integers. So how you will see? Again, you will just see the general term. So t, what will be your general term? Your t r plus 1 will be what? 35 c r. Your general term will be 35 cr. A, what is your A? A is your 7 to the power half. So 7 to the power half to the power 35 minus r. So this will become 35 minus r by 2. Your first term was root 7, which is 7 to the power half. So 35 minus r by 2. Next, this is 5 to the power 1 by 3. So this will be with the power r. So this becomes r by 3. So this is your general term for this expansion. It says you have to find all the terms that are integers. When this will be an integer? This will be an integer. For this to be an integer, power of 7 should be an integer, power of 5 should be an integer. Also, I know my value of r is from 0 till 35 only, because your value of n is 35 and this coefficient is from 0 till the value of n. So this is from 0 to 35, the value of r. Now for this to be an integer, power of 7 and 5 both must be integers. Then only this will completely give me an integer value. Because if this power is not an integer, this will give me a root expression which will not be an integer, and similarly this will not be an integer. So for this to be an integer, this implies r by 3 must be an element of z. R by 3 must be an element of z. For 5, r by 3. So r by 3 should be an integer. So this implies r should be a multiple of 3. R should be multiple of 3. Now, when r has to be a multiple of 3, r is from 0 to 35. What are the possible choices for r? This implies r can be so r can be equal to 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and the last value that R can take is 33. By this condition, from 5, I get R can be these particular values. Now we have to deal with this as well. For this, 35 minus R by 2 should also be an integer. For this to be an integer, this should be divisible by 2. 35 minus R should be divisible by 2. Now, if R is odd, if R is odd, if R is odd, we can only divide then. If R is odd, it is valid. If R becomes even, take any even number. So, even number when subtracted from an odd number will give an odd number and it will not be divisible by 2. So, if R is odd, it is only possible. If R is even, it is not possible. So, R can be only even. So, this was the condition from 5 power. This is the condition from power of 7, that R has to be what? R has to be odd. So choose what are the odd values among these values. So my 3 is allowed, my 9 is allowed, my 15 is allowed, 21 is allowed, 27 is allowed, and 33 is allowed. 1, 2, 3, 4, 5, 6. I get only 6 values. So answer is option number C. We get only 6 values. There are no 7 values. 1, 2, 3, 4, 5, 6. So answer is option number C, 6. This is just a result that we did just now. This is sum of binomial coefficient with n is 23 and sum of binomial coefficient with even index. So sum of binomial, this is nothing but sum of binomial coefficient at odd position. This is sum of binomial coefficient at odd position with n is equal to, with your n is equal to 23. So do you remember the formula for sum of binomial coefficient at odd position? This is same as with even position, and that is 2 to the power n minus 1. So this will be 2 to the power 23 minus 1. That is nothing but 2 to the power 22. So your answer is option number A. This was such a direct question just on the result of properties of binomial coefficients. Now, your next chapter is permutation and combination. So, your next chapter is permutation and combination. So, let us see and introduce how permutation and combination comes. So, when you have an event which can occur in m ways, let's suppose you want to organize an event, it can happen in m ways. And there is another independent events. Let's say you are having two events, one at this place, another at some other place, and they are independent of each other, which means there is no relation, one is not linked to other. If this is happening, that can happen or not happen, and similarly if this event is happening, other can happen or not. So there is no link, between those two events. So if this is occurring in m ways, another is occurring in n ways, then both events can occur together in m into n ways, which means the occurrence of both the events can happen in m into n number of ways. And similarly, if event is occurring in m ways, another event is occurring in n ways, then either event, which means one of the two events can occur in m plus n ways. So in this case, both the events are occurring in m cross n ways. Only one, either of them can occur in m plus n ways. Now similarly, if you have k independent events, let's say I have k number of events which are happening in different places, they are not depending on each other. They are occurring in n1, n2 and nk ways. So total number of ways they can happen is n1 into n2 into nk. Similar to the two number process, k events can happen in n1 into n2 into nk number of ways. Now what is your permutation? Permutation means particular arrangement. Permutation means you are arranging something and in that position matters. That is what is defined as permutation. So arrangement with position matters, arrangement in which particular position matters is known as permutation. So you want permutation of n distinct objects. Let's say I give you n different objects. I want to say you have to arrange them and in the arrangement order matters. Let's say you have three objects, a car, a scooter and a bike. Let's say you have three objects, a car, all right, or let's say something else. I can't draw, I am not good at drawing. Let's say you have three different objects, a yellow color ball, an orange color ball and a blue color ball. All right, I say you have three objects, you want to arrange them. In which ordering matters, in which position the color will be first, that matters. So you can do that in n factorial ways. How you can do that in n factorial ways? Let's say you have to place them in three different positions. You have three balls, you have three positions available. Now first position you can give to yellow as well, you can give to orange as well, you can give to blue as well. All the possible choices will be over. So in this position you have three ways. You can put it yellow, put it orange, put it to be blue. When you have used this position, you have filled this position with particular color, you are short with one color. You are done with one color ball because that will be fixed here now. Now you will be left with two balls. So now next position can be filled in two ways. You can fill either of the two remaining balls here. Now you are only left with one choice. You only have one ball left. That will surely go there. So this is what 2 into 3 into 1. 1 into 2 into 3 or 3 into 2 into 1. So this is nothing but your 3 factorial. 3 into 2 into 1. So similarly, if you have n different objects, if you have n distinct objects, you want to place them in which arrangement matters. You can do that in n factorial ways. Now similarly, permutation of r objects from n distinct objects. Now you have n objects, but you only want to place n objects. You only want to place n number of objects. What you can do? It is npr, n factorial upon n minus r factorial. Or how you can see this? How you can see this? Let's say similar to this. Let's say now you have, let's say you have 5 balls. Let's say you have 5 balls. You have n number of distinct objects. You have 5 distinct objects, but you only want to place r objects, which means there is a particular number that you want. Let's say I want to only place now 4 balls. For 4 balls, I want to place just 4 balls in a particular arrangement. So I only have 4 places to fill. Now the first place again can be filled in 5 ways. You have 5 balls, it can be filled in 5 ways. Next, one place is captured. It is taken by one of the balls. Next will be with 4, then 3 and then it will be 2. So similar to this is this particular formula. What it is? It is n, 5, n minus 1, 4, n minus 2, n minus 2. Until what point we will go? We will go till n minus r plus 1. You can see your r was 4 here. So what will be your n minus r plus 1? N minus r plus 1 in this case will be what? This will be 5 minus 4 plus 1. Right? So this will be what? This will be your 2. So that's why the last value is coming out to be 2. So the last value that you will fill it with is n minus r plus 1. And this particular formula is written and given a pattern which is NPR. NPR, permutation of n distinct objects in which only r objects are to be placed. N distinct objects we have, but we only want to place r objects. So this is the permutation formula NPR. And these are the special cases and values. And when you have permutation with repetition, let me tell you what this is. Permutation with repetition. So let's do it here. Permutation with repetition. So permutation with repetition. What it means? It means something is repeating again and again. Something is repeating again and again. So let's say in this ball example only, let's say you have three yellow colored balls, and let's say you have two blue colored balls. So these balls were added to your permutation, your arrangement, and you have n objects only now. 1 2 3 4 5 6 7 8. Your objects are 8 now, but among them 3 are of same kind, Q, which means 2 are of some same kind. Then your permutation means your arrangement. What arrangement can be done? Now in this case, arrangement can be done in how many ways? In this case, total are 1 2 3 4 5 6 7 8. So arrangement can be done in 8 factorial upon. See how many are repeating. First kind, yellow is repeating 3 times. So divide by 3 factorial. So when you have same kind of objects and they are p times, they are three same objects. Q, this is two blue balls repeating. So this will be 8 factorial upon 3 factorial into 2 factorial. When you see something repeating, you just divide by that particular number's factorial. And in numerator, you take all total numbers and its factorial. So this is permutation with repetition, when some items or some things are repeating again and again. All right. All right. Now, what is circular permutation? Circular permutation means when you arrange certain things on a circle or on a circular table. When you want to arrange something on a circle. So, circular permutation of n distinct objects. What happens is, just like the normal permutation, you just subtract one number here. Why? Because circular permutation can be seen in this manner and this manner as well. So, for circular permutation, one object is fixed. One object is fixed. And then we permute and then we place all the other objects. So for circular permutation of n distinct objects, we have n minus 1 factorial. It is n minus 1 factorial. We fix one object to break the symmetry, because on circle we have symmetry from this side as well, from this side as well. So we break the symmetry by placing and fixing one object and arrange the remaining n minus 1 objects. And then whatever n minus 1 objects are remaining, you just place them, and you can place them in n minus 1 factorial ways. Now, circular permutation when clockwise is equal to anti-clockwise. What it means? It means it does not matter you fill it in clockwise sense or you fill the circle table or circular thing in an anti-clockwise ways. Then it will be n minus 1 factorial upon 2. Since you have two ways in which you can go and both will give same thing, so you divide it by 2. For example, when you bead on a necklace, let's say you have a necklace, you are putting beads inside it. Necklace in a round shape. If you put beads in this manner or this manner, it is same. It does not matter. So then it will be n minus 1 factorial by 2. When clock or anti-clockwise, no matter if you put it in clockwise sense or anti-clockwise sense, it will give you same thing. So what you do, you just divide it by 2. Now, people around a table, if we have different people, no two people can be same. If you have different people, you want to sit them around a circular table, that is nothing but n minus 1 factorial. Again, keys in a ring. If you have a ring, if you want to put keys inside it, no matter if you put it from this side or from this side, it will be same, right? If you put it in circular, clockwise sense or anti-clockwise, it will be same. So it will be n minus 1 factorial by 2. Now these are permutations with restrictions. We are given certain restrictions on objects and then we will see what happens. Objects always together. First case is certain number of objects are always occurring together. What we do? We treat group as single unit. So whatever objects are told or said you to be taken as a single have to be taken together, you treat them as a single unit. Then arrange those units, arrange them within the groups. So formula for this is this. Let me tell you with the help of an example. Let me tell you with the help of an example. For example, let's say you want arrangement of word, let's say what word we can take. Let's take mathematics only. So you want to arrange the word mathematics, you want different arrangement of word mathematics such that M such that E and S occur together. So you want to arrange arrange the words from mathematics such that your E and S, your letter E and S occur together. So what it says? Objects always together. What object I want together? I want my object E and S to be together. Alright. So what the formula says? Treat them as a single unit. So what you do? First, separate out E and S. Treat them as one single object. Separate out ES, treat them as a single object. Write whatever words are left. You are left with M, A, T, H, M, A, T, I, C. So, when you have seen this, you want to have E and S always together. So, it says treat that as a single unit. So, treat E as just one single object. Then arrange the units. What it says? Arrange these units. So, when you arrange these units, when you arrange all these units, now this is one unit or one object. You have these many objects 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is considered as single one unit, one object. Then you have remaining 9 objects. It says treat this as a single unit and then arrange all the units. So this is what? These are 10 objects. So what is the formula? 10 factorial. Since I am not having any positions to fill, I have to fill all the positions. So there are not R given. We have to fill all the 10 positions. So 10 factorial. Now, we will divide by what? We divide by repetitions. Remember, do not forget to divide by repetitions. So I can see my M is repeating 1 and 2 times. So I will divide by 2 factorial. Similarly, I can see my A is repeating twice. So this will be divided by 2 factorial. Then what is repeating? Your T is also repeating 2 times. So divided by 2 factorial. Whatever objects are repeating in how many number of times, we divide it by that. So we have done the arrangement. We have done the arrangement of these 10 objects. Then it says, then arrange within the group, which means you have formed this group, right? You have formed this group, ES, but I can write this as SE as well, right? ES or SC, it just says it has to occur together. It does not mean in what manner, it just have to occur together. So it can be written as ES as well and SC. So now arrangement within the group. So these are two objects. I have to arrange them in 2 positions. So this will be multiplied with 2 factorial. I have two objects. they can be switched in 2 positions. So this will be multiplied by 2 factorial. Whatever you will get here, that will be your answer. Next, objects never together. So when you want objects to be never together, find the permutations, find the number of arrangements for together and subtract it from n factorial, because these are your total arrangements. When you will subtract it from together arrangements, you will get never together. So for this, we will just apply the subtraction formula, or you can say the what we say, you just find the complement formula. You just find the complement and just subtract it. All right. All right. So you can calculate this. Calculate 2 factorial and 1 cancels out. 10 factorial upon 2 factorial into 2 factorial. Calculate this and you will have your final answer. Alright, now let's come to your combination. So combination of R objects when you have total number of N objects. So this is given by NCR. This is the formula which we see in binomial expansion as well. And this is your formula N factorial upon R factorial upon N minus R factorial. So this is your combination formula. Alright, then properties of this. NCR is always equal to NCN minus R. So this is a symmetric case. Why? How you can see this? Your NCR. This will be what? N factorial upon R factorial N minus R factorial. Now when you want to calculate NC, N minus R, this will be what? N factorial upon N minus R factorial. The term written on top, factorial, bottom factorial. So this is N factorial upon N minus R factorial. Then you subtract N minus R. So N minus of this will give you nothing but R factorial only. So these two things are equal. So NCR is equal to NC N minus R for any N and for any R. And NC0 and NCN value is always equal to 1. NC1 value will be equal to N. And when you add 2, this is known as Pascal's identity. When you add NCR plus NCR plus 1. So the next coefficients also you can say in your binomial expansion. You will get N plus 1 CR plus 1. So you don't have to just add just R values. Just add 1 to the N and it will be just R plus 1. So this is known as your Pascal's identity. Also, you can relate permutation with combination. This is your formula. What your permutation said? Your permutation was N factorial upon, what was your permutation? Permutation was N factorial upon N minus R factorial. So your permutation was N factorial upon N minus R factorial. And what is your combination? It is N factorial upon N minus R factorial into R factorial. So you just multiply it here. So R factorial times of NPR is equal to what? Okay, you just multiply R factorial here. So this will be equal to what? R factorial. Wait. We multiplied there, right? R factorial multiplied here and divided here. So this will be equal to R factorial times of NCR. Right? You just multiply R factorial here. That will give you the formula for NPR. So this is NPR is equal to R factorial times of NCR. This we have seen in your binomial coefficient. Sum of all the binomial coefficient is always equal to 2 to the power n. And when you have to sum the alternate binomial coefficient, it is always equal to 0. This is what we have seen in your chapter binomial theorem. Then next, many students many times get confused when to use permutation formula and when to use combination formula. So the difference between permutation and combination. In permutation what happens is your order actually matters. In what order you are putting the objects, in what order you are placing the objects. So this can be arrangement, this can be a sequence, this can be a position, in which the position, arrangement, order matters. That is known as permutation. So you will apply the permutation formulas whenever you see your order is mattering, whenever you have to arrange it or you have to position it, or in some sequence you have to write it or do it. Then in combination, order does not matter. In whatever order you choose, you pick, it does not matter. It is actually the selection of things, it is choosing certain things, or it is grouping certain things. It does not matter in what order you are selecting things, it does not matter in what order you are choosing some stuff, it does not matter in what order you are grouping certain things. So whenever you have these terms, you use combination formulas. Whenever these terms are used, we use the permutation formula. So how to test it? How you can see in quick? So if swapping two objects, let's say you have selected two objects and you swap them, it gives a different outcome. Then it means it is a permutation. But if swapping does not matter, it means it is a combination. For example, let's say I choose 3 students from my class. I want to go for sports day and I want to select 3 particular students. So I can select first student, second and third. It does not matter in what order I select, but I only had to select 3 students. So in that case, my combination will come out. But if I say I have to select 3 students such that first will be wearing this shirt, second will be this, and third will be this. So in that ordering actually matters. So whenever order matters, you take permutation. When it does not matter, you always take the combination. All right. So these are distribution problem, and this is an important one. So this is an important distribution problem. First says what? Distributing n distinct objects into r distinct groups when they have equal size of size k. So let's say you have a basket. All right. In this you have n objects. You have a basket in which you have n objects. You have to send them to r groups. So let's say I have my group 1, you have to send it here, you have to send it here, you have to send it here. So this r can be any number. So you have n distinct objects, you have r distinct groups. All right, let's say there are certain number of balls inside this, and these are different balls because these are distinct objects. So I have drawn with the same color, but these are distinct. All right. So these are n distinct objects inside this basket. You have to send them to n distinct groups. So you have to send balls in this, as well as in this. So you have to send them in these 3 distinct groups. These are your n distinct groups. So first case, equal group of size k. When you have equal sizes, which means if let's say you have 15 balls and you have to send 5 here, 5 here and 5 here, equal size, you have to send equal number in all of them. Then what formula do you use? You use n factorial upon k factorial to the power r. N factorial upon k factorial to the power r, where k is what? K is this, n is equal to rk. So for example, let n is equal to 15 and your groups are r is equal to, you have 3 distinct groups. In this case, you have 15 balls here, you have to send it to 3 groups, 3 different boxes. Then your size will be what? Then your n will be equal to 3 into 5. So this is your r, this is your r, this is your k. It says you have to send them of size k. Size is 5, 5 and 5. In each of them, you will send the size 5. So what is the formula that you will use? The formula to send them is 15 factorial upon k factorial to the power n. Your k is what? K is 5. So 5 factorial to the power r. R is 3 into 3 factorial. So this is the formula. This is the formula when you will have to send n distinct objects into r groups and size of the groups are same. So this is what we do in this case. If groups are distinct, or labeled. Now if you have different distinct groups and they are labeled. In this case, they were same groups, they were not labeled. Now they are given labels, so you will just delete this r factorial from the denominator. All right. Now unequal groups of sizes. When the size does not matter, you can send any size. So n factorial upon their different sizes and the factorial of them. So these are three different cases for your type 1 when you have to distribute n distinct objects. Type 2, this is also known as stars and bars method. What you have to do here? You have to distribute n identical objects. The difference here is the objects are identical and here the objects are distinct. So you have to send n identical objects, but they are to be sent into r distinct groups. So you can see these are identical objects. You have to send them into r distinct groups. So this is also known as stars and bars method, or you can say balls and bins method. And the formula for this is n plus r minus 1 cr minus 1. So this is nothing but n plus r minus 1 cr minus 1. This is an important formula. We will see a question how to use this. So this, let's say you have non-negative integers. Let's say let x1, x2, x3 be three non-negative integers. Negative integers such that x1 plus x2 plus x3 is equal to 5. So what it says, you have n identical objects. So your object now becomes 5. This is identical. This is not changing. This is always fixed. This is 5. You have to send him into r distinct groups. So your distinct groups becomes x1, x2 and x3. So you have to find x1, x2, x3, three non-negative integers such that the sum will come out to be equal to 5. So what is the formula? It says n plus r minus 1. Your n is what? N is 5. Your n is what? N is 5. Because that is fixed identical object. So object is your 5. How many groups you have? 3 groups. 1, 2, 3. So this r is what? 3. So 5 plus 3 minus 1. C r minus 1. So C 3 minus 1. So this will be what? This will be 7C2. So there are 7C2 ways in which you can give these numbers. Let's say I can give this 0, this 5. Then 1, 1, 2, 1, 1, 3. And there are 7C2 ways in which I can give these three numbers and I can tell them to have to be non-negative integers. So stars and bars method is used to calculate this as well. Number of non-negative integers such that sums come out to be equal to some particular value. So in that also we use the formula for your stars and bars method. Now when you have some restriction, when each group will at least get one element, which means this cannot be left empty, this cannot be left empty, this cannot be left empty, then the simple formula is n minus 1 c r minus 1. Then you delete this r from the numerator part, so it will be n minus 1 c r minus 1. When at least one object has to go in them. So then your number of answers reduces because we have put a restriction that each group will get at least one. Alright, so the question from dearrangement part is never asked, but let us just see what dearrangement is and how we see. So number of dearrangement of n distinct objects. What does dearrangement means? Dearrangement means no object goes to its right place. Goes to its right place. And it means every object is going to some different places. Let's say I have 3 envelopes. I have to send them to 3 address. I have fixed addresses, but dearrangement will give what? Dearrangement will not send any letter to the correct address. So when it means no object goes to its right place. So let's say you have 10 envelopes, you want to send it to 10 addresses, but all the envelopes goes to the wrong address. None of the envelope, not even one single envelope goes to the correct address. That it means by dearrangement. So number of dearrangement is given by this formula: n factorial 1 minus 1 upon 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, and so on. It keeps on plus minus alternating sign. So this is the formula for number of dearrangement. Then recursive formula. You can remember this. If sometimes a question comes, you can remember the recursive formula. What is the recursive formula? Dearrangement of n objects is n minus 1 dn minus 1 plus dn minus 2. So for this, you only have to remember 2 values. You can only remember the value of d1 and d2, and then you can calculate the values of next rearrangement with the help of this relation. How we can do that? Let's say you have d1 and d2. You want d3, put n is equal to 3. So this will give me what? 3 minus 1. This will be d3 minus 1. That will be d2 plus 3 minus 2. That will be d1. So I can find d3 in terms of d2 and d1. So this will be what? This will be 2, d2 is 1 plus 0. So from here I can simply calculate my d3 value will come out to be 2. Similarly, you can calculate d4 if you know d1, d2 and d3, and so on. You can find number of dearrangements of n distinct objects. Now try this question. We will see permutation and combination with the help of these 3 to 4 questions which I have for you better. Doubts, okay. Try these questions. I am here and sitting for 2 minutes. Try these questions. Try this question. Anup, I did saw your doubt. So your doubt says actually what? Your doubt actually says you have a garland, or say it's a circular arrangement. Then you fixed a diamond here, right? You fixed a diamond. So you have fixed a position. Now, if you have n distinct objects, let's say now you have n minus 1 or n distinct objects and you want to place them. So you have fixed this. So the arrangement will not matter. It will be like a linear permutation only because we have already fixed the value. So now if you have n different objects, let's say now you have n objects, and if you want to fix them, so that will be fixed, that will have n factorial arrangement only because we have fixed, you have a reference point. Now if you have n different objects, let's say these are n distinct objects, then these distinct objects can be filled here, but since we have fixed this, this will just behave like a normal permutation. The formula was n minus 1 factorial, but if you have now n objects, so this will be n factorial. All right. Now in second scenario, if all the beads are same, if all the beads or some beads are same, so you will only use all the permutation formula because you have fixed a diamond, right? You have fixed a point, so this is your reference point. So you got a reference point or you fixed an object, so this will behave like normal permutation and you will apply all those formulas for this. All right. So this question, yes, anyone? Anyone? This question, what it says? The question says an examination consists of 10 MCQ questions. So there are total number of 10 questions in an MCQ exam. Each question has 4 options. Every question has 4 options, out of which only one is correct. Then every question a candidate earns 3 marks if he is choosing the correct options. So 3 marks are for the correct option and -1 is for choosing the wrong option. Now assume the candidate answers all the questions by choosing exactly one option. So what it says, we are given a condition that candidate answered all the question. He did not left any question. Then the number of combinations we have to tell of the answers that can earn the candidate a score from this particular set. So we have to tell what different combination of answers the candidate will give so that his score will lie in this particular set. So we will form certain equations depending on the given conditions. So let correct answer be, let correct questions is solved be, let correct questions is solved be C. Let C be the correct number of questions is solved, and then let incorrect or wrong incorrect questions he solved be W. So we have let that the correct question that is solved are C, incorrect are W. So in the question it is given that total number of questions are 10 and he questioned all the answers. It means he answered to all the questions. So whatever the correct or incorrect will be, total will be always equal to 10. So from here I get my first equation, correct plus incorrect. Total questions will always be equal to 10. And since he answered all, correct plus incorrect will always be equal to 10. Next, we have to see the score. If he is correcting C number of correct questions are C. For each correct, he is earning a marks of 3. So for this, he will score 3C. If we have answered, let's say 6 correct question, so he will attain 3 into 6, 18 marks. Alright. So if he answered C correct answers are done, so he will earn a score of 3 into C. Then you will subtract what? The negative score, which is minus W. This will be his total score. Let S be the total score. So S is total score. This is the total score of the student. So I have two equations. In this we have done in terms of score. In this we have done in terms of the answers. So now substitute. W is equal to 10 minus C. So 3C minus 10 plus C should be equal to what? His score. So from here I will get 4C is equal to S plus 10. So from here C should be equal to S plus 10 by 4. So the number of correct questions that he will attempt will be S plus 10 by 4. So these are the number of correct questions that he will attempt. Now, this is a natural number because these are questions that he is attempting correct. Now C is a natural number. C is a natural number. Why? Because these are the number of questions that he is solving. So for this to be a natural number, S plus 10 must be divisible by 10. For this to be a natural number, this implies S plus 10 must be divisible by 4. Because if not, then C will not be a natural number and this will not be a valid equation. So S plus 10 must be divisible by 4. Check from the particular given options. If what values of S are valid? 15, 16, 17, 18, 19, 20. For S is equal to 15, my S plus 10 is 25, which is not divisible by 4. So this symbol I am using as not divisible by 4. This is not divisible by 4. So for other values also you will check. You will only get for S is equal to 18. For S is equal to 18, your S plus 10, which will be 28, it will be divisible by 4. So the only possible choice, only possible score is 18. So I got my possible score. The only possible score that I can score is 18. So S is only equal to 18 is allowed. So what will be the number of correct questions? So number of correct questions will be equal to 7. When you will solve this, number of correct questions will be 7. This implies number of incorrect questions will be 3. So I got my number of correct questions, number of incorrect questions. Now there are total 10 questions. Among 10 questions, 7 has to be chosen and they have to be correct. Does order matter here? Does order matter? If I am giving my first answer is correct, then third answer, then fifth, does order matter in the scores? No, order does not matter. It does not matter if the first answer is correct or third or fifth or 10th. It does not matter. So out of 10 questions, 7 has to be correct. So we will apply the formula for combination. We have 10 objects. We have to choose 7. So for correct, we will choose 10C7. We will see 10C7. So these are the combinations in which I can pick up 7 correct questions. Now when I have already picked 7 correct options, does I have any choice for choosing the incorrect options? Do I have any number of possible ways to choose incorrect options? No. The remaining 3 will only be incorrect. There will only be one choice that all 3 are remaining are incorrect. So for this I have these many choices, but for this I only have one choice because I have already chosen which of the 7 questions will be correct. So remaining 3 has to be incorrect. So there is only one choice for them. So this is the choice for correct questions. Now for correct questions, how many options are available to you? There is only one correct option available to you. Now only which is only what? So yes, this has 4 options. It has 4 options and it is an MCQ based question paper. So which means all the options only one will be correct and rest 3 will be wrong. So for this, how many option choices do you have? Only one option choice. For these 7 questions, I only have one choice to choose my option. But here, for 3 questions, I have 3 choices to choose the incorrect question. So from here, for incorrect options, I have 3 choices. So each 3 incorrect one can have any 3 choices for being incorrect. So this will be 3 into 3, which is 27. So I have 27 ways to choose incorrect options. But for correct options, I only have 10C7 ways. So this will be what? 10 factorial upon 7 factorial into 3 factorial. So this will be 10 into 9 into 8 upon 3 factorial. So this will be 3 into 2. All right. So this will be giving me 3. This will give me 4. This will give me 120. Now, they are independent. Correct options, correct answers, incorrect answers. They both are independent. So 120 into 27. So you will do what? You will do 120 into 27. So your answer and option will come out to be 3240. You just do 120 into 27 because these two are independent. So 120 into 27. So you are getting what? Did I make some? Okay, this will be 2. So this will be 3240. So the correct answer is 3240. All right. Next, this is a very easy question. Please try this. Try this. This is a very easy question. Everyone, please try this one. So try this question. What it says, number of arrangements of letter parallel such that P and R are always together. So this is same as the mathematics question that I told you. So it says P and R has to be together. So treat P and R as a single block. Treat them as a single unit. What is left? You are left with A, L, L, E, L. So P and R should be always together. Your remaining positions are to be filled by, treat this as a single unit, then 1, 2, 3, 4, 5, 6 and this 7. We have total 7 units. You have to arrange these 7 units. So what is the formula to arrange these 7 units? 7 factorial. Repeating. Which one are repeating? A is repeating twice. So divide by 2 factorial. L is repeating thrice, 3 times. So divide by 3 factorial. Now this is, we are done with the arrangement of this when we have treated this as a single block. Now among this also, we can arrange this as PR or RP. So for this you have 2 factorial choices. If there were 3 here, so we have 3 factorial choices. So multiply it with 2 factorial. So 2 factorial cancels out. 7 factorial upon 3 factorial. What it will be? This will be 7 into 6 into 5 into 4. This is what? So this will come out to be 840. So you have 840 arrangements possible for this question. Now next, n be the total number of integer solutions to this equation where all these are non-negative and not divisible by 3. So this we will do by stars and bars method. This is your question which we will use by stars and bars method, because it says we have to find the solution of this. It has to be non-negative, but here an extra condition applies. They are not divisible by 3. So the numbers x1, x2, x3 are not divisible by 3. So let us first solve this problem. Let us solve the problem of not divisible by 3. So now we know I can write, or xi can be written as, x1 can be written as 3 times of k1 plus r1. x2 can be written as 3 times of k2 plus r2. x3 can be written as 3 times of k3 plus r3. I can write any number in terms of 3. This is your what? Question remainder theorem. So these are the remainders. by quotient remainder theorem, I can write these numbers x1, x2, x3 as multiples of 3 by your quotient remainder theorem. It says not divisible by 3. For it to be not divisible by 3, my values of Ri should be 1 and 2. Because as soon as this R1, R2, R3 will become 0, 3 or any other number, it will be divisible by 3. If let's say I take 4, I can write 4 as 3 plus 1. So that will be curved inside this. That will become 3 times of some k2 plus r1. That will be 1 only. So my remainders, my possible remainders are 1 and 2. My possible remainders are 1 and 2. So substitute them there. Substitute these numbers there. What will be your equation now? Your equation will be 3k1 plus r1 plus 3k2 plus r2 plus 3k3 plus r3 is equal to 30. Take all the k terms together, r terms together. So you will be getting 3 times of k1 plus k2 plus k3 is equal to 30 minus r1 plus r2 plus r3. This is what you will get, just taking to the left and right. Now divide it by 3 as well. So k1 plus k2 plus k3. This can be equal to 30 minus. Let us call this as s upon 3. Let this be s. So let r1 plus r2 plus r3 is equal to sum s. This is a sum of 3 numbers r1, r2, r3. I have let it to be equal to s. Now the values of k1 plus k2 plus k3 is equal to this. This is in terms of this sum s. Now see, what are the valid choices for Ri? It is only 1 and 2. So your s, minimum s can be, if all are 1. So minimum s can be 3, next it can be 4, then it can be 5, and maximum it can go to 6. Because if all the remainders are 2, 2, 2, maximum sum will be 6. So possible choices for s are 3, 4, 5 and 6. So possible values of s are 3, 4, 5 and 6. Now these are the possible values of your sum because Ri are from 1 or 2 only. So this sum can be minimum 3, maximum 6. No other values this sum can take because it is R1 plus R2 plus R3. Now let us check for different values. When s is equal to 3. When your sum is 3, what will be your k1 plus k2 plus k3? So your k1 plus k2 plus k3 will be equal to 9. This is the case 1. When sum is equal to 3, k1 plus k2 plus k3 is equal to 9. And what are the choices for r? It can be only 1, 1, 1. So for this, r1 is equal to 1, R2 is equal to 1 and R3 is equal to 1. These are the only possible choices for this remainder values. So there is only one fixed value for this R. So from here I'll get only one choice. All of them has to be equal to 1. Now this is what I have to solve. This is what my actual equation is converted into. This is what I have to solve. K1 plus K2 plus K3 is equal to 9. And since these all were positive, K1, K2, K3 has to be positive because remainders are also positive. So all these values has to be positive. So all these are non-negative integers. These are also non-negative integers. So apply the bars and stars method. Apply the stars and bar method. This is your n. You have 3 objects. You have 3 places to fill them. You have n as 9. So applying the bars and stars method, what will be the solution to this? This will be 9 plus 3 minus 1 c times of 3 minus 1. So this will give you 11c2. This will give you 11c2. Let's analyze the case 2. Let's analyze the case number 2. Case number 2, when s is your 4. When your sum is coming out to be 4, this number will be 30 minus 4 by 3. That will be in decimal. So this implies 30 minus 4 by 3 is not an integer. But all these k values are non-negative integers. Now sum of 3 integer will also be an integer. So k1 plus k2 plus k3 can never be equal to this. K1 plus k2 plus k3 can never be equal to this because these are integers, but this is not an integer value. Similarly for case 3, when your sum is equal to 5, when your sum will be 5, then also 30 minus 5 by 3 will not be an integer. But since all these are integers, they will sum to an integer value. So this case is also not valid. Now remaining case is case number 4. Case 4, when your sum is equal to 6. In that case, what I will get? In this case, I'll get k1 plus k2 plus k3 is equal to 8. In this case, I will get the value as 8. Now apply the stars and bars method again. This will be 8 plus 3 minus 1 c times of 3 minus 1. So this will give me 10c2. Now you have to just calculate the value of 11c2, 10c2, add them, you will have total number of solutions. So you have to just add them, you will find total number of solutions. What is 11c2? This is 11 factorial upon 2 factorial into 9 factorial. So this is 11 into 10 by 2. So from here I will get 55. From this case I will get 10 into 9 upon 2. From this case I will get 45 values. So 55 plus 45. So your total will be 100. So total number of solutions to this is 100. So your answer is 100. All right. All right. All right. Let's move on. Let's move on to your next chapter, which is quadratic equation. Now this is also a scoring chapter. If you are a bio student, please do this chapter and you can have good score from this chapter as well. All right. So let us start with your chapter quadratic equation. So how does a general quadratic equation looks like? So your general quadratic equation is ax square plus bx plus c is equal to 0. Now the coefficient of the highest power, which is x square, it cannot be equal to 0. Why? Because it is quadratic. Quadratic means second degree equation, power will be 2. So if this a is 0, this will not be a quadratic. So simply a should not be equal to 0. And the roots of these are given by this formula. This is your quadratic formula or Sridharacharya formula, which we call it as. So this is your solution or roots of this quadratic, and discriminant is given by d, which is b square minus 4ac. Now condition for roots to exist and what is the nature of root. If discriminant d is greater than 0, you will have real and distinct roots. If your discriminant is greater than 0, you will have real and distinct roots. If d is 0, you will have real but two equal roots. They will be same roots. If it is less than 0, then you will have complex conjugate roots. You will have two complex roots which will be conjugate of each other. If d is greater than 0 and it is a perfect square, which means d is of the form 9, 16, 4, 25, then you will get rational and distinct roots. It will give you rational roots because under root term will come out and it will be a rational number. Then if d is greater than 0 and it is not a perfect square, then you will have irrational and distinct roots, which is very easy to observe with the help of this particular formula. All right. Now this is your sum and product of roots, or you can say your Vita formula, which is if alpha and beta roots of this equation, then sum of root is minus b by a, which is minus times coefficient of x divided by coefficient of x square. Product of roots is constant term upon coefficient of x square. So this is your with a formula which is sum of roots and product of roots, and forming equation from the roots. If we are given two roots, you can directly form the quadratic equation as x square minus sum of the roots into x plus product of the roots is equal to 0, because this gives you sum of roots, this gives you product of the roots. So this is how you can form the equation as well. So your next come up is the standard parabolic, which we will see how you will see a quadratic as graph. So standard parabola, you can consider this as a function. So it will be simplified, and you can write the quadratic in this manner as well. You can just manipulate, do some transformations, and you can find the quadratic can be written in this particular manner as well. So how you will see this? This is a parabola. This will be a parabola. This will be a parabola of this form. It can be below, above, anywhere, but this will be a parabola of this form. So y is equal to this is a parabolic shape of this form with vertex coordinate. Vertex means the lowest point or the highest point. So the vertex coordinates will be what? The vertex coordinate will be, the coordinate of this point will be minus b by 2a comma minus d by 4a. So this can be in this form as well, or this parabola can be of this form as well. So the coordinate of vertex, vertex means the highest or the lowest point, the coordinate of the vertex will be this. All right. Then axis of symmetry. Axis of symmetry means by what line it will be same. So if you see the graph, if you draw a line here, if you draw a line here, oh wait, if you draw a line at this particular point, if you draw a line at this point, you can see the graph to the left and right. The graph to the left and right of this line is same. You can reflect it and you will get the same graph. So this is known as axis of symmetry. Axis of symmetry means about what line your graphs look similar. So axis of symmetry for this is x is equal to minus b by 2a. Since your vertex was passing through this point minus b by 2a, so the equation of this line is x is equal to minus b by 2a. So this is your axis of symmetry for a quadratic, and this is how we can see this as a standard parabola. Now maximum and minimum values of a quadratic. So this can be treated as a function ax square plus bx plus c if your a is greater than 0. If your value of a is positive, then we will have a minimum. And what will be that minimum value? That will be nothing but minus d by 4a. We will have this minimum minus d by 4a, and it will be at this point minus b by 2a. Similarly, if a is less than 0, that is the case in which your graph will look like this. When you have a less than 0, this is how your graph of quadratic will look like. Then you have the maximum value, and that will be same as minimum. Values will be same, point will be same. It's just that it will be the minimum. In this case, it will be the maximum. And this is how you can find the extreme value, which is c minus b square by 4a. Now condition for the root location, where your roots will be located, where they will be formed. So for that we have certain conditions. So let's say you have a quadratic ax square plus bx plus c, and its roots are alpha and beta. Now if both the roots are greater than some value k, what this condition will be? This condition will be actually, this is your quadratic. This is your quadratic. Let's say these are the roots alpha and beta. So these are your roots alpha and this is your root beta. It says both the roots are greater than the value k, which means k will lie left to these both the points. So k will be somewhere here to the left of both the points. So for both the roots to be greater than a value k, your discriminant should be greater than equal to 0. Why? Because roots are existing, so discriminant has to be positive. Discriminant has to be positive or 0. For roots to exist, this is the condition already. Then your minus b by 2a should be greater than k. What is your minus b by 2a? Minus b by 2a is your vertex, and I can clearly see my vertex that will be somewhere here. So this should be always greater than this value k. Then a times of fk. This a coefficient of this, when you multiply with this value f at the point k, which means this means a into, it will be a k square plus bk plus c. This complete value a into, when you put fk, this should be greater than 0. So this should have same sign as a. So if a is positive, so this is greater than 0. Alright, so these are the three conditions for root to be located and it to be greater than this value k. Now similarly for less than k. For less than k, your k will lie here. For less than k condition, your k will be here and roots are less than k. So in this case, this is always true. The vertex will be now less than, and this condition are same in both the cases. So these two conditions are same, these two conditions are same, only vertex will now lie to the left of it, so it will be less than the vertex value. Alright, now roots on opposite side of k. So one is greater than and one is less than. So this is the condition when these are your roots alpha, beta, and your k is lying somewhere here. So one root is less than it, one is greater than it. So this is the condition, roots on opposite side of k. One is to the right of it, one is to the left of it. So only condition is a times of fk should be less than 0. A times of fk should be less than 0. That is the only condition for roots to lie one to the left and one to the right. Now both in some interval k1 and k2. So both the roots to lie in some interval k1 and k2. So these are your roots alpha, beta. Now if both the roots have to lie in some interval, so let's say this is your point k1, this will be your point k2. So if the roots are lying between these two values k1 and k2, the condition from these two cases should be valid. So discriminant should be greater than equal to 0. K1, this K1 should be less than the vertex, and this should be less than the second point K2. Then A times of this should be greater than 0. A times of this should be greater than 0. So all the combination of these two conditions will be valid here because roots are lying between this and this value. So this is the condition for location of root. Now exactly one root in K1 and K2. It says now exactly one root will lie between these interval. So what it means for condition number 4. So for this we have, these are your roots, exactly one root in this particular interval. So your interval will be of this form. Your K1 will be here, your K2 will be here. So exactly one root is between K1 and K2, or it can be K1 here and K2 here. Exactly one of the root will be between this interval. So for that the condition is function value at first point and at second point should have opposite signs. It should always be less than 0 when you multiply both the function value at that point. Alright, now condition for common roots. Let's say you have two quadratic equations, ax square plus bx plus c is equal to 0 and a dash x square plus bx plus c dash is equals to 0. For them to have a common root, this is the condition. This is the condition for two equations to have a common root. So let's say these two have a common root 3. So if they have a common root, this condition should be true. This condition should be valid. If this is true, then these equations will have a common root. They will have a same root. Alternatively, how you can approach? If alpha is a common root, so alpha will be a root of this. Alpha will be a root of this as well. Alpha will be root of both the equations. So put alpha in both the equations. then eliminate alpha by cross multiplication. You know how to write the cross multiplication of 3 terms. We write it in 4 terms and we do cross multiplication. Do that and you can eliminate the value of alpha. Then also you will come back and you will see this condition is only coming out in that case as well. Next, what are cubic equations? Again, we know cubic equations, if the roots are alpha, beta and gamma, what is a cubic equation? It is of the form ax square plus, ax cube plus bx square plus cx plus d. So this is a cubic equation. If we have a cubic equation, then if alpha, beta, gamma, it will have now 3 roots. If it has 3 roots, alpha, beta, gamma, sum of roots will be minus b by a. Sum of roots taken 2 at a time. Alpha, beta plus beta, gamma plus gamma, alpha. So 2 roots taken at a time, it will be c by a. And if all the roots are taken together, which means product of the roots, it will be minus d by a. So these are the conditions for cubic equations. Sum of roots taken 2 at a time, and product of the roots. And this is how you can form the cubic equation. X cube minus sum of roots into x square plus product of roots taken 2 at a time into x minus alpha, beta, gamma is equal to 0. So this is an important result which can be used at a times. What it says, if this is a general polynomial an xn plus dot 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 till a naught. So this is a general polynomial equation with integer coefficients. So remember, the coefficient has to be integers. So all these coefficients, these are integers. By this what it means? It means an minus 1, all these till a naught. All these coefficients are integer. Then rational root p by q. It will have a rational root p by q if it has a rational root p by q. So listen carefully what it says. If you have a general polynomial with integer coefficients, if it has a rational root of the form p by q, then p must divide a naught, p must divide the constant term a naught, and q must divide the highest coefficient a n. So p must divide a naught, p must divide a naught, and q must divide the highest coefficient, which is your a n. Alright, so this is the rational root theorem. We will see a question on this. It was a direct application of this theorem in one question that was asked in your PYQs. Do this question. You are asked, what values of t does this equation have only real roots? So this is a cubic equation. It should have only real roots. So you have to tell what will be the condition on t for this to have only and only real roots. Do it. So by observation, 1 is a root. You can clearly see 1 is a root. Why and how you can see that? Just put value of f1. You will get 1 plus t plus 2 minus t minus 3. T cancels out, 3 minus 3 is 0. So by observation, 1 is always a root. 1 is always a root. So this equation x cube plus tx square plus 2 minus tx minus 3. This can be written as x minus 1 is taken common, and you can write this as x square plus t plus 1x plus 3 is equal to 0. So if 1 is a root, I can take x minus 1 factor out, and this is the remaining terms that will be left for your equation. This will be the rest of the terms that you will get as your equation. Now, for it to have only real roots, the discriminant of your quadratic should be greater than or equal to 0. For it to have only real roots, x square plus t plus 1 x plus 3. For this to have only real roots, this is your quadratic now. For this, discriminant should be greater than or equal to 0. So let us just compute the discriminant. Discriminant will be t plus 1 whole square minus 4 into 3. This should be greater than or equal to 0. So this says t plus 1 square should be greater than equal to 12. Take square root on both the sides. So this will give mod of t plus 1 should be greater than or equal to 2 root 3. So this is what you will get. Mod of t plus 1 should be greater than or equal to 2 root 3. So when you open the mod, you will get t plus 1 should be less than equal to minus 2 root 3, or t plus 1 should be greater than or equal to 2 root 3. These are the two conditions that will be formed when you open the mod. So from here, you will get t should be less than equal to minus 2 root 3 minus 1, or t should be greater than or equal to 2 root 3 minus 1. So these are the conditions that t must satisfy for it to have 3 real roots. Now see, this is a negative number. I don't have any negative number in my option. I have minus 1, but minus 1 will be greater than this, but t has to be less than minus 1. So this option is discarded. This is discarded. This says greater than or equal to 2 root 3 minus 1. 2 root 3 minus 1. So this is 0. This is again not possible because this is greater than, this is not less than 0. So now when you evaluate this value, this will come out to be greater than 2. So when you evaluate this value, this will be coming out to be less than 2. So the only option is t is equal to 4. So just evaluate this value, 2 root 3 minus 1, approximate value. You will see the only possible choice is 4, and for this there are no possible choices. So t has to be equal to 4. All right. Next, this is a very easy question. Please do it. Px is given to be this. It is a quadratic polynomial, quadratic equation. Coefficients are b and c. You are given p of 1 is equal to 5. P of minus 1 is equal to 3. You have to tell the product of root of this equation. You have to only tell the product of root of this equation. So you are given two conditions. P1 is equal to 5. So just put the value. So you will get what? You will get 1 plus b plus c is equal to 5. When P1 is equal to 5, this is the condition. Then P of minus 1. What will be P of minus 1? That will be 1 minus b plus c. And this will be equal to what? This will be equal to 3. That will be equal to 3. From here I'll get b plus c is equal to 4. From here I'll get minus b plus c is equal to 2. Two equations in b and c, solve them, just add them. When you will add them, you will get 2c is equal to 6. This directly gives you c is equal to 3. So when you have value of c, so your quadratic will be x square plus bx plus 3, and we know product of root. So your product of roots are what? Products of root is what? C by a, which is 3 by 1. So product of root is 3. So your correct answer is option number B. Such an easy question. This can be done by a 10th level student as well. Next, you have to tell the number of real roots of this equation. How you will approach this? Now, if this is given in quadratic, you will not understand in your exam time, but this is a quadratic equation question itself. So what you can do, what you have to do, you have to just let x cube is equal to t. When you do that, you will get x to the power. When you will do that, you will get t square plus t minus 1 is equal to 0. This is what you will get. T square plus t minus 1 is equal to 0. So you have to tell the number of roots of this. So solve the roots and find the roots of this. So t will be minus 1 plus minus under root. B square minus 4ac will give you root 5 upon 2. So the value of t are minus 1 plus root 5 by 2 and minus 1 minus root 5 by 2. These are the two possible values of your t. Now t was equal to x cube. So from here I have x cube is equal to minus 1 plus root 5 by 2, and the second condition that is I have is x cube is equal to minus 1 minus root 5 by 2. Now your x cube graph you must have done in your lower classes or even in your classes as well. So your graph of x cube, you know, it is a 1 1 function. So your graph of x cube is what? This is your graph of x cube. This is your graph of x cube, right? So this will take value minus 1 plus root 5 by 2. This is some value, positive value. Let's say this is here somewhere. So this will attain this value only once. Again, x cube is equal to minus 1 minus root 5 by 2, a negative value. It will only attain this value once at this point and this positive value at once. So the solutions are only 2. One here, one here. So total number of solutions or real roots are 2. So this equation will have only 2 real roots. Next come up. I am giving this question as a homework. This is similar to the previous one. Just similar to the previous one. Do this as a homework. First solve this quadratic. Let fx is equal to t. So you will be having a quadratic t square minus 18t plus 8t is equal to 0. When you will solve this quadratic, you will have values of fx. You will have values of fx. Put that here. Solve for x. You will have two quadratic equation for x. Then you have to just tell the number of solution. Then you will solve those two quadratic and have number of solution. So this is the hint. Let fx is equal to t. After solving this, you will get two values of t. You will put it here. You will get two equations in x. Solve them. Get the number of solutions. All right. Let us come to your next chapter, the 7th chapter, which is your complex numbers. So we will study complex numbers and we will see how we can approach complex numbers. So what is the imaginary unit first? So when we were studying about complex number, what came into picture? We wanted to solve this type of equation. That's where the origin of complex number actually happened. Now we wanted the roots of this equation, but in real numbers, we were not able to find any number that will give the root of this equation. So an imaginary unit was introduced that is called as iota, and its value is considered to be under root minus 1. So this was introduced as iota as under root minus 1. Now when you square it, I square will come out to be equal to minus 1. So from here, I square plus 1 is equal to 0. Now this becomes a solution of this equation. So this imaginary unit was introduced and this was from where the complex number origin started. So now complex number standard form is seen as z is equal to a plus ib, where this I is your imaginary unit iota and a or b are real part and imaginary part. Also both of them, a and b, are your real numbers. So a is a real number, b is a real number, this is an imaginary unit and this is called as the real part, this b is called as the imaginary part. Now powers of iota, as we saw, iota is what? Under root minus 1. So iota to the power 1 is iota only. When you square it, you get minus 1. Cube it, you will get minus 1. Then fourth power will give you 1. And the pattern will keep on following. At 4n power, it will give you value 1. 4n plus 1, it will give you iota and so on. So from here we have a result as well. iota to the power 4n plus iota to the power 4n plus 1 plus iota to the power 4n plus 2 plus iota to the power 4n plus 3. This will always give you sum as 0. Why? Because this will open as 1, this will open as minus iota or plus iota, this will open as minus 1, this will open as minus iota. From here you can clearly see. So this will be 1 cancels out, iota cancels out, this gives you value 0. So this is an important sum formula that you can remember. If you add four consecutive powers of iota, that will always give you sum as 0. Next, addition and subtraction of complex numbers. So let Z1 and Z2 be two complex number. It is of the form A plus IB. This is of the form C plus ID. How you can add them? You will add real part with real part, imaginary part with the imaginary part. So A plus C plus iota B plus D. So real part with real, imaginary part with the imaginary part. Same for subtraction. A minus C plus iota B minus D. How you will multiply two complex numbers? You will take the factorized form. This is the factorized form. Just like you multiply A plus B and C plus D in real. When you multiply these brackets, you will multiply them in the same following manner. So this is how you multiply them, and this is what the final outcome comes out to be. So multiply them as a normal numbers in factorized forms. Multiply them and this is what you will get. Next, division. So Z1 upon Z2. It can be written as this, but in denominator we don't like to see complex numbers. In denominator we don't like to see the complex number. So we will multiply the numerator and denominator by the conjugate of denominator. Because in division we don't like to see a complex number sitting in the denominator. So multiply the numerator and denominator by its complex conjugate. So if you don't know about the conjugate, we will understand it further. So multiply with the conjugate in numerator and denominator. This will be your final complex number. Now this does not have a denominator in the form of a complex number. This can be seen as some new complex number E plus IF. So we wanted to represent every complex number in the form A plus IB. So that's why we multiplied and divided by the complex conjugate, and this is again of the form E plus IF. So that's how a complex number division is done. Next come up is complex conjugate. What is the conjugate of a complex number? So let's say you have a complex number A plus iota B. Its conjugate will be what? It will be A minus iota B. So whatever imaginary part is there, whatever is being with the imaginary part, you give it a negative sign. Real part, leave it like that. Whatever is with the imaginary part, give it a negative sign. So if it is a positive, it becomes negative. Again, if you take the conjugate here, it will again become positive. So whatever is with the imaginary part, give it a negative sign. So geometrically, it means what? It means reflection about the x-axis. So geometrically, how complex numbers are seen? In 2D plane, this is your real axis, this is your real, this is your imaginary. All right. So this is, let's say, your A comma B is sitting somewhere here. So this is the representation of complex number Z is equal to A plus IB. This is of this form, A plus IB. So what it says, the conjugate means you are reflecting it about the real axis. So what it does, it just reflected it about the x-axis and this numbers comes down. So this became A minus B. So you are taking the reflection considering real axis as a mirror. So you just reflected it. So this will be the complex conjugate. So this is nothing but this is your Z conjugate. Live all right. So this is your conjugate. Now what are the properties of your conjugate? If you add two complex number, take complete conjugate, you can separate the conjugate and take it like that as well. So Z1 plus Z2 conjugate is nothing but Z1 conjugate plus Z2 conjugate. Similarly for subtraction, similarly for multiplication, similarly for division. So if you want to take the complete conjugate of these, you can separate them and take the conjugate. Now, conjugate of a conjugate. This is Z bar to the bar. So when you take the conjugate again, you will get back your complex number. Why? You will add it, you will subtract 1 here, minus minus will become again plus. And if you take the reflection also, you will reflect it back in the x-axis, so you will get back your original complex number. Now if you have z to the power n, a complex number is multiplied n times, or you can say it is z to the power n. You want its conjugate. So what you can do, you just take the conjugate of z and take whole to the power n. Alright. Now, if you add z with its conjugate, see, if you add these two, imaginary part will cancel out. You will get 2 times of real part. So that is what it says. 2 times of real part is your final output when you add a number with its conjugate. So 2 times of real part or 2 times of a. Similarly, when you subtract them, you will get imaginary. If you multiply them, if you multiply z with its conjugate, you will get mod z square, or a square plus b square. Now real number test. When a complex number will be a real. So z is real. A complex number is real when its imaginary part will be 0, or you can say it will be equal to its conjugate. If z is equal to its conjugate, then we can also say that that complex number will be a real number. Similarly for purely imaginary, if z is equal to its negative of the conjugate, then we will say that the complex number is a purely imaginary number. Now what is absolute value? And this is also called modulus value. Absolute value or modulus of a complex number. So what is your absolute value or modulus of a complex number? It is for z is equal to a plus ib, its modulus value is under root of a square plus b square. If you want to see geometrically, what happens is, this is your complex number sitting here. Let's say this is a comma b. This is your complex number sitting. We draw a circle around it. Now this has this modulus is the distance from the origin. Modulus of z is distance from origin. So this is, let's say this is your complex number z. This is your mod z, which is nothing but distance of that complex number from the origin 0. So that will be nothing but under root of a square plus b square. Then geometric meaning, that's what I explained you. It is nothing but distance from the origin of that complex number. Now these are the properties that your absolute value or the modulus value actually follows. These are very important. Mod z will always be greater than or equal to 0. Since this is a square and root, so this will always be positive, or you can simply say distance is always non-negative. It will always be either 0 or positive. If it is 0, then your number is what? Then your complex number is nothing but it is 0 only, because this is the only point, that will give you the 0 distance. Other at anywhere it will give you a positive distance. Then mod of z is equal to its mod of conjugate is equal to minus times of z mod. So these three values are equal. You take any mod of these three complex numbers, they are always equal. If you have two complex number multiplied and you want their modulus value, you can separate and take the modulus value. That will always give you the same answer. Similarly for division, if you have z to the power n, a complex number raised to the power n, you want its modulus value. You can simply take modulus of z and then raise it to the power n. Now this is your triangle inequality, which is important. Mod of z1 plus z2 is always less than equal to mod z1 plus mod z2. And second inequality is derived from triangle itself. It says mod of z1 minus z2 is greater than or equal to complete mod, then mod Z1 minus mod Z2. And lastly, this is the relationship between complex number, its conjugate, and the modulus. So this is the relationship between complex number, its conjugate, and the modulus. This is the distance formula. If you want two complex number, let's say this is your Z1 and somewhere your Z2 is sitting. So you want Z1 minus Z2. So if you subtract them and take the mod, that will give the distance between Z1 and Z2. So if this is this Z1 minus Z2, the distance between Z1 and Z2, if you take its modulus value, that will give the distance between two complex numbers Z1 and Z2. Alright, now let's look at the argument and the properties of argument. So for a complex number, a non-zero complex number, because arguments is defined for a non-zero complex number, argument is what? It is the angle theta tan inverse of b by a. So tan inverse of b by a, tan inverse of imaginary part upon real part. That is the argument of your complex number. And what is the principal argument? Principal argument means what angles it can go to from minus pi to pi. So principal values that this angle, that this tan inverse can take, the principal values are from minus pi to pi only. Alright, then formulas by quadrant. So the argument of a complex number changes with respect to the quadrants. If you are in your first quadrant, so if you are in your first quadrant, so this is your first quadrant. All right, so if you are here in your first quadrant, second, third, and fourth, if you are in your first quadrant, your argument is given by simply tan inverse b by a. So if you have a complex number here, if you have a complex number a comma b, both will be positive. So what you do, you just take tan inverse of b by a. If you are in your second quadrant, in which a will be less than 0, obviously here this will be some minus a comma b type of number, or if you are considering as a comma b, so a will be a negative number. So if you have some a comma b here, a will be a negative number, so a will be less than 0, b will be greater than 0. Then your angle theta or argument is given by pi minus tan inverse mod value of b by a. So you take mod of these two values because one is negative. So tan inverse mod of b by a and subtract it from pi. Similarly, if you are in your third quadrant, then you do what? Minus pi, minus times of pi plus tan inverse of mod b by a. So in this quadrant, this is how you find the argument, and in your fourth quadrant, your argument formula is minus tan inverse mod b by a. So depending on the quadrant, your argument values are calculated and changing as per this. Now what are your properties of argument? If you have two complex number multiplied together and you want its argument, so you can just add both the arguments. So if you have two different complex number, you want the argument of them multiplied, you just add the argument of individual. For division, it will be subtracted. For z to the power n will come in front and it will be argument of z. This can be seen from your first property only. It is what? This is nothing but argument of z into z n times. So z is multiplied n times, arguments are added n times. So this will give you n times of argument of z. Similarly, argument of z bar, conjugate of z, that is nothing but minus times of argument of z. And argument of minus z is what? It is argument of z plus minus pi. So it can be plus pi as well or minus pi as well. Arguments are only defined up to multiples of 2 pi. Why? Because in a quadrant system, this angle completes at 2 pi. So arguments are defined up to multiples of 2 pi only. After that, it keeps on repeating. So arguments are defined up to the multiples of 2 pi. Now this is actually important part. Any complex number, you can write any complex number as r cos theta plus I sin theta. Why you can do that? So let's say this is your complex number, which is a comma b. So you represent it on a circle. Right? So the distance it covers, this distance is your mod z. You can call it to be the radius of this circle. Now, in the polar coordinates, the point on a circle, in polar coordinates, the point on a circle A, this can be seen as r cos theta, B can be seen as r sin theta. So in the polar coordinates, point on a circle are r cos theta and b r sin theta. So when you replace this here, your z can be written as r cos theta plus I r sin theta. Your A is r cos theta, your B is r sin theta. So r cos theta plus I times of r sin theta. And this is also sometimes read as cis theta. So this complete term is also sometimes read as cis theta. Now where r will be what? R will be mod of z only. And theta is what? Theta is your argument of this complex number. Theta is actually this angle theta, which is your argument of the complex number. Conversion formula. How you can convert from Cartesian to polar and from polar to Cartesian. So if we have Cartesian to polar form, your r or mod will be what? Under root a square plus b square, and theta just now we saw it will be what? Tan inverse b by a. Depending on the coordinate, you will find the value of theta, and your r will be under root a square plus b square. Now polar to Cartesian form, a is what? R cos theta, b is what? R sin theta. So from polar to Cartesian, you can form z as r cos theta plus I r sin theta. Now this is a critical formula. This is an important formula, which is Euler's formula. Now your e to the power I theta. E to the power I theta is nothing but cos theta plus I sin theta. If you have e to the power I theta, it is nothing but cos theta plus I sin theta. So when you put the value here, just what you will do, you will just put this value of e to the power I theta in the polar form. When you will put this value in the polar form, your Euler form will come out to be z is equal to r e ki power I theta, just by putting this value here. Your Euler form will come out to be z is equal to r e ki power I theta. And these are the relations how you can find cos theta and sin theta in terms of your e ki power I theta. These are the relations for cos theta and sin theta, how you can find these angle values with the help of e ki power I theta. Alright, now next comes your De Moivre's theorem. What your De Moivre's theorem says, for any integer n, if you have cos theta plus I sin theta to the power n, so what you do? You just multiply this n with the angle. You just multiply this n with the angle and this n with the angle here. So your complex number, this is a complex number, you have taken it power with n. So you just multiply these angles theta with this number n. This will be your new complex number, which you don't have to calculate the nth power. This will be your easy calculation. And in exponential form, how you will see this in exponential form? This is nothing but e ki power I theta. This is nothing but e to the power I theta. So e to the power I theta to the power n. Now powers are multiplied, e to the power something to the power something. So powers are multiplied, so it becomes e to the power I n theta. It becomes e to the power I n theta. Now for any general complex number, we know my complex number is of the form r cos theta plus I sin theta. If you want its nth power, if you want the nth power of a complex number, you just multiply r with this. Take r to the power n. Since r is a number and this is again some expression, you are taking it nth power. So r to the power n. And just like in this case, we multiply the angles with n. So this is an important form to find any nth power of a complex number. To find any nth power of a complex number where n is some integer, you can simply use this form and easily find the nth power of any complex number. This is an important, very important concept. Nth roots of unity. So the nth root of unities are solution of what? Your nth root of unity are nothing but solution of this equation z to the power n minus 1. So you have this complex equation z to the power n minus 1. So the nth root of unity are what? Whatever solutions, whatever answers root this equation will give, they are called nth root of unity. And the general formula for your nth root of unities are, so all your nth root of unities are of this form: cos 2k pi by n plus I sin 2k pi by n. You can also read this in exponential form as e to the power 2 pi I k by n. So this is the exponential form formula. This is in the form cos theta and sin theta. So all your nth root of unity are of this form. You just change the value of k. Take k as 0, k as 1, 2 till n minus 1. So you can easily find nth root of any equation of this form. For example, let's say cube root of unity. Cube root of unity. So cube root of unity will be meant what? By cube root of unity we will mean z cube should be equal to 1. We are at nth root. For cube root, z cube should be equal to 1. What will be the general formula? General formula will be zk is equal to cos 2k pi by, now your n is 3. N is 3 for the cube root. So put 3 in the denominator plus iota sine 2k pi by 3. This is your nth root of unity. These are your cube roots of unity. What are the values of k? K is from 0, 1 and 2. Since k ranges from 0 to n minus 1, n was your 3, so it will be 0, 1, 2. Now from here, just put the values. So z0, it will be what? Cos 0 plus iota sine 0. This will be nothing but 1. Cos 0 is 1, sine 0 is 0, so it will be 1. So first root is 1. Second root, this will be cos 2 pi by 3 plus iota sine 2 pi by 3. Who will tell me the value of cos 2 pi by 3 and sine 2 pi by 3? Quickly tell me the value of cos 2 pi by 3 and sine 2 pi by 3. Next will be cos 4 pi by 3 plus iota sine 4 pi by 3. Tell me the values of these cos and sine angles, and then we can write them as a complex numbers. So what is the value of cos 2 pi by 3? Can I not write this as cos pi minus pi by 3? Can I not write cos 2 pi by 3 as cos pi minus pi by 3? So this will be what? This will be minus sine pi by 3, and sine of pi by 3 is what? Sine of pi by 3 is my minus root 3 by 2. So this cos 2 pi by 3 is nothing but minus root 3 by 2. Is this correct? Then sine 2 pi by 3. Sine 2 pi by 3 will be seen as sine pi minus pi by 3. So this will be, sine will remain sine. So this will give me plus iota root 3 by 2. Is this correct? 2 pi by 3 can be written as pi minus pi by 3, right? That is correct. Then sine pi minus pi by 3. Pi minus pi by 3 will be in second quadrant. It will be remaining as sine only, positive, and it will be pi by 3. And sine of pi by 3 is what? Sine of pi by 3 is root 3 by 2. I think this is correct, right? Yes, anyone who can verify and tell me if this is correct or not. Cos 2 pi by 3 and sine 2 pi by 3. Are the values correct? Anyone? Then you can similarly calculate for 4 pi by 3 and 4 pi by 3 cos and sine. So these are your cube roots of unity. What are the properties that nth root of unity actually follows? There are exactly n distinct nth roots of unity. As we can see for cube root also, there are only 3 distinct values for 0, 1 and 2. As soon as you will put value 3, roots will keep on repeating itself. Roots will keep on repeating itself. So there are exactly n distinct roots of unity, and they are equally spaced on unit circle. So if you want to see nth root of unities, right? If you want to see nth root of unities, now z to the power n minus 1 will be nothing but a circle. Z to the power n minus 1 will be nothing but a circle. All its roots will lie on this circle and they will be equally spaced. Like you want to see this as well, right? This is what z naught is equal to 1. So this is nothing but 1 plus 0 iota. So this is sitting where? This is sitting here. The next root, that is this. It will sit at an equal distance from this, and the next will also sit at an equal distance. So the distance between these three, distance between the cube roots of unity, all the 3 roots will always be same, and this will form an equilateral triangle, and hence this will form an equilateral triangle. So the cube roots of unity forms an equilateral triangle in a circle. Next, fourth root of unity, if you will see, they will form a square. For the fourth root of unity, they will be at this point. The fourth root of unity. Yes, so they will be at this point. They will not form triangle, they will actually form rhombus. So this. So this will be your fourth root of unity. All the distances will be same. So they will form a rhombus. Then next, fifth root will form a regular pentagon, then hexagon, and keeps on going. So they are equally spaced on unit circle. This is your unit circle. This is a circle with radius 1, and your nth roots of unity are equally spaced on your unit circle. Now sum of all nth root of unity is always equal to 0. So what it says, if you have all nth root of unities, so it says 1 plus omega square plus dot omega to the power n minus 1, the sum will always come out to be equal to 0. So this is how we represent nth roots as 1 omega square till omega to the power n minus 1. So the sum of all these roots, sum of all nth roots will always come out to be equal to 0. So for cube roots, what you can say? For cube root, you can say 1 plus omega square will always be equal to 0. So this is the property that cube roots of unity will hold. Then next, product of all nth roots. Product of all nth roots is always equal to minus 1 to the power n plus 1. So in case of n to be 3, this will be minus 1 to the power 4. So product of all the roots, which means 1 into omega square, this will always be equal to 1. So product of all nth roots of unity will always be equal to minus 1 to the power n plus 1. And this is how we see primitive roots, which means exactly starting n plus n roots. So 1 omega till omega to the power n minus 1, where omega is your first root. Omega is your first root for value of k to be equal to 1. For value of k equal to 1, omega is your first root, and then all the roots are in that power. Omega square, omega cube till omega ki power n minus 1. So this is an important concept of nth roots of unity. Please practice this and see this very clearly. Now these are some important geometric loci. So important geometric loci, if a complex number has to represent a circle, so this will be of the form mod z minus z naught is equal to r, circle with the center z naught. So if this equation, if this is an equation given to you, what it means geometrically, this will represent a circle with center z naught and radius r. So questions sometimes directly come from these equations. So if you are given this type of equation, this represents a circle with center z naught and radius r. If you have mod of z1 minus z2 is equal to mod z minus z2, if this is given to you, you can directly say this is perpendicular bisector. This is a perpendicular bisector of a line which is joining the points z1 and z2. So let's say these are your z1 and z2. Let's say these are your points z1, z2, and it is given that mod z minus z1 is equal to mod z minus z2. So what it will mean, you will join this line. This modulus equation represents a perpendicular bisector. This represents a perpendicular bisector of the line joining these 2 points. So mod z minus z1 is equal to mod z minus z2 represents nothing. It represents this perpendicular bisector line. The next, Apollonius circle. This is nothing but a circle only. So this is a form of a circle. This is also another form of a circle in which mod of z minus z1 upon mod z minus z2 will be equal to some value k. Now here note that k should not be equal to 1. K should not be equal to 1. This will also represent a circle only in a complex number plane. Now straight line. If argument of this is equal to 0, where z1 is making an angle theta with the line joining z1 to z2. So a ray is drawn from z1 making an angle theta which is joining the point z1 and z2. If theta is 0 or pi, this is a straight line that is passing through z1 and z2 only. But if this is not equal to 0 or pi, this will represent a straight line. Then half plane. If real of z is greater than a, so this is your real line, this is your real, this is your imaginary. It says real of a complex number. So a complex number, real of z is greater than a. So a is some fixed value. So let's say this is your value a. It says real number of that complex is always greater than a. So this will represent this half of the plane. Real will always be greater than this value a. So right half plane, it means the right side half plane. The left side plane is left. So right half plane. And imaginary is greater, so upper half plane, which will represent the upper half plane. Similarly, if it was less, you will say left half plane and down half plane. All right. Now next, if mod of z minus z1 plus mod of z minus z2. So if this type of equation comes equal to some value k. Now this k has to satisfy this condition that k is greater than mod of z1 minus z2. So you are given two fixed numbers z1 and z2. You are given the modulus in addition, and you see the mod of both the numbers. If it is equal to some k and that is greater than this, then the locus of z. So these z points will represent what? This will represent ellipse with the foci z1 and z2. So this equation represents an equation of ellipse with foci at z1 and z2. Similarly, same equation, but in this k should be less than. K should be less than mod of z1 and z2. Then this will represent a hyperbola with foci z1 and z2. So both are same. In this only greater than and less than is difference. This will be ellipse, this will be the hyperbola. So these are important geometric loci and geometric features or geometric things that you can see for a complex number. Try this question, do this question. Your hint, directly apply rational root theorem. 1 line answer, 1 second answer, just you have to apply that rational root theorem. Just your answer will be done in 1 second. You have to just apply the rational root theorem that we studied in your quadratic equation. Apply it. All right. So yes, that's why I was asking you if I made a mistake there. So cos of, okay, this will not change to sine. This will be actually cos only. That's why I was getting confused. This will be cos pi by 3 only. And then cos of pi by 3, cos of pi by 3 is nothing but cos of your pi by 3 is minus 1 by 2. So that's why I was asking you again and again, because I was having a doubt here. This is nothing but this will be minus 1 by root 2 plus I times root 3 by 2. This is correct. This is root 3 by 2, but this will be minus half. Cos of 2 pi by 3 is nothing but minus half. Cos 2 pi by 3 is minus half. So this will be your first root of unity. Try this. Try this question. This will be just by rational root theorem. Yes, so in this question, what it says? It says this is a polynomial. That was true in your rational root theorem. All the coefficients Cn minus 1 till C naught, all are your integers, and this n value is greater than equal to 3. Does not matter. We have to tell which of the following statement is correct. Now in your rational root theorem, the coefficient of x to the power n was also an integer, but here it is already 1, which we know is nothing but an integer. So all the coefficients are integers. So all the coefficients are integer, and by rational root theorem what it says? If a is a rational root of this polynomial, so let a is a rational root. So let a is a rational root. So this implies a will be what? A will be p by q. It will be a rational number of the form p by q. Now what the rational root theorem says? Rational root theorem says p will divide what? P will divide your c naught. P should divide the constant term, and q should divide cn. Q should divide the coefficient of the highest power term. That is what your rational root theorem says. If it has a rational root, it should divide, the numerator should divide the coefficient constant term, and the denominator should divide the coefficient. So the denominator should divide the coefficient of the highest power. So from here, P should divide C naught and Q should divide 1, because the coefficient is 1 here. For Q to divide 1, this implies Q has to be equal to 1 only, because the only number that will divide 1 is 1 itself. So the rational number is of the form what? This is of the form A is equal to P. And where P will be what? P will be some integer. So if A is a rational root, then it must be an integer. So option D is correct. Did you guys understand this? Right, the answer is D. Next, try this. Omega is given to be the complex root of this quadratic polynomial. Omega is given you to be the complex root of this. You have to tell the value of this particular expression. So omega is root of x square plus x minus 1. Now from here you have to observe that when you expand x cube minus 1, this is nothing but x minus 1. This is nothing but x minus 1 x square plus x plus 1. So x cube plus minus 1 is nothing but this. So this is of the form x cube is equal to 1. X cube is equal to 1 is this. What are the roots of this? X cube is equal to 1 will be the roots. So this is what we want. So we want what? Roots of this particular expression. So from here I can directly say omega is, from here I can directly say omega is cube root of unity. Omega is nothing but your cube root of unity. Why? Because omega is root of this expression and that expression means root of this. So omega is cube root of unity, because the roots of this expression are what? Cube roots of unity. So omega is a cube root of unity. By the properties of nth root, I know 1 plus omega square will always be equal to 0 and omega cube will always be equal to 1. Sum of roots of unity 0, product of roots of unity equal to always minus 1 to the power n plus 1. Since this was cube root, so it will be equal to 1. So these are the properties that I know my omega will follow. These are the properties that I know my omega will follow. So you can write 1 by omega in some terms. So from here I can write this as omega into omega square is equal to 1. This implies omega is nothing but 1 over omega square. I can take the reciprocal. Also 1 over omega is equal to omega square. These are the two expressions. That I can form for cube roots of unity. Now this is in this pattern only. So what you can do? You can write this as Hello, hello. Okay, am I audible now? Am I audible to you all? Hello, am I audible to you all now? Mm-hmm. Tell me, am I audible now? Everyone, please. Those who are watching, tell me. Yes, the mic was discharged. I did not pay attention to that. I did not see that. But I changed the mic now. Is it fine now? Perfect. Okay. Okay. Okay, great. So did you guys hear this question when I explained you this? Were you able to understand this question? Please let me know. Otherwise, I'll move on. Yes, anyone. I'm moving on. If you don't understand this, please let me know. We'll come back to it again. So you have to consider the following subset in the xy plane. This is a set in the xy plane. Z is a complex number. You have to tell which of the following is correct. What this set S will represent. You have to tell what this set S will represent when your set S elements are of this form. So you have to tell what this will represent. So do nothing, just let Z is equal to A plus IB. This is a complex number. This is how we write it. So substitute it here. So your x coordinate will be what? Mod of A plus IB minus I times A plus IB. So this will be nothing but A plus B plus I B minus A. This is what this will open as when you will find this x. This is in xy plane. So this represents your x. This represents your y. So let's calculate the value of x. This is mod of this number. That will be nothing but under root a plus b square plus b minus a square. That is what the modulus of a complex number is. Mod of this will be this under root a plus b square plus this, right? So when you open this, you will get 2a square plus 2b square. This will be nothing but root 2 mod z. You can see this will be nothing but root 2 is taken common under root a square plus b square. That is nothing but modulus of z, because from here I'll get mod z as under root a square plus b square. Now what is your y? Your y is given to be mod z whole square. So from here I can say, from here my mod z will be what? Mod z will be x by root 2. This was your x. This was your x. Mod z will be x by root 2. So substitute the value. Y will be x by root 2 whole square. X by root 2 whole square. So y will come out to be x square by 2, or you can say 2y is equal to x square. What does this equation represent? What does this equation represent in the xy plane? What does this equation represent in the xy plane? This will represent a parabola. So your answer is S is a parabola. All right. Now let us come to your next chapter, which is your straight lines, and from here your coordinate geometry actually starts. So for the straight lines, so your distance formula, distance between 2 points A and B. Let the coordinate of A be x1, y1, coordinate of B be x2, y2. So the distance between 2 points is given by this formula. So this is your distance formula for two points. Now let's come to your section formula. Section formula means if a point P is dividing a line AB in the ratio m/n. This is for internal ratio and this is your formula, and this is for external ratio, and the formula is this. So this is what internal division means and this is what external division means in section formula, and this is your distance formula. Now area of a triangle. How you can find the area of a triangle? If you know the vertices of 3 points, let's say you have 3 points A, B, C. We want to find the area of this triangle. Vertices are x1, y1, x2, y2, and this is x3, y3. So you want to find the area of this triangle. So this is the formula to find the area of this triangle. This is the determinant form and this is the determinant form. This is in expanded form. This is normal determinant form. Also, what is the condition for coplanarity? Coplanarity means, sorry, collinearity. Planes are not in your syllabus. What is the condition for collinearity? So 3 points are said to be collinear. Collinear means they will lie on the same line. So 3 points A, B, C. If you want to check if they are collinear or not, just make the area of triangle equal to 0. Why? Because these 3 points will not form any triangle, so the area will be 0. So if 3 points are collinear, make area of triangle equal to 0. Then you can directly say 3 points are collinear. So just make area to be equal to 0. Next, slope of a line. How do you find slope of any line? So slope measure what? Slope actually measure how steep your line is. How steep of a line is. So slope measures the steepness of a line. So for a line passing through point x1 and x2, x1, y1, x2, y2. So let's say you have points x1, y1 and points x2, y2. So you want the slope. So slope is what? Slope is what? Subtract the y coordinates, divide by subtraction of your x coordinates. So this is your slope of a line, or rise and run, which means how much it is rising and how much your x coordinate is running. How much your y is rising? What does it mean by rise and run? So let's say this is your coordinates. By rise, it means how much this has risen up. And by run means how much this has run in the horizontal axis. And this is also seen as delta y by delta x. Change in y upon change in x. Change in y upon change in x. Also in terms of angle. So if you have a line, let's say this is your x-axis horizontal line and you have a line. This is a line on it. If this line is making an angle theta, with the horizontal x-axis, then slope is given by tan of this. So slope is also seen as tan of this angle theta. So slope of a line is also measured with the help of tan theta. Why? Because tan theta is nothing but perpendicular upon base. So when you will join this, this is, let's say, your x2, y2, and this is somewhere your x1, y1. So you can take these as parallel lines. So whatever angle it will form here, the same angle will be here. So y2 minus y1 upon x2 minus x1 will be nothing but perpendicular upon base only, which is your tan theta. So slope is also measured in terms of angle, which is tan theta, where theta is the angle made with the positive x-axis. That I already told you. Now equations of line. We will see different forms of equations of line. So first form is point slope form. Point slope form of a line, which means you will be given a point, you will be given the slope of that line. So what is point passing through x1, y1 with the slope as m? So what is the point slope form of a line? Y minus y1 is equal to slope times of x minus x1. So this is the slope form, this is the point slope form of a line. Next, 2-point form. You are given 2 points and then you have to find the equation of line passing through these 2 points. So this is same as point slope form. Now this is your slope only. This is your formula for slope only. This is nothing but your slope m only. So if you compare with the previous one, y minus y1 is equal to m times of x minus x1. This is same as the previous one. So this is nothing but same as previous one. This is passing through 2 points x1 y1 x2 y2. Third form, slope intercept form. What does it mean by slope intercept form? So let's say these are your coordinates. This is a line. So it says you are known, you have given the slope. So you are known with this angle theta. It is given to you, or you know slope of this line, which is m. And what is c? C is the point. C is the point where it will touch the y-axis. C is the point where it will touch the y-axis. That is called as y-intercept. Intercept means where it is touching that particular axis, the coordinate of that point. So C is the y-intercept, at which point it will touch the y-axis, the coordinate of that y point. So mx plus c. Intercept form. If you have known with what is your x-intercept, what is your y-intercept, then you can write as intercept form as x by a plus y by b is equal to 1. Then next form is your normal form or perpendicular form. How you see this? How you see this? So in this, you have a line. In this, let's say you have a line. All right. So what it says, P is nothing but your perpendicular distance from the origin to the line. So this is your origin. You draw a perpendicular to this line. So this distance is your distance P. P is the perpendicular distance from origin to this line. So this is the perpendicular distance from origin to this line. And alpha is what? Alpha is the angle that perpendicular makes with the positive x-axis. So this is your angle alpha, which this perpendicular line will make with your x-axis. So this is your normal form or perpendicular form. And any general form of a line can be seen as ax plus by is equal plus c is equal to 0, where a, b, c are any arbitrary constants. Now, angle between two lines. Let's say you have two lines. Let's say we have two lines. All right. This is your line 1. This is your line 2. This first line, let's say, has a slope of m. The second line, let's say, has a slope of m1, m2. So these are two lines with slope m1 and m2. We want angle between these two lines. So whenever you want to have the angle, one angle will always be an acute angle, other angle will always be obtuse angle. Or if they are perpendicular, both will be 90 degree. Otherwise, one will be always acute, other will be always obtuse. So by angle we only mean the acute angle. So this formula is for acute angle. What you do? Tan theta is nothing but the angle between two lines. So this angle theta, which is represented by theta. So this angle between two lines, this theta, will be what? Slope of first minus second upon 1 minus multiplication of slope of both the lines. So this is the formula for acute angle between two lines. If the lines are parallel, angle will be 0 degree. If the lines are perpendicular, this angle will be 90 degree. And then this is a very important identity or result, you can say, that perpendicular lines follow. Slope of both the lines, if they are perpendicular, will always be equal to -1. The product of slope of both the lines, if they are perpendicular, will always be equal to -1. Now next, perpendicular distance from a point to a line. So let's say you have a line. Where should I draw it? Okay, let me draw it here. So for this, let me draw it here. So let's say you have a point in your plane. Let's say you have any point in the plane. You want its perpendicular distance from some line. This is your line. This is your line. The equation of line is given by ax plus by plus c is equal to 0. So this is ax plus by plus c is equal to 0. Now you want the distance of this point x1, y1. So this point is x1, y1. You want the distance of this point from this line. So for distance, we draw perpendicular on it, and calculate this particular distance. So this is given by what formula? You just put the coordinates of these points in this equation. Put the coordinates of this point in this equation. This will become ax1 plus by1 plus c. Take the mod value, divide by under root of a square plus b square. That will give you the distance between the point and the line. Now similarly, distance between two parallel lines. If two lines are parallel, then you can find the distance between them. These are the equation of parallel lines. Their x coefficient will be same, y coefficient will be same. They will only differ by this constant. For parallel lines, please remember two lines are parallel. If their x coefficient and y coefficients are same, only they will differ by this constant C1 and C2. So these two lines are parallel. You can find the distance between them using this formula, C1 minus C2 upon under root a square plus b square. Alright, then next is your image and foot of perpendicular. What does it mean by image and foot of perpendicular? So let's say you are given a line with the equation ax plus by plus c is equal to 0. You have a line with this equation, then you have a point in your plane given to you as x1, y1. So you have a line, you have a plane, you want its foot of perpendicular. By foot of perpendicular, what you mean? You draw a perpendicular on this line from this point. You draw a perpendicular from this point to this line. So this is a perpendicular which is drawn from this point to this line. Now what does it mean by foot of perpendicular? Foot of perpendicular means this point Q. What will be the coordinates of this point Q when you will draw a perpendicular from a point to any line? This point Q is called as, foot of perpendicular. So when you draw a line perpendicular from a point to a given line, so whatever the coordinates of this intersection point will be, that is known as foot of perpendicular. So this is the method or formula by which you can calculate foot of perpendicular. So the foot of perpendicular coefficients, let them be x and y. Let the coefficient be x and y. Let the coordinates be x and y. X minus x1 upon a, y minus y1 upon b. This should be equal to minus 1 times of, you put these values in this. So ax1 plus by1 plus c upon a square plus b square. These are the formulas to calculate foot of perpendicular. Now what does it mean by image? Image means treat this line as a mirror. So you reflect this point in this mirror. When you reflect this point in this mirror, you will get a new point. Now you want the coordinate of this point, and this point will be your image. Now this new point is your image. To find the coordinates of this image point, do the same as above, do the same as foot of perpendicular formula. Just in here you have minus 1, here you just multiply it with minus 2. So only difference is here it is minus 1, here it is minus 2. So these are the two formulas to calculate image and foot of perpendicular. Now concurrent lines. Three lines are said to be concurrent if they are passing through a common point. So what does it mean by concurrent lines? Let's say you have line L1, let's say you have line L2, and you have line L3. They are called concurrent if they have a common point from which they pass. So this is the common point from which all the three lines are passing. So three lines are said to be concurrent if they are passing through a common point. And what is the condition? This should be true. The determinant of this matrix should always be equal to 0. If three lines are concurrent. And this is how the equation of three lines is given. First is a1x plus b1x plus c1 is equal to 0. Second line will be a2x plus b2y plus c2 will be equal to 0. Third will be a3x plus b3y plus c3 is equal to 0. Just put the values of a, b, c, a1, b1, c1, a2, b2, c2, and you will find if the lines are concurrent or not. Now this is the formula for angle bisector. What do you mean by angle bisector? So these are two lines given to you, L1, L2, and this is the angle. This is the angle that this line is making here, and this is also one angle that this line is making with this line. So we will get two angles. So angle bisectors. Why we write bisectors? Because there are two angles, so there will be two bisectors. Bisector means a line which divides the angle into two equal parts. So one line will be in this, one line will come from here. So first line will come from here. It will bisect this angle in two equal parts. I know it is not seeming to be bisecting. Alright. So this will bisect the angle in two equal parts. So this angle, this, let's say this is theta 1, this is theta 2. They both will be equal. So the work of this line is what? This is to bisect the angle between these two lines in two equal angles. Similarly, there will be a line here. There will be a line here bisecting this angle in two equal parts. So this will again be some theta 3, this will be some theta 4, which are equal. So we will get two angle bisectors. For two lines which are meeting at a point, we get always two angle bisectors. One will be bisecting one angle, another will be bisecting the other angle. And this is the general equation. This is the general equation for your angle bisectors. Angle bisectors will be nothing but two lines. So this is the equation for angle bisectors. One is with a positive sign, one is with a negative sign. And this gives two bisectors, again one for positive and one for negative. So one will be positive and one will be negative, and these will be two angle bisectors for any two given lines. Now how to deal with the locus problems? So how to deal with the locus problem? What does it mean by locus? First understand what it means by locus. So what happened was a point P. Let's say this is x comma y. A point P, x comma y was said you can move anywhere in the plane. You have freedom to move anywhere in the plane. Then after that, some conditions were applied to this point. It was said you can move anywhere in the plane. Then some conditions were applied to this point. Then it was asked that where you can go now. It was asked that where this point now can actually move when we have applied certain conditions or restriction to this particular point. So whatever direction, whatever places it can travel to, whatever curve it will trace, that is known as its locus problem. Whatever graph it will form, that is the locus problem for this particular point. So how we will do? Let the moving point be h comma k or x comma y. So this is your moving point. You can consider it to be x comma y or h comma k. Then express the conditions in terms of h comma k. So that's what I did. Whatever conditions will be given to you, whatever restrictions will be given to you, express them in terms of h and k. Then eliminate all the parameters. What does it mean by eliminate parameters? Eliminate all the variables, all the terms which are except h and k. Then simplify to get the relation between h and k or x and y. Then simplify it and you will find a relationship between x and y. So this is your required locus, and you are done. That will be your required locus. So some common locus which we will see. Distance from a fixed point. So let's say we have fixed a point. So you have a fixed point. So this is, let's say, a comma b. So you have fixed a point. You have fixed the distance from a fixed point is a constant. So what it says, this is a fixed point. Distance from this point will always be a constant value. And I know if I want the distance from this point, let's say this is my moving point. Let's say this is my moving point. Let's say this is my moving point P x comma y. Now if I have fixed this distance, I know I can only move in a circle. I know I can only move in a circle. So distance from a fixed point, if I have said it to be a constant, I can only form a circle. Now sum of distance from two fixed points is a constant. You should know that it will form an ellipse. Difference of distance is a constant, then you should know it will form a hyperbola. If distance from a point is equal to distance from a line, then it will form a parabola. And points equidistant from two lines will always form angle bisector. If two points are at an equal distance from two lines, they will always form angle bisectors. All right. All right. So try this locus problem. Try this locus problem. So what it says, a point P is in the Euclidean plane with A and B non-zero. So this is a fixed point in your Euclidean plane. So let's say this point P be A comma B. This is a fixed point. Then for any point S on the x-axis. So you want x-axis as well. So let's draw it. This is your x-axis and y-axis. S is any point on the x-axis. So let this your point S be here. So this is your point S. What will be its coordinate? Its y coordinate will be 0. Let the x coordinate be small s. So this will be the coordinate of this point S on the x-axis. Then P be the point of intersection of PS. So you have to join PS. So you have to join PS. And T is the intersection point of this with the y-axis, which means you have to extend it and meet it with the y-axis. All right, and it is said T is the point of intersection. So this point is your point T. Its coordinate, let it be 0 comma T. All right, because it will have no x coordinate. So this is what I can draw figure till now for my locus problem. Now next, what it says, let M be the midpoint of this line ST. So you have joined S to T and it is said M is its midpoint. So now somewhere will be your M. This is, let's say, M. Now this is your midpoint. You have to tell the locus of M. Since we have to find the locus of M, let this be H comma K. So let this midpoint have coordinates H comma K. So you have to find an equation in terms of H and K. I can see I am forming a straight line. I am forming a straight line. So for a line, I only have one thing which I can use is equation of a line passing through 2 points. So let's find equation of a line. So equation of line passing through P and S. Since all the 4 points lie on the same line, I can find equation of line using any 2 points. So let me use P and S. So what will be the equation? It says for 2 points, you have 2 points on this line. Equation of line says y minus y1 is equal to y2 minus y1. So b minus 0 upon x2 minus x1. So a minus s. So this will be your y2 minus, and then it will be x minus x1, which is your s. So this is what I have written as equation of line using these 2 points P and S. Now I know this line also passes through the point T. This line passes through T. So this passes through T, which is 0 comma T. So I can substitute those coordinates. So this will be T minus 0 will be equal to B upon A minus S. X is what? 0. So this will become minus S. So this gives me what? This gives me T is equal to B upon A minus S into minus S. Now I want it in terms of h and k. But I can see I have my parameters. I have two parameters, t and s. I have to replace these parameters with h and k somehow. So what we will use? We will use this midpoint. We will use this midpoint of st thing. So since h is m is the midpoint. Since m is the midpoint, I know its coordinate will be what? Its coordinate will be s by 2, and since k is also the midpoint, I know its coordinate will be what? T by 2. You can apply the section formula. This will be dividing it in the ratio 1:1. So when you apply the section formula, you find this coordinates, it will be s by 2, it will be t by 2. So from here, my s is what? S is 2h, and k is what? K is what? K is equal to, sorry, t is what? Now t is what? T is equal to 2k. So substitute s as 2h, t as 2k here. So when you substitute it, what you will get? This will give you 2k is equal to b upon a minus. It will be 2h, and this will be minus 2h. 2 and 2 cancels out. When you cross multiply, you will get ak minus 2kh will be equal to minus bh. So just take it to the left or right. You will find your answer is option number D. Because you can replace h and k by x and y also. You can replace this h and k by x and y. You will get option number D as your answer. All right. All right. Next, do this question. We will just do questions from your straight lines and then we will take a break. Let's do questions from your straight lines chapter, then we will take a break. So do this question. Do this question. What it says, A, B, C are three non-collinear points, M and N with a point on segment. So your graph is your complete graph, or your complete diagram is given to you. What it says, M and N are points on segment AB and AC such that line MN is parallel to BC. So you are given MN is parallel to BC. So suppose MB is equal to 1. So this distance is 1. Then Mn is equal to 3. Mn, this distance is your 3. Then Nc is equal to distance 2. Next, BC is equal to 5. You have to find the length of foot of perpendicular AX. You have to find the length of this foot of perpendicular AX. How you will approach this question? So since the first thing it says is this is parallel to this, I can see two triangles. I will apply my concept of class 10th. In triangle AMN and triangle ABC. We know since this is parallel to this angle will be equal to this angle will be equal to this, and this is a common angle. So these two triangles will be similar. So AMN is similar to ABC. I know these two triangles will always be similar. From here, I know ratios of side will be same. So AM upon AB will be equal to MN upon BC will be equal to AN upon AC. This is what my ratios of side will give me. Now let's see what AM will be. What AM will be. If I consider my complete AB to be equal to x, if I consider my complete length AB equal to x, AM will be what? AM will be x minus 1, because MB is 1 unit. So this will be x minus 1 unit. So this will be x minus 1 upon x is equal to MN is given to be 3, BC is given to be 5. And AN similarly, let this complete length be y. So AN will be y minus 2. So y minus 2 upon y. So we have equation in x and y, solve them. So from here you will get x minus 5x minus 5 will be equal to 3x. So you will get x as 2.5. From here you will get x as 2.5, and when you will solve for y, you will get y to be equal to 5. So your value of x will be 2.5, your value of y will be 5. So now I have this length, which is 2.5. I have this length which is equal to 5 units. So in my triangle ABC, I know length of AB, AC and BC. Now apply the area of triangle formula. So area of triangle ABC by Heron's formula that we already studied in 10th as well. This will be S minus A, S minus B, S minus C. You calculate the semi-perimeter S, find the area, and this area will be equal to what? This will be area will be equal to half into base into height. Now what is your base? Your base is 5. Your height is what? Your height is AX. Use the formula for area of triangle, what Heron's formula. For Heron's formula, calculate semi-perimeter. You have AB, AC and BC, all the values. Calculate semi-perimeter, apply in this formula, find the area, then you will have the value of AX. Because you have 2 as well, 5 as well, you only need AX. So just calculate the area, find the value of AX. And your answer will be option number B, 5 root 15 by 8. Your answer to this will be 5 root 15 by 8. Next, ABCD is given to be a square. It is of unit length. P and Q are points such that ABP and CDQ. So this triangle, these two triangles that are formed, they are given to be an equilateral triangles. So you have to tell the area of intersection of these two triangles. So you have to find the area of this blue part. You have to find the area of this blue shaded region. So we will solve this with the help of lines only. We will solve this with the help of our straight lines. So let the coordinate of A be 0, 0. Now since the length is unit length, so the coordinate of B will be 1, 0. The coordinate of C will be 1, 1. Coordinate of D will be 0, 1. We can see the coordinate system of ABCD easily. Let A be at origin 0, 0. So B will be at a distance of 1. So it will be 1, 0. It will be 1, 1. And this will be 0, 1. We will find the coordinates of PQ and let these points be R and S. So we will calculate the coordinates of all these points, then we will find the area of this region. So let's find the coordinates of point P first. So coordinate of P. So coordinate of P. Now since APB is a equilateral triangle. Now since APB is a equilateral triangle, I know height will be what? Height is, so this implies your height of an equilateral triangle, it will be root 3 by 2. The height of your equilateral triangle will be root 3 by 2. How you can calculate this? Draw a perpendicular. This angle is 60 degree. What will be your sine 60 degree? Sine 60 degree will be, let's say this point is some Z. So what will be it? It will be PZ upon AP. Now I know this is an equilateral triangle, so AB will be equal to AP, that is 1. And sine 60 is what? This is root 3 by 2. So PZ is equal to root 3 by 2. So my height is root 3 by 2. So this is at a height of root 3 by 2 from your 0, 0 origin. So its y coordinate will be root 3 by 2. What will be the x coordinate? When you draw perpendicular, these two triangles will be congruent, or you can clearly prove that these two triangles will be same. This and this will be equal. So Z will be at a distance of half from A. This will be at a distance of half, and since this is a perpendicular, so its x coordinate will be half. Similarly, for point Q, its x coordinate will still be half. For y coordinate, since this is also a height of root 3 by 2, from here till here, the height will be root 3 by 2. Now you want its coordinate from origin. So that will be what? That will be 1 minus root 3 by 2. So I have coordinates of my point P, I have coordinates of my point Q. I want coordinates of R and S as well. So for that, what you will do? I am just giving you the hint, you will solve it on your own. Now, R is what? You see here in the diagram. This is your B, this is your point, let's say P. This is your point C somewhere here. This is your point C. This is your point Q here. So what you can see R as? R is the point of intersection of these two lines joining BP and CQ. So how you will find R? R is point of intersection of BP and CQ. R is the point of intersection of this line B to P and CQ to Q. Now you have coordinates of B and P, you have coordinates of C and Q. Find the equation of how you will find this. So find equation of BP and CQ using 2-point form, using your 2-point form, and then find point of intersection R. Find R. Similarly do for point Q using AP and DQ. For Q using AP and DQ. Now this is the point of intersection of AP and DQ. So find the coordinates of point S using the intersection of these two lines AP and DQ. When you have all these coordinates, you can see your this figure PRQS. This is nothing but a rhombus, and area of rhombus is given by half into diagonal 1 into diagonal 2. So what is this? So area of PRQS is nothing but area of a rhombus. This is nothing but area of rhombus, which is given by half into diagonal 1 into diagonal 2. So when you have coordinates of RS, you have coordinates of PQ, you can easily calculate this distance, diagonal 1 distance. You can easily calculate this diagonal 2 distance. Evaluate, put the value, you will get your answer. You will get your answer, and it will be 2 by root 3 minus 1. How do you know AP? The coordinates of A are 0, 0. Coordinates of P are 1 by 2, root 3 by 2. So you can easily find the equation of the line using 2 points. You know this point coordinate. You know the coordinate of point P. So you can easily use the 2-point form of line and find the equation of line AP. Alright, Anup. You can easily find the equation of line AP using the coordinates 0, 0 and 1 by 2 and root 3 by 2. So like this, you will solve this and you will get A as your answer. Similar to the previous question, we will have this question. So let us consider the center of this circle as 0, 0. Let's consider the center of this circle at origin. What the question says? ABCD is a square inscribed in a circle of unit radius. So the radius of this circle is 1. ABCD is a square inscribed in it. E is a point on this circle such that ABE is a point on the circle such that AB is an isosceles triangle. You have to tell the area of intersection of this with the triangle ABE. So you have to find the area of this shaded portion. Again, we will find coordinate of AB and let this point is let this point is P, let this point is Q. So we will find coordinates of A, B, P and Q. Then we will apply the area of trapezium half into sum of parallel side into distance between them. So let us see how the coordinates will be. So if this is origin, if I join point A to C, if I join A to C, I know this angle is 90 degree, this angle is 90 degree, and any line joining with the center, if it is forming a 90 degree angle, so this has to be the radius. So AC is the radius, sorry, diameter. So AC is diameter of circle. Why? Because the line joining AC is forming a 90-degree angle on the circle, so which means AC is the diameter and it will pass from the origin. So AC is the diameter of the circle. So this implies AC is of unit length 2. Now this is a square. You can apply Pythagoras theorem. So you will get what? AD square plus DC square will be equal to AC square, which will be 4. So this will give you AD will be of length root 2. So the length of AD will be root 2. So this length is root 2. This complete length D to C will be root 2. This will be root 2. This will be root 2. All these lengths are of unit length. These are of length root 2. I have calculated the length of my squares. Now since this is origin, now consider this as coordinate system. If this is origin, A is at a distance of root 2 here. This complete length is root 2. When you calculate this and this, you will see this will form a small square only. And when you will see, so this will be at a point, this will be half of it. So this will be at a coordinate of -1 by root 2 comma -1 by root 2. Why? Because this complete length is root 2. This is the origin. When you will join this line, this will be of length root 2. So half of it will be at -1 by root 2 upon 1 by root 2, because you multiply it with 2. So this will be at 1 by root 2 comma -1 by root 2. C will be at 1 by root 2 comma 1 by root 2. D will be at -1 by root 2 comma 1 by root 2. So I know the coordinates of A, B, C and D. Now you want coordinates of P and Q. Now see, if you draw a perpendicular from E, on your AB, so this will be forming a 90-degree angle. This will also form a 90-degree angle here. So this particular point will be at an equal distance from A and at an equal distance from B. So this will be the midpoint of AB. If this is -1 by root 2, this is 1 by root 2. So the coordinates of this point, has to be 0 comma something alpha. So I know this line is lying nowhere, but this line is lying nowhere on this y-axis only. So my point E also lies on the y-axis. So its coordinate will be 0 comma 1. Why? Because point E is on the circle. It is at a distance of 1 from the center. So 0 comma 1, because point E also lies on your y-axis. So I know coordinate of E as well. Now form equation of line DE, CD, find the point of intersection Q, take AE and CD, find the point of intersection of P. You have coordinates of P, you have coordinates of Q, you have A and B. You have all the 4 coordinates. Then what you do? You just do that and apply area of trapezium. The formula for area of trapezium, which is half into sum of parallel sides into distance between them. So your sum of parallel sides will be what? Sum of parallel sides will be PQ plus 8B, and distance will be the same, which is root 2. So distance will be root 2, which is nothing but this AD only. This is the distance, same distance, the side of the square. So just calculate PQ and AB after finding the coordinates. Your answer to this is B, 4 minus 2 root 2. So let's take a break and we will start with your next chapter, circles then. Let's take a break, then we will start with your next chapter, circles. What time is it? 6:57. We will start again. We'll start again at 7:10. All right, break till 7:10. Yes, I know 7:10 हो गया. I was not able to find my phone. I put it somewhere. So yes, I am back. Are you guys back with me? Are you guys back with me? Yes, I know. 7:10 हो गया. I am here. All right. All right. So should we start with the circles? Let's start with the circles. All right. So, so what circle says? The introduction of a circle is equation of any circle with center a comma b. So this is a center which is a comma b and having a radius r. So its equation is given by x minus a square plus y minus b square is equal to r square. And with center 0 comma 0, what you will have? With center 0 0, your equation of circle is x square plus y square is equal to r square. So this is the general equation of a circle with center at AB and having the radius r. Now we will see general equation of circle in terms of a 2-degree equation. So this is the equation of circle in terms of a general 2-degree equation. So with this, when you compare and open this, what you do for this? Just square it, open it, and compare with this form. Just square this, open this, solve, compare it with this form. You will get the center for this general equation as minus g comma minus f. So this is nothing but representing a circle, but this is in a general form. It will have a center minus g comma minus f, and the radius for the general form will be under root g square plus f square minus c. So you have to do nothing for this. Just expand this, open it, compare it with this form. You will get your center as well as your radius. Now, equation of a circle in diametric form. So when you have a circle in diameter form, what it means? You are given the coordinates of the diameter of a circle. So you know the coordinates of diameter of a circle are x1, y1 and x2, y2. So your equation of circle can be written as diameter form as x minus x1, x minus x1, x minus x2. So what you do? You just multiply x minus x1 and x minus x2. Similarly do for y, add them, put them equal to 0. This is the equation of a circle when you know the endpoints of your diameter. So in this way you can find the equation of your circle. Next, what are parametric coordinates for a circle? Just as I told you in your complex numbers, this is your general circle. If this is any point x comma y lying on this circle. So the parametric coordinates are taken, or polar coordinates are taken as r cos theta, r sin theta. Why? Because if you see this, you will join this will form a right angle triangle. Now x is what? X is this distance covered. So when you apply the trigonometry, this will be what? Cos theta will be equal to your x upon r. So what will be your x? X will be cos theta into r. So that is what your x is, r cos theta. Similarly, this distance here will be your y. So when you apply trigonometry again with sin theta, you will get this y as r sin theta. So the parametric coordinates of a circle are r cos theta and r sin theta for this circle with center 0 0 and radius r. Now for the general equation of a circle, you will take x coordinate in parametric form as minus g plus r cos theta, and this will be minus f plus r cos theta. So just we change the center. So when center will be changed, now when your center will be somewhere here, this is somewhere, let's say minus g comma minus f. So your parametric coordinate changes as minus g plus r cos theta minus f plus r cos theta. Sorry, r sin theta. So you just take center with this minus g plus r cos theta minus f plus r sin theta. So that are the parametric coordinates for any general circle. Try this question. It says P and Q are the point of intersection of two circles C1 and C2. R be the point 1, 2. you have to find the distance of this point R from the line P and Q. This is a very easy question. This is a very easy question. I want you all to do it. I want all of you to do this. This is a very easy question. Now see what it says. P and Q are point of intersection of two circles. Now for circles to intersect, which means this equation for circle 1 should be equal to this equation of circle 2 at those point of intersection, because if circles are intersecting, that at these 2 points, if these are P and Q, they will satisfy both the circles equation. So I will equate them. I will equate the equation of both the circles. So I will get what? X square plus y square plus 2x minus y is equal to 0. Sorry, this should be equal to what? X square plus y square plus 3x plus 2y minus 3. Because both the circles are intersecting, so their equation should be equal at the point of intersection. X square cancels out, y square cancels out. What you are left with? You are left with x plus 3y is equal to 3. This is what your equation of the line, this is what the equation of your line PQ is coming out to be. The equation of line PQ is this. Now you want the distance of the point R from this line. So let's say R is any point in the plane. You want the distance, just apply the distance formula of a point from a line. Distance of a point from a line. For that, before you just write this in the form x plus 3y minus 3 is equal to 0. Always write your line equation in the form ax plus by plus c is equal to 0. Now just find the distance of that point. What does your distance formula says? Distance formula says take mod of value. What is the value of r? It is 1 comma 2. So 1 plus 3 into 2, this is minus 3 mod value upon under root 1 square plus 3 square. This will give you what? This will give you mod 4 upon root 10. So this will be 4 by root 10. So your answer is 4 by root 10. So correct option is option number D, 4 by root 10. What you have to do? Just equate them. You have to find the equation of line, then apply the distance formula of a point from the line. This was such an easy question. Now next, we will study various forms of tangent to a circle. So what happens is, let's say you have a circle, and you draw a tangent to it. Let's say we draw a tangent to it. What does tangent means? Tangent means a line that will touch the circle at only one point. So we want equation of tangent. If this is the center of the circle, the equation of tangent is fine with respect to this. We know the radius, when you will draw this line, the tangent, this will always make an angle of 90 degree. And it to intersect at one single point, the equation of line and equation of circle should satisfy at the single point. So from there, we get the condition for tangency as r root 1 plus m square. If you consider the equation of this line as mx plus c, this is your radius r. So let your center be 0, 0. Apply the distance formula, or you see what? It should touch it at single point. So equate it and put it in the circle equation. This is what you will get value of c as. In your equation of line, this will be your value of c, and this is your condition for tangency, and then this will be your equation of tangent. When center is 0, 0. This is your equation of tangent. Now when your center changes to alpha, beta, just subtract beta from y coordinate and subtract alpha from your x coordinate. Everything else remains the same. If your center is some alpha, beta, subtract beta from y, alpha from x, everything else remains the same. Next, how you can find, how this is a very important thing actually. First, let me tell you how you can find Cartesian form of tangent for any general curve. So this is an important thing. Please understand and learn it. A general second degree equation in x and y. So your circles, parabola, ellipse, every 2-degree curves, every 2 degree have x and y. So this is the general 2-degree equation. This is a general 2-degree equation in x and y. So we have this equation as a general 2-degree equation in x and y. If you want Cartesian tangent, if you want the equation of a tangent in Cartesian form, if you are given a point, what does it mean by Cartesian tangent? It means if you are given a point from which your tangent will pass. If you are given a point from which your tangent will pass on any 2-degree curve, then you can obtain that tangent equation. You can obtain the tangent equation by this substitution. You just replace x square by x1. Wherever you see x square term, replace it with x1 and replace y square with y1. So x will be a variable, x1 will be this point from where this tangent is passing. Similarly, y is a variable, y1 will be the point from where this tangent is passing. Wherever you see simple x, wherever you see normal x, substitute it with x plus x1 by 2. Similarly, y you substitute with y plus y1 by 2. Whatever term is with xy, this xy term, substitute it as xy1 plus x1y upon 2 and remain this c as it is. Let the c constant be as it is. Then you can find tangent to any curve. This is true for circles, parabola, ellipse and hyperbola as well. So you can find Cartesian equation to any of these curves with the help of these substitution and transformations. So let us do this question. Let us do this question with the help of your Cartesian substitutions. So what it says, consider the tangent line to this circle x square plus y square is equal to 1. So this is your circle, x square plus y square is equal to 1, which means it has a center at 0, 0. The radius of the circle is 1. You have to draw tangent at the point 1, 0. So 1, 0 will be here. So you want to draw a tangent at this point, and another tangent will be at the point 1 by root 2 and 1 by root 2. So this will be some tangent at the point 1 by root 2 and 1 by root 2. If you see, this points will satisfy the circle equation. So 1 by root 2 and 1 by root 2 will be points somewhere here. So 1 by root 2 and 1 by root 2 will be somewhere here on this circle. You want equation of tangents passing through these 2 points, and you want to tell the angle formed by these tangents. So let us first find the equation of the tangent. So let's find equation of tangent passing through 1, 0. So this is your x1, y1. Substitute the values of x square. What it says, replace x square with x1. So this is your x, x1 is your 1. Replace your y square with y1. Your y1 is 0. So this will be equal to what? 1. So equation of your tangent is x is equal to 1. Equation of tangent which is passing through this point is x is equal to 1, which is nothing but this is a vertical line. So this is your tangent passing through this point to the circle at that point. Let us find second tangent equation. So equation of tangent that is passing through what? That is passing through the point 1 by root 2, 1 by root 2. Now you want the equation of tangent that is passing through this point. So just substitute again. With x square you replace x1. So this will be x into 1 by root 2 plus y into 1 by root 2 and put it equal to 1. So this will be what? This will be x by root 2 plus y by root 2 is equal to 1. So when you solve this, what you will get? You will get x plus y is equal to root 2. So when you see, this will be what? Y will be equal to minus x plus root 2. So this is your equation of line. So this line will be somewhat like this. Now you can clearly see from the diagram the angle that they will make in this portion. This angle will be an obtuse angle, because here you see this is the angle that is formed to be acute. Now this is a line. This is again a line. We know angle between two lines, but we know for the acute angle. We know it for the acute angle. For obtuse angle, we will find it by subtracting with pi, because the complete angle will be 180 degree, that will be pi. So just find the acute angle, subtract and find the obtuse angle by subtracting with pi. So what will be the slope of this line? Since this is x is equal to 1, this is a vertical line. Since this is a vertical line, its slope is what? 90 degree. But when you have to take the angle between two lines, when you have to find the angle between two lines and one of the line is a vertical line, then what is the formula? So your theta will be what? Slope of second line minus pi by 2. So how do you find the angle, acute angle between two lines? If one line is a vertical line, so that will be slope of second line minus pi by 2. So this will be what? Slope of second line. Yes, slope of second line will be what? Wait. We calculate it by doing what? We do pi by 2 minus tan inverse of slope of that line. Pi by 2 minus tan inverse of slope of that line. So your pi by 2 minus slope of this line. Slope of this will be coming out to be pi by 4. So your angle theta will come out to be pi by 4. But you want obtuse angle. When you want obtuse angle, so obtuse angle will be 3 pi by 4. For obtuse angle, you do what? For obtuse angle, we take pi minus theta. So that will come out to be 3 pi by 4. So the angle that it will form will be 3 pi by 4. Alright, now let us come to your next topic, which is common tangents to circle. Very important concept, very important topic. A lot of questions is seen from this topic. So what is the common tangent to two circles? So when two circles are not touching each other, when they are distant, when they are apart from each other, so we can form four common tangents. And how these tangents will look like? The first tangent that you can draw will be this. Second tangent common, that will be like this. The third and fourth tangent common to these circles will be in this manner. It will go like this, touching this and this, both the circles. Yes, somewhat like this. And your fourth tangent will be this. So this will be your fourth tangent. So when two circles are apart from each other, you can draw four common tangents to both the circles. So four common tangents. The tangents which lie like this are called direct tangents, and which are on opposite sides of the center are called transverse tangents. So four common tangents, two direct and two transverse. What is the condition? If this circle has radius, r1, this another circle has radius r2, we can clearly see their center distance, the distance between center is greater than r1 plus r2. So distance between their centers C1 and C2 should be greater than the sum of their individual radius. Then only the circles will be then only circles will be not touching each other. They will be separated. Then when they are touching at exactly one point, when they are touching exactly at one point, how many tangents are there? There are 3 common tangents. When they are touching at exactly one point. So the first tangent will be this, second will be this, the third will pass from their common point. These are the 3 tangents that we can draw for the circle which is touching at exactly to one point. Both circles are touching each other at exactly one point. What is the condition? The distance between their centers, the center 1 and center 2. This portion is radius of first circle. This is the radius of second. And I can see the distance between their centers is always equal to the sum of their radius. So this condition gives that the circles are touching at exactly one point. Circles are exactly touching at one point, and that is true externally. Externally, they are touching at exactly one point, and the condition is sum of the radius should be equal to the distance between their centers. Third, 2 circles are touching each other at 2 points. Circles are touching each other at 2 points. In this case, we only get 2 common tangents. In this case, we are only able to find 2 common tangents, this and this. In this case, we can only form 2 common tangents to the circle. One will be up and one will be down. So they are touching each other at 2 points, and the distance between their centers. Now you can clearly see this is radius 1, this is radius 2. So the distance between their centers will be less than the sum of their radius, because the sum of radius will be greater than the distance between their centers, because this particular portion is extra. But it will be greater than the difference between their radius. It will be greater than the difference between their radius, R1 minus R2. The difference will be less than center distance, and center distance between both will be less than the sum of the radius. This is the condition for touching at two points for 2 circles. Next, when they are touching at one point now, but internally, when they are touching each other at exactly one point, but they are touching internally now. In this case, you can only form one common tangent. In this case, you can form one common tangent, and this will be your common tangent. In this case, you can only find one common tangent. In this case, you will find only one common tangent when they are touching internally. And condition for internal touching. Now, condition for internally touching. So let's see. See, this is the radius. This is the radius of your first circle. Oh God. This is the radius of your first circle. Let's say R1. And this is the radius of your second circle, R2. So the distance between their centers, you can clearly see the distance between their centers, this and this, is nothing but R1 minus R2. So the distance between their centers becomes what? R1 minus R2. So this is the condition for circles to touch each other at exactly one point, and that too internally. This was internally, and this was the case for externally touching. In this, it is R1 plus R2. In internally, it is R1 minus R2. So these are the conditions for internally touching and externally touching. Now when one circle is inside another circle, so you cannot have any common tangent, because whatever tangent you will draw for the outside circle, whatever tangent you will draw for the outer circle, it will never be a tangent to the inner circle. And whatever tangent you will draw to the inner circle, it will never be a tangent to the outer circle. So they have no common tangent. And now the distance between their centers will be less than the distance between their individual radius. It will be less than R1 minus R2. So these are the conditions for common tangents, and this is how we draw the common tangents and how we see the circles. Now do this question. Yeah, we have 3 questions. Do this question. Do it. So how you will approach this question? How you will approach this question? You can see clearly, this is an big circle, an external circle, a small circle is sitting inside it. It is touching this circle at exactly one point. It is touching this circle at exactly one point. So let the center of this circle be here. Let this be the center of this circle. So I know when I will draw a line from here like this. When I'll draw this line, let the center of this circle be, P. Let the center of the small circle be P, and let let radius of sigma, which is your small circle, let radius be R. So let the radius of the small circle sigma be R. Now its center we have considered to be as P. Now we can clearly see, this line AB. AB is tangent to this small circle because this small circle is like this and your AB line is like this. So AB is touching this circle at exactly one point. So this is a tangent to this. So when you will draw perpendicular on it, this will be equal to what? This will be equal to the radius R. Let's call this point as E. This P distance is equal to the radius R, and I know this will be my 90-degree angle, because to a circle, if tangent is touching at a point from center, if you draw a line, it will always be perpendicular to the tangent. So this angle is 90-degree. Now you can see a triangle OPE. So I have PE in terms of R. I want OE and OP in terms of R. Then my work will be done. Then I can use Pythagoras theorem and I can directly calculate R. So let's see what OE and OP can be. So OE and OP. So we want OE and OP. Let's see first OP. So OP is the distance from center of the big circle to the center of the small circle. Alright. Now the condition. Remember what the condition says? If two circles are touching at one point, the condition is distance between their center is equal to R1 minus R2. So the distance between their center O and P will be what? R1 minus R2. The radius of bigger circle minus the radius of small circle. And it is given that radius of your big circle is 1. Your radius of big circle is 1. So we know OP is what? OP is nothing but 1 minus R. Why? Circles touching internally at one point. So from the condition, I can directly say my OP will be equal to 1 minus R. Let's see what this OE will be. If I can calculate OD, somehow, I can see my D is nothing but, if you draw a 90-degree angle here as well. Why you can do that? Because this line CD also, you can see this is also a tangent. This is also a tangent to this small circle, because this CD is passing in this way. So this is how CD is joined. So CD is also a tangent to this circle. So this distance is also equal to your radius R. This blue distance is also your radius R. Your P is also R. This angle which it will form, this angle will be also 90-degree. So this will be formed as a square. So whatever this distance blue one is, same will be your distance DE. So your distance D is nothing but, distance D is your radius. Your distance from D to E is nothing but your radius R. Now I am left with to calculate OD. If I calculate OD, I can find OE as OD plus DE. So we have to find now OD. To find OD. OD. So you can see this is a triangle. This is a triangle. In this my OC will be what? 1, because this is the radius of the circle. This angle is given to be 60 degree. So just apply cos theta. So cos of 60 degree will be equal to what? It will be equal to OD upon OC. So from here I can find OD will be what? OD will be what? Cos 60 is 1 by 2. So your OD will be equal to 1 by 2. Now I have OD, I have DE. So what will be your OE? So your OE will be complete. Your OE will be equal to 1 by 2 plus R. Now I have OE in terms of radius. I have my P in terms of radius. I have my OP in terms of radius. Now just apply the Pythagoras theorem. So by Pythagoras theorem, what you will have? 1 minus R whole square will be equal to 1 by 2 plus R whole square plus R square. This is the equation that you will form in terms of radius. This is a quadratic equation. Solve it and find the value of your radius. Find this, solve this equation, find the value of your radius. Is it clear? Just solve this, find the value of your radius. I don't remember which is the correct option from here. I don't remember the answer as well. And I'm not solving it further. Solve this equation by Pythagoras theorem. Find a quadratic in R. You will find the value of your radius of the small circle sigma. All right. All right. All right, everyone. Sure. This is an easy question. Please do it as a homework. In this also, circles are touching each other internally at one point. So the distance between C1 and C2, C1, C2 will be equal to what? C1, C2 will be, okay, touches another circle with center at C2 and radius R2. C1, C2 will be your R2 minus R1. They are touching each other internally. And your C1T will be what? This is a tangent to this small circle. This is a tangent to the small circle again. So C1T will be equal to your C1T will be equal to your radius 1, the radius of the small circle. You have to tell the length of C2T. So again, for C2T, you know C2T square plus C1T square will be equal to C1C2 whole square. So again, applying the Pythagoras, you will find the value of C2T. All right. And I guess the answer for this was option number C. Yes, try it and solve it. You will find the answer for this. This is again the same application that we did in the previous question. All right. This question, let's do this one. Let ABCD be a square of side length 1. So ABCD is given to be a square. Length of this square is 1. C1, C2, C3 are 3 circles and they are inside the square such that C1 touches AB and AD, C2 touches BC and AB, and the C3 just touches the side DC. All right. Also, you have to tell that what will be the radius R if C1, C2, C3, all these 3 circles have the same radius, which is R. So you have to tell the radius, the value of this radius R. So how you will approach this? We will approach this with the help of coordinates. Let the coordinate of D be 0, 0. Then the coordinate of C will be 1, 0. Because the length of the square is 1 units. So coordinates of your point B will be 1, 1. The coordinates of A will be 0, 1. Now when you have coordinates of D, C, B, A, you will find the coordinates of center of C1, C2, C3. So let's say this is the center of C1, center of C2, center of C3. You will find the coordinates of the center of all the three circles. Let's see first C1. Let's first see C1. Now since C1 is touching this side AD, so this is tangent to the circle. This is tangent to the circle C1. And I know this will be perpendicular and this distance will be nothing but your radius R. Again, this is also touching AB. So this distance, this will also be equal to your radius R only. Alright. So this height is nothing but this height is equal to R units. I am from origin, this complete length is 1. From origin, D is considered to be as origin. The complete length till A is 1. So till the length C will be what? This will be 1 minus R. So the coordinate for Y will be 1 minus R. Similarly for X, this distance is what? X units. So from origin, you are actually at a distance of X units because this is also origin with reference point. So this is at a distance of R units. So the coordinates of center of circle 1 is R comma 1 minus R. Now coordinates of center of circle 2. So let's see this coordinates. Now again, this will be your radius R. This will be your radius R. Now if this is R, this particular part till here where the center is, it will be 1 minus R. So its X coordinate is 1 minus R. Y coordinate will be also 1 minus R because these are on the same line and the distance from here till here is 1 minus, from here till here it will be 1 minus R from the origin. So center is at 1 minus R, 1 minus R. Let us see the center of circle C3. So this is tangent to just the line this. So this is at a distance of R units. This is at a distance of R units from DC. Now this is your x-axis. This is your x-axis. It is vertically moving R units. So its y coordinate I know. Its y coordinate will be R. I don't know about its x coordinate. I don't have any idea about its x coordinate. So for the x coordinate, let it be equal to x. Let the x coordinate of this circle be x. You have coordinate of center of this circle and this circle. Also the extra condition that you know is, all the circles C1, C2 and C3, these are touching with each other externally. So this externally touching says distance between the center of C1 and C3 and distance between the center of C2 and C3. See the externally touching condition. The condition for externally touching at a point says the distance between their center should be equal to R1 plus R2. So the radius of this is this. The radius of this is what? Radius of this is R. This is also R. So C1, C3 will be equal to 2 times of R and C2, C3 will also be equal to 2 times of R. The distance between their centers both are equal to 2R. So equate them. When you will equate them, what you will get? Apply the distance formula. You will have C1, C3 is equal to C2, C3. Apply the distance formula with these coordinates. What will be? It will be under root R minus X square plus 1 minus R whole square. That will be equal to under root C2, C3. This will be 1 minus R minus X whole square plus 1 minus R whole square. Now you can take square root on both the sides. You can take square on both the sides to remove the square root. So this will give me R square plus X square minus 2RX plus 1 plus 4R square minus 4r. All right, this will be equal to 1 minus r minus x. Wait, did I make some mistake? All right, let's see. A square plus minus 2r plus 2rx. Then this will be what? Minus 2x. And this will be same term, right? Plus 1 plus 4r square minus 4r. This and this cancels out. 4r square 1, 4r square 1 cancels out. R square x square cancels out. And yes, so you are left with 4rx 4rx minus 2x minus 2r is equal to 1. Oh, I think we made some mistake here. I think I made some mistake. If you guys are able to see some mistake in this, please let me know. Let me know what mistake we made and how we can rectify that. What is the mistake that is made here? R minus x square plus 1 minus r square, that is fine. This is also fine. Can you find any mistake in this? When you will equate this, okay, try it on your own, please. I think there is some mistake, but this is a general method that will follow for this. When you will equate and solve this, I was getting my x to be 0.5. All right, and you can see as well, if you put x as 0.5, this will become what? This will become 0.5 minus r whole square. All right, and this will also be r minus 0.5 whole square. Then only these two terms will be equal. So this is a correct equation. I think I expanded this in wrong way. So when you will expand this and solve, you will find your value of x to be 0.5. And you can clearly verify that by putting the value of x here. This will give me r minus 0.5 square. This will also give me r minus 0.5 square. So both terms will be equal. So your value of x, the coordinate of x that I found is, this x coordinate is nothing but 0.5. This x coordinate is found out to be 0.5. Now again apply the same formula for any two. So what you will have? From here you will have r minus 0.5 whole square, whole square plus 1 plus 4r square minus 4r. That will be equal to what? That will be equal to the distance, which is your 2 times of radius. So you again find a quadratic equation in terms of r. This will be r plus 0.25 minus r plus 1 plus 4r square minus 4r is equal to 2r. This is again a quadratic in terms of your radius r. Solve it and you will find the value of the radius of this. You will solve it and you will find the radius of this small circles C1, C2 and C3. X can be, how it can be 1.3? You just solve this equation, you will find out the value of x as 0.5. I think I did some mistake in calculating this, but if you verify this, if you put x is equal to 0.5, this will be r minus 0.5 whole square plus 1 minus 2r square. This will give me this. And when you see this will give me 1 minus 0.5 is also 1 minus 0.5 is also 0.5, and that can be written as r minus 0.5 square plus 1 minus 2r square. So for 0.5 it is confirmed x is equal to 0.5 is verified value, but when you open this and solve, I think I made some mistake in that step. So you just verify that after solving you will get x as 0.5. Alright, so just solve this equation, you will get one of the value here. I don't remember again what was the answer to this question. So please solve this and see what is the answer to this question. Now let us come to your last chapter, which is your conic sections. In this we will cover parabola, ellipse and hyperbola. So let us quickly cover this chapter and see what it is. So introduction to conic section. So what was conics? How conics were introduced? So what happened was, so we considered a moving point pxy. Then it was said that fix a point S, that is called to be the focus. So the fixed point for any conic is called to be the focus. And also there was a line, and what it was said is, what the condition on this point was made is, the condition on this point was made that the distance of this point, from this fixed point PS, distance of this moving point from this fixed point S, divide by the distance of this moving point from this distance of the line. So the distance of this point from this and the distance of this point from this line, this will always be a constant value E. So this was the condition that was made on this moving point P, that distance of this point from this fixed point and from this moving line, this will always be equal to a constant value, which is E. And here E denotes what? This is your eccentricity of a conic. This is called as eccentricity of an conic. Alright, so this is your eccentricity of a conic, which was said that distance of this point from this to this will always be equal to a constant value, which is your eccentricity. So from here you can write PS is equal to E times of PM. So this was the introduction of conics. It said this moving point with a fixed point distance divided by the moving point from a fixed line distance will always be equal to a constant. Now this fixed line is called as directrix. This fixed point is called to be the directrix. Note that this focus, this fixed point should not be on the directrix, which means this point cannot fall on this line, directrix line. Alright, so this was the introduction of your conic section. Now let us see the summary of your conic section actually. What it means geometrically. If your point S, now what happens if your fixed point S lies on this line, directrix line. So this is your fixed point. This is your fixed point. This is your directrix. This is your fixed line, which is called as directrix. Alright. Now when this fixed point is lying on this line, the directrix line, you get pair of straight lines. What does PUSL means? It means you will get pair of straight lines. And if the value of E is what? E is same as PS upon PM. If your PS by PM, which is E, it is greater than 1, then the lines are two distinct lines, which means you will get two different lines. If E is equal to 1, if this ratio is equal to 1, then you will get coincident lines, which means you will only get one single line. If this is less than 1, then you will not get any lines. These lines will be imaginary lines. Now for conics, what happened? Same happened for the conics. In conics, again, you have your line, which is your directrix line. This is your point P, which is your moving point. This is your moving point. This was your fixed point. So if this does not lie on the directrix, then the distance of PS upon PM ratio was again seen. It was calculated and given to be a constant value E if E is greater than 1. Now if that ratio is greater than 1, it will represent a hyperbola. If the ratio of the distance between PS and PM is greater than 1, it represents a hyperbola. If it is exactly equal to 1, it represents a parabola. If it is between 0 and 1, it will form a shape of an ellipse. So this was the conic introduction. And in theory, this is the general 2 degree equation in terms of x and y. So every shape, hyperbola, parabola, everything comes from the 2 degree equation. You calculate this discriminant value. You calculate this delta value, the determinant value. What it is? It is A, HG, HG, BF, FC. How you can remember this? Take A, B and C. A, B, C in your diagonals. A, B, C is taken in diagonals. Then you put HGF like this and like this. Alright, so this determinant was calculated. If determinant comes out to be 0, it represents again pair of straight lines. In this case, point was line on the line. In this case, if your determinant is coming out to be equal to 0, it will represent pair of straight lines. Again, the condition for distinct lines, h square should be greater than 2ab. H square should be greater than ab, then this will represent two distinct lines. If it is equal, coincident lines. If it is less, then they are imaginary lines. And same case is for conics. If the discriminant is not equal to 0, if the delta is not equal to 0, these are the conditions to represent different conics. All right. Next, now this is your standard parabola and everything about your standard parabola that you must know. So these are your standard parabolas. Y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, and x square is equal to minus 4ay. I hope you know all the shapes of these parabolas, and these are the information for these parabolas. Please look at it and please read them, and you should know this by now. Alright, so these are the standard equations and standard things for your parabola which should be true. Alright, let's move on. So now shifted parabola. What does it mean by shifted parabola? Shifted parabola means first your parabola was with a vertex at 0, 0. So your general parabola, standard parabola is y square is equal to 4ax. And we know this parabola looks like this. Its vertex is at 0, 0. For this parabola, your vertex is at 0, 0, and this is a standard parabola y square is equal to 4ax. When you shift it, which means this was your original axis, you shifted it and you shifted it vertex at some point here, which is alpha comma beta. Originally, your vertex was at 0, 0. Now your shifted vertex is at alpha comma beta. And this alpha comma beta can be anywhere. It can be here as well. It can be of this form, any form. Then how you do it? Then your equation of parabola transforms that. You transform y to y minus beta. You change x to x minus alpha. If your vertex is at alpha comma beta, you change y to y minus beta, x to x minus alpha. So in this, it will be y minus beta whole square. Y minus beta whole square is equal to 4a x minus alpha. So this is the equation of your shifted parabola. So do this question from your PYQ. This is a question on parabola, and you can also use the theory of quadratic. Why? Because you can see parabola is nothing but a quadratic equation. Parabola is nothing but a quadratic equation in terms of y, So you can also use your theory of quadratic. And you can also use the concept of maxima minima. Maxima minima and application of derivative can also be used to see these points. Can you see this will be the maximum for this parabola? This will be the minima point for this parabola. For you can also use the concept of applications of your derivatives. Try this question. Try this question. So how you will solve this? I will use, for my ease, I will use my derivatives application, and I will find this point of maxima, I will find this point of minima. This is my point P, this is my point Q. So I will use my derivatives. For this parabola, I know my dy by dx will be what? It will be 2x plus b. Now it has a maxima or minima at the point where derivative is 0. So put it equal to 0. So your point x will come out to be minus b by 2. So this is your coordinate, x coordinate of point P. So this is your x coordinate of point P, which is minus b by 2. Now again for second parabola, dy by dx is equal to minus 2x plus d is equal to 0. From here, I'll get coordinate of my q as, my coordinate of q will be d by 2. So I know my x coordinate of point P, I know my x coordinate of point Q. You want what? You want the slope of line passing through P and Q. The slope of line that will pass through these 2 points. So what is the slope? What is the formula for slope? Either it is in angle form or it is in coordinates form. So let slope be m. Let slope be m. So by coordinate form, m will be what? M will be equal to yq minus yp upon xq minus xp. This is the coordinate form of your slope that you can find. Now you can see this point P and Q. P and Q is common to both the parabolas. P is also lying on this downward parabola. Q is also lying in this both the parabola. Similarly, for this upward parabola, which is in color red, P and Q lies on this parabola as well. So I can use equation of any one of the parabola and I can substitute and find the value of your y coordinate and y coordinate of Q and point P. So let me use this equation. Let me use this equation to find the y coordinates of these 2 points. So for Q, let's put it will be xq square plus b times of xq plus c. That will be the y coordinate of point Q. Then y coordinate of point P from this only. So this will be xp square minus bxp minus c whole divided by xq minus xp. xq minus xp. So when you see c cancels out, you can take xq and xp common from both. So xq minus xp, when you take common, you will get xq plus xp. This will give you what? Wait, what mistake did I make? Right, it will be plus b. Right, whole divided by xq minus xp. So when you cancel xq minus xp, you will be left with xq plus xp plus b. So your slope is nothing but xq plus xp plus b. What is your xq? Xq is d by 2, xp is minus b by 2. So just substitute. So d by 2 minus b by 2 plus b. You will get b plus d by 2 as your answer. When you find this, your answer will be b plus d by 2. So your slope is b plus d by 2. All right. So now next question. alpha is any real number, you have to tell total number of distinct points of intersection of the parabola, of this parabola with this pair of lines. From here, y square is given to be equal to 1. So you can say y is equal to plus 1 and y is equal to minus 1. So you have two lines, y is equal to 1 and y is equal to minus 1. You have to tell the point of intersection. For intersection, the equation should be equal. So just put the value of y1 in this parabola equation. So when you put for y is equal to 1, it will be 1 is equal to x square plus 4x sine alpha plus 6. Solve this quadratic, you will get x square plus 4x sine alpha plus 5 is equal to 0. When you will try to find out the roots of this quadratic, you will find the discriminant is always less than 0. So no roots. So from here you will have no point of intersection. Similarly for y is equal to minus 1. For y is equal to minus 1, what will have? Minus 1 will be equal to x square plus 4x sine alpha plus 6. When you will solve this, what you will get? X square plus 4x sine alpha plus 7 is equal to 0. This is again a quadratic in x. When you will try to solve it, your discriminant will come out to be, your d will again be less than 0. So from here also, you will get no roots. So both the equations gives you no roots, which means no point of intersection. So it will have 0 point of intersection, no point of intersection. Now these are your equation of tangents to these parabolas. So all you need to remember is the first one and the third one. Rest all can be derived from these first and third only. The parabola is y square is equal to 4x. The equation of tangent with slope m is what? Mx plus a by m. This is small m. So equation of slope for this, equation of tangent for this parabola with slope m is what? Mx plus a by m. And remember for this, x square is equal to 4ay. Your equation of tangent is what? Mx minus am square. Now if you have to move from here to here, what we did was, instead of a, we did what? Minus a. When you move from this equation to this, we did what? We just subtracted a. So instead of a, we took minus a. So in this also you take minus a. So this will be with a negative sign. And similarly, from here to here, we take with a negative sign of a. So you again take a negative sign with it. Negative will become positive. So this will become mx plus am square. Now when you have to move from here till this equation, from here to this one, so y is with minus beta, x is with minus alpha. So do same with here. Y with minus beta, x with minus alpha. This is nothing but y with minus beta, x with minus alpha, rest remains the same. Similarly, when you are coming from here to here, x with minus alpha, y with minus beta. So y with minus beta, x with minus alpha in this particular equation. Y with minus beta, x with minus alpha. So you have to remember just this one and this one. Rest all are the derived forms from this only. And these are the point of contact. Point of contact means the point at which the parabola and tangents meet each other. Let's say this is a parabola, this is a tangent. So this point at which they are meeting, this point has these coordinates for these parabolas equation. Now what will be your equation of normal? So for equation of normal, we have y square is equal to 4x. Differentiate it. You will get 2y dy by dx is equal to 4a. So your dy by dx will be equal to 4a upon 2y. I know my derivative also represents my slope. Dy by dx, my derivative also represents my slope. And the point P in parametric form, any point on the parabola can be written as 80 square comma 280. So your y point, this is your x, this is your y. So your y point is what? 280. So replace with 280. So this will be 4a upon 4at. So the slope will come out to be 1 by t. So the slope of tangent. So the slope of tangent in parametric form, comes out to be 1 by t. Now you want what? You want slope of normal. Now normal and tangents are always perpendicular to each other. So slope of normal, I know my normal and tangent are always perpendicular. So m1 into m2 will always be equal to -1. Let m1 be the slope of your normal. This was 1 by t. So this will be equal to -1. So from here I get my slope of normal as minus t. So here that is what it is written. Slope of your normal comes out to be minus t. Now you have slope, you have the point, you can write the equation of the normal. You have the slope, you have the point, at square comma 280, you can write the equation of normal. So what will be the equation of normal? So equation of normal, it is in point slope form. So that will be what? Y minus 280 will be equal to slope is what? Minus t, and x minus at square. So this is your equation of normal, which you can derive from equation of your tangent. Now let us move on to ellipse. So ellipse are of two types. Standard ellipse 1, which is of the form x square by a square plus y square by b square is equal to 1. In this, a is greater than 1. So how this ellipse looks like? This ellipse looks like this. So this is a horizontal ellipse. Horizontal ellipse when x coefficient, the term with x is greater than the term with y. So this is a horizontal ellipse. So in this, it is given by this standard equation, and this is the relationship between your a, B and E. E is what? E is your eccentricity of the ellipse. So this is an important relation. This is an important relation between B square, A square and E square for the horizontal ellipse. And in this, A is greater than B. And these are the things that you should know about your standard ellipse 1. And these are, let's say this is your focus, these are focus, then somewhere here are the directrix. So you should know everything about the ellipse from the diagram. Just read this and you will get to know. Then let us come to your standard equation of ellipse 2. So for standard equation ellipse 2 table, you have to do nothing. Just replace x with y and then replace a by b in your standard equation 1. And you will get the complete table for standard ellipse equation 2. It is also written as x by a square plus y by b square is equal to 1. In your textbook, it is written as x square by b square plus y square by a square is equal to 1. But here, I just left it like that so that you get no confusion and you can form the table easily by just replacing these values. Alright, so in this, the condition get reversed. Why? Because a is replaced with b. So wherever it was your a, it comes now b. Wherever it was b, so it will become a. And in this, b will be greater than a. In this, your b will be greater than a. And this ellipse looks like how? In this, your ellipse is a vertical ellipse. So this is how your ellipse will look like in this particular case. This is a vertical ellipse. And this is all about your ellipse. That are the important points to know. Now what is shifted form of ellipse? Or what is shifted ellipse? So before your ellipse is with center, 0, 0. So before your ellipse has center 0, 0, by shifted form of ellipse we means the ellipse get shifted and its center is now somewhere else. It can be here, it can be here, it can be here, anywhere. So its center changes just like the parabola. So now let's say its center is at alpha comma beta. Let's say the center moved from 0, 0 to some alpha comma beta. So what will happen? Replace x with x minus alpha, replace y with y minus beta. So for this ellipse, your standard equation was x square by a square y square by b square is equal to 1. For this, your standard equation will become what? Replace x with x minus alpha. So for this, your equation will become x minus alpha square by a square plus y minus beta square by b square is equal to 1. So what you do, just replace x with x minus alpha, y with y minus beta, wherever your center is moving for the ellipse. So this is how the this is how you can find the equation of a shifted ellipse. Now try and do this question. This is a question for your shifted ellipse form only. Shifted ellipse. Try it and do it. Try and do it and please tell me what will be the answer to this. Try do this question and let me know what is your answer. Yes. So what it says, this says an ellipse has the points 3, 2 and 7, 2 as the focus. So let's say these are your x-axis and your y-axis. Now your focus of the ellipse are at 3, 2 and 7, 2. So this will be somewhere your 3, 2 and somewhere here will be your 7, 2. So these are your focus for the ellipse. So how your ellipse will look like? This is how your ellipse will be actually looking like. Also, it says ellipse touches the x-axis. So let us make the new axis. Let us define your axis. So it says ellipse touches the x-axis. So your ellipse will touch the x-axis as well. Alright, so this touches the x-axis. So this is how your ellipse is actually like. It is having the focus at 3, 2 and 7, 2 and ellipse touches the x-axis. So you have to tell its eccentricity. So if it is touching the x-axis, let's say this is the center of the ellipse. Alright, so I know this is my focus 1, this is my focus 2. Now remember, the coordinates of focus for an ellipse are, for focus we have AE, 0 and for focus 2 it was minus AE, 0 in terms of standard ellipse. But here the ellipse got shifted. But the distance between focus will remain the same. Distance between focus F1 and F2 will always be equal to 2 times of AE. No matter your shifted ellipse or whatever form of ellipse, the distances are always preserved. So distance between these two focus, will be equal to 2 times of AE. So we can see the distance is 4. So from here you will get 2AE is equal to 4. Also, the center of the ellipse always is at a same distance from the focus. So your center will lie at 5, 2 because the center of the ellipse is at equal distance from both the ellipse. So your center is at 5, 2. Also, it says it just touches the x-axis, which means if you have to calculate this distance, since it is just touching the x-axis, this will be nothing but your length of your semi-minor axis. This will be nothing but your semi-minor axis B. So you can see from the x-axis it is at a distance of 2 units above in the y-axis. So I can clearly say from there my value of B is also what? 2. My value of B is what? 2. Now apply the relationship. The relationship says b square is equal to a square 1 minus e square. Now your b is 2, so this will be 4. This will open as a square minus a square e square. From here I know my value of a will be 2. So a square e square will be 4. So from here I will get a square is equal to 8. My value of a square will be 8. So just substitute this value in this. You take square here, a square e square is 4. So a square is 8. So e square will be 4 by 8. So your value of e is 1 by root 2. So your value of e is what? 1 by root 2. So the eccentricity for this ellipse comes out to be 1 by root 2. So your correct option is option number A. Now focal distance of any point on an ellipse. How you can find the focal distance of any point? Let's say your point P is on the ellipse. You have to find the distance PF1. You want the focal distance PF1. What does it mean by focal distance? The distance between any point on the ellipse from the focus. So that is the focal distance. So you have to find the focal distance P of F1. It is very difficult to calculate from this using distance formula. But I know PF1 upon PM1. This is always equal to a constant, which is eccentricity of the ellipse. Why? Because this is your moving point. This is your moving point. This is your fixed point, which we call as the focus. And this is your point on the directrix. This is your point on the directrix M. The distance between PF1 and PM1 will always be equal to a constant, which is eccentricity for this ellipse. So from here I can say my PF1 will be E times of PM1. So PM1. Now PM1 is easy to calculate. This is your PM1. You can easily see in your x-axis this distance from here till this line. It is A by E, because the equation of directrix is x is equal to A by E. So this distance will be A by E, and this distance from x-axis to this point, it is x. So distance PM1 will be what? It will be A by E minus x. So this will be E times of A by E minus x. So this will come out to be A minus EX. So focal distance from this point to first focus is A minus EX. Similarly for the second one. For the second one, you will have PF2 will be equal to E times of PM2. So your PF2 will come out to be E times of A by E plus X. So this will be A plus EX. This is because this is your X and this distance is your A by E. So total will be X plus A by E. So X plus A by E, A plus EX. So from here you can say and clearly see, if you add the focal distances, and take the mod value, because this can be positive or this can be positive, anyone can be, depending on where the point lies on the, ellipse. So take the mod value and add them. This and this will cancel out. This will always be equal to 2a. So the sum of distance of any point from the focus is always equal to the length of your semi-major axis. Remember this as a result. Sum of distance of any point from the focus is always equal to the length of your semi-major axis. Now, various forms of tangent to an ellipse. So this is your slope form of the tangent. If you are given the slope of a line, if you want to write the slope form of a tangent, it will be mx plus minus under root a square m square plus b square. So this is your slope form of a tangent on an ellipse. And Cartesian form can be derived by the general method that I told you. So you replace x square with xx1, y square with y1. Everything else remains the same. So Cartesian form can be directly found by using that particular method. Now try this question. It is based on the tangent. This question is based on the tangent. Try and do it in your homework. And the answer to this is option number D. All right, all right. So now various forms of normals to the ellipse. These are the various forms of normal to the ellipse. This is the slope form and this is the Cartesian form. So there are many results and formulas in your conic sections. So yes, this becomes sometimes hectic as well, but no problem. So this is the slope form. This is the slope form of normal. This is the Cartesian form of normal to the ellipse. We will see a question in your PYQ that is based on this form. So let us do this question. Let us do this question. This is on the normal. So what it says, let h comma k be a point on the ellipse x square by a square plus y square by b square is equal to 1. Now since a is greater than b, I know this ellipse is my horizontal ellipse. This is my horizontal ellipse. So the ellipse is a horizontal ellipse. So this is your ellipse. All right, the horizontal ellipse. H and K are any 2 points on this ellipse and it is given both are positive. So H comma K will be somewhere here. So this is your point. This is your point P with coordinate H comma K. Now what it says, focus of ellipse are F1 and F2. So let's say the focus is here F1 and the second focus is here F2. Now the normal at P. So we are drawing a normal at the point P. So there will be a tangent at this point. There will be a tangent at this point P, and then there will be a normal at this point P. And there will be a normal at this point P. Let's say this is the normal line. This is your normal line at point P. Question says the normal intersect the major axis at Q. We know this is your major axis for the horizontal ellipse. So it says it meets the major axis at the point Q. And you are given the ratio of PF1 to PF2. You are given ratio of PF1 to PF2. Your PF1 is what? Your PF1 is nothing but distance of this point from your first focus. So you are given PF1 distance of this point from this focus and PF2 its ratio. You have to tell the ratio of QF1 and QF2. So you have to tell the ratio of this QF1 and QF2. So you have to tell this particular ratio, what it will be, and you are only given the ratio of PF1 and PF2. How we will do this? So equation of normal. We will use equation of normal. So what does the equation of normal says? It says a square x upon, what is your equation of normal? Equation is a square x by x1. So from where it is passing? It is passing through h comma k. So it is a square x by h. See this equation, a square x by h minus b square y by k. So minus b square y by k. And this will be equal to a square into e square. So we have just used the formula for equation of normal. Now this says the normal intersect the major axis at Q. If it is intersecting the major axis, this is your x-axis, so its y coordinate will be 0. Its y coordinate will be what? 0. So put y is equal to 0. So we will get a square x by h will be equal to a square e square. So when a square cancels out, your coordinate of x is e square into h. So I have my coordinate of x as well, which is e square into h. So I have my coordinate of point Q. Now let us calculate the distance QF1 and QF2. So your QF1 Your QF1 will be what? This will be from origin to Q minus origin to F2. And I know my ellipse will be at focus minus AE comma 0 and this focus will be at AE comma 0. That is the standard. That is the standard result for ellipse. Alright, so let us calculate these distances. So these distances will be what? This will be E square H minus AE. We will take the mod value because we don't know Q is to the left of this or to the right of this. Alright, so this will be, we can take E common. This will be EH minus A. This will be EH minus A. Then QF2. This will be mod of E square H plus AE. Because the second focus will always be to this side. So this distance plus this distance. So this will be, you take E common, you get you get EH plus A. When you have this, take the ratio. E will cancel out. You will be left with what? You will be left with EH minus A mod upon EH plus A. So this is what the distance is. And I know this is nothing but PF2 upon PF1. So the ratio is 2 by 1. So the ratio for this will also be 2:1. So your answer is 2:1. All right. Now let us look at your last topic, final topic, which is hyperbola. Standard equation of your hyperbola is what? It is given by x square by a square minus y square by b square is equal to 1. And this is the again relationship between a, b and eccentricity. And this is your table for your hyperbola, which you can see. And how does hyperbola look like? Hyperbolas look like this. So these are your hyperbola. Don't say these are two parabolas making a hyperbola. No, this is one complete hyperbola. They are not formed by two parabolas. This is one complete hyperbola which is following this equation. All right. Then again you have standard hyperbola 2, which is of this form. Your standard hyperbola 2 is of this form. All right. And it is given by this particular equation. And same for this table. Replace x with y and replace a by b. You will find this table similar to the table of your hyperbola 1. Then what is rectangular or equilateral hyperbola? If a is equal to b in your hyperbola equation, what was your hyperbola equation? X square by a square minus y square by b square is equal to 1. If a and b both are same, so your equation will be what? Your equation will be x square minus a square and this will be a square is equal to 1. This will give you x square minus y square is equal to a square. So this equation also represents a hyperbola in which a is equal to b. So these are called as rectangular or equilateral hyperbola. This type of hyperbola is termed as rectangular or equilateral hyperbola. And the note point for this hyperbola is the eccentricity is always equal to root 2. So you don't need to calculate it, you don't need to do anything for its eccentricity. It will always be equal to root 2. Now what are conjugate hyperbolas? If you have a hyperbola equation x square by a square minus y square by b square is equal to 1, its conjugate is given by taking a negative sign. So this is the conjugate hyperbola. This is your conjugate hyperbola for this. Now if this hyperbola has its eccentricity E1 and this hyperbola has eccentricity E2, then there is a relationship between the eccentricities of these two hyperbola which is given by 1 by E1 square plus 1 by E2 square will always be equal to 1. You can equate them and see how you will find this equation on your own. It is very easy to see. So if this is your first hyperbola, so its conjugate is drawn like this. If this is your hyperbola, So this is its conjugate. So this is the conjugate hyperbola. Now focal distance, same just like we did for ellipse. Just like for ellipse, focal distance of a point on the hyperbola. So we have PF1 upon PM1 will always be equal to what? Eccentricity. So PF1 will be equal to E times of PM1. Now let us see what PM1 will be. So equation of directrix is again x is equal to a by e for the hyperbola as well. This is same for hyperbola. It is a by e. So this distance is now a by e, and this complete distance is your x1. So what it will be? This distance PM1 will be x1 minus a by e. So e times of x1 minus a by e. So this will be ex1 minus a. And similarly, when you will find PF2, it will be e times of x1, e times of this x1, this complete plus a by e. So this will be ex1 plus a. This will be ex1 plus a. Now when you subtract difference of the distance PF2 minus PF1 and take the mod value, it will give you what? This will cancel out, this will get added, this will again be equal to 2a. So this will again be equal to 2 times of a. So from ellipse we have sum, for hyperbola we have difference. Difference of distance of any point on the hyperbola from the focus is always equal to 2a. Now this is again equation of tangent in Cartesian form. Again you can replace x square by xx1, y square with y1. And this is the slope form for your tangent. This is your slope form for the tangent for the hyperbola. And similar to that, you have equations of normal in Cartesian form and equation of normal in the slope form. So this is equation of tangent, equation of normal in Cartesian form, equation of normal in the slope form. At last, let us do a one question from your hyperbola part. What it says, P and Q are the point of intersection of the hyperbola and this line. So did you notice they ask a lot of questions with point of intersections? So what you have to do? First, equate both the equations. So simply just equate both of them. So this is what? X square minus y square is equal to 5. Another equation from here I'll get y is equal to 5 minus 2x. So put this value of y in the equation of your hyperbola. What you will get? You will get x square minus 5 minus 2x square is equal to 5. So solve this, you will get x square minus 25 minus 4x square plus 20x is equal to 5. Just see this, this will be 3x square. This will be 3x square minus 20x plus 30 is equal to 0. Again, you get a quadratic. If you solve this, you will get 2 points of intersection of this hyperbola and this line. It is said 0, a is the point where perpendicular bisector of this line segment PQ. So point of intersection will be found from this. Let's say this is your hyperbola. And you have a line. All right. This is your point P. This is your point Q. You want AB be the point of where the perpendicular bisector of this segment PQ. So this is your line PQ. For perpendicular bisector, we need a midpoint. For perpendicular bisector, we need the midpoint of this line PQ. So now, P and Q will be what? P and Q, the x coordinates of P and Q, x coordinates of P and Q will be roots of this. will be roots of this equation. But we don't need to solve it. Why? Because we want the midpoint. So how you will find the midpoint? The midpoint, let's call it to be M. So you know bisection formula, the midpoint is coordinate of x plus coordinate of q upon 2. So midpoint coordinate, midpoint x coordinate, it will be what? It will be x1 plus x2 upon 2. Sum of roots by 2. You will find from here your sum of roots will be 20 by 3. Your sum of roots will be 20 by 3. So this will come out to be 20 by 6. This will be 10 by 3. So your x coordinate of this midpoint is 10 by 3. Now you want its y coordinate. Just equate in this line because this will satisfy the equation of this line as well. So y coordinate of the midpoint M, it will be what? 5 minus 2 into 10 by 3. So this will give you what? This will give you minus 5 by 3. So the y coordinate of this midpoint is minus 5 by 3. Now what? It says this meet the y-axis at this point 0, a. So for this perpendicular bisector, I have a midpoint. So this is your perpendicular bisector. I have a point on this line. If I get its slope, I can find the equation and then I can find this coordinate. If I have the slope, I will have this equation. So let us find the slope. Now since this is a perpendicular bisector, this will make an angle of 90 degree. So what is your slope of PQ? From here, slope of PQ. Slope of PQ is minus 2. Slope of perpendicular line will be what? Perpendicular line will be 1 by 2. Because the slope of a line with its perpendicular or normal is always equal to minus 1. The product. So slope of let's say this point is R. So slope of line RM is equal to 1 by 2. Now you have slope of this line is 1 by 2. You have the point on it, just equate it and write the equation of line by point slope form. So your equation of line will be what? Equation of perpendicular bisector. That will be what? That will be equal to y minus 5 by 3. So y plus 5 by 3 is equal to, slope is what? Slope is half. Half into x minus, the point is 10 by 3. So x minus 10 by 3. Now it meets the y-axis at the point 0, a. So this point is 0, a. Put the value of x as 0. So put the value of x as 0, you will get y plus 5 by 3 as, if this is 0, this will be 10 by 6. So y will be minus 10 by 6 minus 5 by 3. Did I make any mistake? (20 by 3 minus 5 by 3), it's fine. Y plus 5 by 3 is equal to 1 by 2. Slope is minus 2 only. Right, correct. So the slope of this will be half. Fine. So if you put it 0, this will be minus 10 by 6 minus 5 by 3. You take the LCM as 6. You will get minus 10 minus 10. This will be minus 20 by 6. That will come out to be minus 10 by 3. So the coordinate of this point, value of A is what? Value of A is your minus 10 by 3. Your option number A is your correct option. So see, you have to see the geometry, and in parabola, ellipse and hyperbola, mostly the question are asked when two curves or two something, a parabola or an ellipse or a hyperbola or a line, something is intersecting. So you have to just follow this general method and you have to see what question is actually asking. So that was all. This was all about your class 11th. We will see you soon for your class 12th Maha revision as well. If you have to say anything, please let me know. Otherwise, I'll just end the session. Thank you everyone for watching it and being with me. And coordinating with me and doing this Maha revision along with me. Yes, anyone wants to say anything, please let me know. Otherwise we are done for today. Your class 11th Maha revision is actually done. Anyone has to say anything, please let me know. Yes, anyone? Thank you everyone. Bye bye everyone. Have a good day. Sleep well and your exam is approaching soon. Don't stress out. Do your best and give your full. All right? Don't stress. Stress just kills everything. It will not give you anything. So be stress free and enjoy and be prepared for your exam because your exam is now very near to you. All right? Thank you everyone. Bye bye.